Welcome to our Python course designed to take you from zero to hero, from a complete beginner to confident professional Python developer. Whether you are just starting or looking to enhance your skills, this course is perfect for anyone aiming to master Python before diving into areas like machine learning, data science, or web development. We have organized the course into 12 chapters to guide your progress. So, we begin with the core basics: Python syntax, variables, data types, and operator. Then in chapter 2, Python string and collection. Here you will explore strings and essential data structure like list, tuple, sets, and dictionaries, crucial for organizing and managing data efficiently. Then in the chapter 3, control flow, you will learn how to make decisions and repeat action in your code with if-else statement and loops. After this, in chapter 4, Python function, and as you know, functions are the heart of reusable code. You will master everything from basic function creation to advanced concepts like recursion, lambda functions, and arguments. After this, in chapter 5, input and type conversion, you will learn how to interact with the users through input and effectively convert data types, and it is an essential skill for real-world application. Then moving to chapter 6, error handling, we will teach you how to handle error gracefully, making your code more reliable and professional. After this, in chapter 7, modules, package and library, you will expand your Python capabilities by learning how to use built-in models and create your own. Then in chapter 8, advanced Python concept, you will deepen your skills with an advanced technique like list comprehension, slicing, and understanding global and local space. After this, in chapter 9, object-oriented programming, we will cover key OOPS concepts like classes, inheritance, encapsulation, and polymorphism. And then in chapter 10, built-in function, you will know about powerful built-in Python functions that make coding easier and more efficient, from print function to enumerate and more. Then in chapter 11, string formatting and assertion, you will master formatting strings and using assertion to test your code's logic. Finally, in chapter 12, file handling, you will learn how to read from and write to files, a very crucial skill for working with data and building real-world application. So let's get started. I will show you how to install Python on Windows. So you need to visit the website python.org. And then you see here the section download, click on it. And after that, you will see here button to download the latest version of Python. So as you can see, the latest version is 3.12.6. Now scroll down and you will see here a installer package. So if you are using Windows 32-bit, download this version. Otherwise, if you have Windows 64-bit, download this installer. Click on this. Now your download will start. After downloading the Python installer, go to the folder or place where it is saved. To install Python, you need to click on this installer file. And now you see a installer window. So here you need to click on add python.exe to path. It will add a Python to your environment variable. Now click on this install now option. Now as you can see, Python is installed successfully. So let's verify it. To verify it, open a command prompt. Within command prompt, type python -version. And this command will show the version of Python that you have installed just now. And you can see here, when you hit enter, you see Python version 3.12.6. So you have successfully installed Python on Windows. Hey, if you are a Mac user and want to install Python, you need to visit the website python.org. Then you need to click on this download section, and here you will see download button for downloading the Python. So click on this button and it will start downloading the Python latest version on your system. Now after downloading the Python installer, click on this installer and you can see installer window opens. Here you need to click on continue, then continue, then continue, and here accept, agree, then click on install and provide the password for your Mac, and now it will begin installation. As you can see, Python is installed successfully. So let's go, close this window, move to the trash to the installer. Now open the command prompt or a terminal. If you don't see a terminal, go here in the launch pad and search for the terminal. To verify the installation, type here Python 3, then double hyphen version and hit enter. And as you can see, the Python version install is a 3.12.6. So this is how you can install Python on macOS. Now let's see how to install Python on Linux system. So here on the website python.org, click on download section, and then you need to click on the Linux option here. And after that, you need to click on this latest Python 3 release and just scroll down. And here you will see a version of the Python file. Here you need to copy this link, gzip source tarbell. So right click on it and copy the link. Then open the terminal on your Ubuntu or Linux system. And here you need to type a command wget. This command will download the Python on our system. Paste that URL that you have copied and hit enter. And as you can see, it downloaded the file Python 3.12.6 tgz, which is a archive format. So you will need to extract this archive format. So to extract this archive format, you're going to type the command tar-x, which means extract, then f, which means you are going to extract the following file. So here we are going to extract this file. So copy this and paste here and then hit enter. Now let's see the extracted file. And as you can see, we have this extracted folder Python 3.12.6. Now let's move to this directory cd Python, and you are in this directory. Now let's view all the file. So here to install this Python, specify ./configure, then specify -enable, then type here optimizations and hit enter. And then finally, you need to run the command sudo make install to install the Python. Specify the password, and as you can see, it's showing make command not found. When you see this kind of message like a make command not found, which means the make utility is not installed on your Ubuntu system. So to install it, you need to execute a certain command. First execute sudo apt update, and then execute the command sudo apt, then specify install build essential like this, and then hit enter, press Y. Now the make utility is installed. So clear everything and make sure you are in the directory Python 3.12.6. Now run the command .configure enable optimization and hit enter. Now after this, you need to run the command sudo make install and hit enter. Installation will take time, and after that, installing the Python version 3.12. To verify it, specify Python 3 then version and hit enter. When you hit enter, you see a message like this or output like this Python 3.12.6, which means you have successfully installed the Python 3.12 version on your Linux system. Now to enter the Python shell, you need to type here command Python 3 and hit enter. And if you see a 3 arrow like this, which means you are in the Python shell. And now here you can execute your Python command. Let's say I want to print hello world and hit enter. And as you can see, it prints hello world. So this is how you can install Python on Windows, macOS and Linux. In this section, I am going to show you how to create a Python virtual environment and activate this environment. And also I will show you how to install other third-party libraries that require you to run your Python. So choose the directory or folder wherever you want to create a Python environment. So here I have created a Python directory on my desktop. So I'm going to open this folder in command prompt So type here cmd. Then here we need to write a command to create environment. So write here Python, then -m, then venv, and this is the package that allows us to create, activate, or remove the environment. So write here Python, then -m, then venv, and after this you need to specify the virtual environment name that you want to create. You can give any name you want. So here I'm going to give name tutorial, or if you want you can specify here any of the name that you want. Then hit enter, and if you see something like this means you have successfully created your virtual environment named tutorial. If you are not sure, then view the files and folder of the current directory. So in Windows type dir, and now you can see here we have directory or folder tutorial. That means we have created virtual environment. Now we need to activate this environment. To activate this environment, specify dot, then slash. Remember, you are going to type this kind of slash, not this kind. So make sure you type this slash. Then here type the directory or folder name or environment name, and after this again slash, then type scripts, then slash, and then type here activate and hit enter. Now if you see your environment name within the parentheses, that means you have successfully activated the Python virtual environment. Now in this environment you can install a different kind of libraries or software dependencies. Here software dependencies means software or other package or other libraries that require you to run your Python program or code. So here I'm going to install the IDE Jupyter Notebook. To install that you can type here pip install notebook and hit enter. As you can see, it's downloading the Jupyter Notebook. So it is going to take some time. Now if you see output like this, which means you have successfully installed the Jupyter Notebook. To open Jupyter Notebook, you need to type here command Jupyter Notebook like this and then hit enter. So in your browser, it opens a Jupyter Notebook IDE where you can execute a Python commands or Python codes. So you will see a Jupyter Notebook interface like this. So here you are going to create a new Jupyter file. To create a new Jupyter file, you need to click here on a new button and then select the Python 3 IPY kernel, and then it opens new Jupyter Notebook with the extension. You can see here IPYNB. Remember this extension belongs to Jupyter Notebook. Now you can see here this is the cell where you can write your Python code that you want to execute. In this cell you can write a multiple line of code that you want to execute. So let's test it. Write here 4 plus 4, and to execute this cell, to execute this line or Python code, you can click on this run button, and as you can see it outputs 4 plus 4 8. Or what you can do here, you can write here 2 plus 2, and to run this code you can run shorthand command from your keyboard, shift plus enter. And this is the cell, and this cell can contain multiple Python code that you want to execute. For example, you can write here print hello world, and also you can write here print 5 minus 2, and from your keyboard press shift plus enter. We get error because we have not specified the parentheses. Now again run this cell, shift plus enter, and you get the output for the first line as a hello world, and for the second line 5 minus 2 equal to 3. You can also give a name to this notebook. So here I'm going to give a name Python tutorials and save this. Go here, click on file and click on close and shut down notebook. Click on OK, and as you can see it closes or shut down the notebook. If you want to also close this interface, then go to file and click on shut down. Then again click on shutdown, and as you can see, you are returned to the terminal or command prompt. As you can see here, your current Python virtual environment is tutorial, and if you want to deactivate this environment, you need to specify command deactivate like this and hit enter. Now you are exit from that environment. So to create a Python environment, you will need to type a command python -m venb, then the environment name that you want to create. After to activate this environment, you're going to type dot then slash tutorial scripts and activate to activate the created environment. And to install any package, you will need to type a command pip install, then the package name that you were to install in this environment. So we installed Jupyter Notebook. Then after installing Jupyter Notebook, we open the Jupyter Notebook and run some of the Python code. And to deactivate the environment, you need to type the command deactivate to exit from the current Python virtual environment. And you will see something like this, which means you are in the regular terminal or command prompt. Now from here, you can exit. That's it. And now you can see here your Python Jupyter Notebook file. And if you remember, we have specified name python tutorials.ipynb. So this is all about how to create a Python environment, activate the environment, install third-party libraries, and deactivate the environment. For the very first lesson, we are going to learn about Python syntax. As you know, in other programming languages like Java, C++, JavaScript, they have their own rule, and every programmer needs to follow that rule. If you not follow that rule, you will get error. You will get a syntax error. Similarly, in Python, there is a rule that you need to follow. For example, let's say if I print here a simple string hello world, and as you can see here we have followed a correct syntax, and if you execute this code, it outputs hello world, as you can see here. But what happens if I remove this parenthesis from here and execute this code? And as you can see, we get the error syntax error, which is saying incomplete input, which means we are not following the rules of Python. So whenever you are using a print function in Python, you need to specify double parentheses. First is the starting and second is the closing, and within this you are going to specify all the string variable, whatever that you want to output on the terminal. So this is the rule of the print function, and this print function is an inbuilt function in Python. If I remove here this is the code. If I remove here and again execute this, we get again syntax error, unterminated string literal, which means whenever we are using a string in Python, we need to enclose that string with a single quote, as you can see here. Otherwise, we are not following the syntax rule of the Python. Now I hope that you understand what syntax means here. And one thing here I want to show you that Python is a case sensitive, which means here we have used the print function, and as you can see here, each of the letter of this function is in a small letter. What happens if I change this P to a capital P and execute this code? And as you can see, we get the error, and here error is a name error, and you can see it is saying print is not defined. As I told you that print function is defined like this within the Python. So here we are using the correct name of the function. So when we execute this, we don't get the error. This is all about syntax error and name error in Python. So now let's move and learn about Python variables. Python variables are containers. This is the container which contains value, information, or data. And this value, information, data that we use throughout our program. So what will happen if I need a value again and again in the program? What happen? I'm not going to define the same value again and again. What I can do here, I can store that value in a variable and use that variable wherever required in our program. So for example, let's understand this. Let's say that I am going to print this a simple message saying hello. Then here I'm typing Tom like this and print this value. It prints hello Tom. Let's say again here I'm writing print hello, and here I'm saying John. Then again I'm writing print hello, and here I'm going to write cat. This is just for example. As you can see here, this hello string is used multiple times for a different person. If I print this, it's going to output a hello Tom, hello John, and hello cat. So instead of writing this hello string or this hello value multiple times, what we can do, we can create a variable named greeting like this, and we will store this hello value in this variable. So this is the variable greeting, and then we are using equal sign to assign to store the value in this variable named greeting. So instead of using this hello string again, what I will do here, I'm going to use this greeting variable. Right here, greeting, then again right here, greeting. And if I execute this, we get the same output. And we can change this variable value from hello to a different value. Let's say good morning. And if I execute this, you can see the output change. Good morning Tom, good morning John, good morning cat. So this is the work of the variable. Let's learn more about variable. You can store an integer value in a variable. For example, here you can specify a number and you can assign an integer value like a 2. Or create another variable named variable 1 and assign a decimal value like a 2.5. And you can use this variable in a print function to print the value which is stored in this variable, like a number and number 1, and execute this cell. You can see we get 2 and 2.5, which is coming from the variable number and number 1. There is some rule that you need to keep in mind while creating a variables. So remember, a variable name cannot start with a number. For example, if I type here 1, and as you can see, if I execute this line of code, I get the error, syntax error, invalid decimal literal. Here you can see variable start with a number. So we cannot do this. Also, we cannot use any special symbol like exclamation here or at, or also we cannot use this exclamation or at the end of this variable, because when you use this, variable is not valid. Python do not understand this kind of variable as a valid variable. But you can use the integer at the end of the variable, like here, it is still valid. Now you understand how to create variable and what are the rules that you need to follow to create variables in Python. In the upcoming section, you will learn about data types, and there you will learn about a different data type, different data like integer, string, float, boolean that you can store in the variable and use that variable throughout the program or perform a different operation. Remember, variable is container which contains value, information or data that you want to use or reuse again and again in your program. Okay, now let's understand data types, because it is very important concept. So you learn about variable, how to create variable, and one thing you need to know that variable can store data of different types, and the different types can do different things. And Python has the built-in data type. So let's see what are these data types. So first data type is a text type. So text type is a string type. You can create a string or text variable type. So let me show you, like here name, and you can assign a text or string value to this variable name like a James. As you can see, to create a text data type, you need to wrap the value with a single quote. So let's print it. Here write print and then name, execute this line, and you can see it prints the text James. You can also use the double quote instead of a single quote and it will still work. So let's print it again, and you can again see this is printing James. Also you can use the triple double quote. So like this, you're gonna use this like this, and if you print this, it will work. And also you can use the triple single quote. Let me show you. 1 2 3 and then 1 2 3, and let's print this, and you can see. So this is the text data type in Python. Now next data type is the numeric data type. There are two kind of numeric data type. First is the integer type, and second is the float, or you can say decimal type. So let's see. Let's say that I want to store a number which is the whole number, like a 20, and let's say that I want to store a price. So I can specify here price equal to 25.5, which is the decimal value. Let's print this two value, print num and price. Now you can see we have the variable num and price. Num is the integer type and price is a float or decimal type. Now next data type we have a sequence type. So in a sequence type we have the list. Let's say that you have a list of values or collection of values. So what you can do, you can create a list equal to, then within the bracket you will specify your collection of values. Like I want to store the integer value from 1 to 5. So I'm going to create this list 1 2 3 4 and then 5, and if you print this list, and you get the list of integer value from 1 to 5. As you can see, this is the sequence type. And remember, you can change any of the value in the list. You can remove the value, you can add a new value, like here specify comma and specify new value 6, and again print this, you get the 6. Now next we have the another sequence type, which is a tuple. So to store the tuple, you are going to use the parentheses, and within parentheses you can specify collection of values or list of values, like here specify 2 5 7. This is the list of tuple, and let's change the name like a tuple type, and let's print this, print tuple type, and look, it stores the integer of value as a tuple within the parentheses. But here I want to mention one thing about tuple, that tuple is unchangeable. So here in list you can add, remove or update the values within this list, but in tuple you can't do that. And tuple also allows a duplicate values. So this is all about sequence data type. Now next, let's see a mapping type. So mapping type. So in mapping type, you will have a key pair values. Let me show you, like a data, and here within the curly braces you will specify key. Key will be as a string, like here name, and the value can be any data type. Like here I'm going to assign a John as the name. Then we can have a multiple key value pairs. So here key as age, and the value will be 20. So you can also include a multiple key value pair or multiple data within the mapping type, and this mapping type is called a dictionary or a dict type. So this is the dictionary data type. Let's print the value, print data, and you can see. And if you want to know the data type of all these variable, what you can do, you can use here a type function, which is an inbuilt function in Python, which allows us to know the data type of the variables or object. So within this type function, if I will specify variable name, then it is going to show the data type of that variable. And as you can see, that data type variable is a str, which is a string, which is a text type. Let's also see the data type of this variable. Print type, then num, and then type, then price, and print this. Look, the type of the num variable is a integer, you can see here, and the type of the price variable is a float, you can see here. Also, let's check here, specify type, then tuple type, and execute this line of code, we get the error because we need to specify here parentheses. Let's execute again, and you can see the type is tuple. Let's also specify here type, then data. Execute this, we can see type is dict, which is a dictionary. Now next data type, we have a boolean data type. Boolean type means a true false value, like is active variable, and you can specify a boolean value like a true, or you can say has money equal to false. You can assign this false boolean value. Let's print the type, print type is active, print type has money. Let's execute this, and we can see the type of both the variable is active and has money has a full type. Now lastly, we have the type called a set type. So set is also used to store a multiple item in a single variable. Let's say I say users equal to, then within curly braces you can provide a multiple items. So for example, name is James, name is John, name is Rock. Similarly, you can also provide a different kind of value, like you can provide integer, you can provide a decimal. And this is just for example, I have given a variable name as a user. Let's change it, name it set type like this, and then let's print set type, and then also print its type, set type, and execute this. As you can see, this is the set which contains a multiple types of values. We learn about all these data type like numeric, text, boolean, map, and set, sequence. So let's understand each of these data type in much more detail. I'm going to start with a integer, and as you know, integer can be a whole number, it can be a negative or a positive value. For example, you can define variable age and you can assign a positive integer value like a 25. Then you can also assign a negative integer value. For example, you can specify temperature and it can be equal to -3 degrees. You can also perform a arithmetic operation with this variable containing integer. For example, suppose there is a variable a which contains a value 5 and variable b which contains a value 5. Now to perform arithmetic operation, type like this, print, and within print function, if you want to perform addition, specify variable a, then specify operator plus, which indicating that we are going to perform addition, and then specify second operand, which is b. So let's print this and we get the output as a 10. Now let's perform multiplication. Type here print a. To perform multiplication, you are going to use the symbol asterisk, and this means Python is going to multiply both this variable value. Let's print it and we get the output as a 25. Now let's perform subtraction. So type print, then a minus b. This hyphen symbol represent a subtraction, so Python will understand this as a subtraction operation. So let's execute this. We get 0 because when we subtract 5 minus 5 we get 0. Let's also perform a division. To perform division, you are going to use this slash. The slash represent the division. So let's execute this and we get as the value 1. So these are the basic arithmetic operations: addition, multiplication, subtraction, and division. And remember this symbol. Here you can see when division is performed, it returns a float value or decimal value. It does not return a integer value. So let's understand about this float value. And as you know, this float value can also be a negative or positive value So for example, you can define a percent variable which will contain a float value of 0.5, which means a 50%. Then you can define variable like a height, and you can store a decimal or float value like a 1.54 meters in height. Then what you can do here, you can also perform operations like you have performed with the integers. So here I'm going to define a variable like a, and which is going to store the value like a 0.5. You can also specify a decimal value like this. You don't need to specify like here 0 before this. You can specify like this and it is still valid. Then specify another variable b, and it's going to store value 2.5. Now let's perform all this operation. So what I will do here, I'm going to copy all this thing and paste here. Now execute this cell and we get this output. So when we add a plus b, and as you can see here, the value of a is 0.5 and the value of b is 2.5. When you add these two values, you get 3. Now when we multiply, we get 1.25, and when we perform subtraction, we get value minus 2.0, and when we perform division, we get 0.2 as output. So this is the float value, and you are familiar with how you can specify float or decimal value in Python. Now you are familiar with the two data types like integer and float, and also you learn about some of the arithmetic operators like addition, subtraction, division, multiplication. So these are not only the arithmetic operator, there are other arithmetic operators. Let's explore those. So here we are performing a division. So let's see this. So if I create a new variable number and which is equal to 5, and then create another variable named number 2 and which is going to contain a 3. Now if I perform a division here like a number 1 then divided by a number 2, we get this result. So as you can see, this is the float value 1.66. What happens, you want to round down this result, you want only 1, you don't want this decimal value, or you want to round down to only 1. So what you can do here, you can use the float division operator. Float division will look like this. So when you use a double slash, that means float division, and when you execute this, you get only 1. It rounds number down. So you can see you get only 1. Now next, let's see how to get the remainder. So to get the remainder, when we divide 5 by 3, if we use this percent symbol and execute this, we get the remainder as a 2. Because when 3 goes to 5, it returns a remainder as 2. So this is the percent symbol, and it is used when you want remainder while performing a division. We learn here two things. We learn about a float division, and we learn about the operator like this one, remainder operator. Let's execute the both. 1, 2. Now let's learn about another operator called exponential operator. So specify print number and use a double asterisk. When you specify double asterisk, which means it is a exponential, and if you here specify a number 2 and execute this, you get the result as a 1 to 5, because when a 3 is raised to 5, it returns a 1 to 5. So here if you multiply 5 into 5 into 5 3 times, you get the result as a 1 to 5, because it is an exponential operation, and you can perform exponential operation using this asterisk symbol. As you can see, this expression is little long, and you can make this expression very smaller, and there is a term called shorthand. Let me show you. Let's define variable here x and assign value 20. Now what you can do here, you can specify like x equal to x plus 10. So what this line will output, it is going to output 30, because as you know here the value of x is defined as 20, and when you add another 10 you get 30, and this variable will contain 30 as output, and you can make this expression smaller. So what you can do here, you can write this x, then here you are performing addition, specify plus, then equal to, and then specify the value that you want to add. So this value is equivalent to this value, this one. Remember, this one is equal to this one. So let's check it. So here I'm going to change the name. I will change this to x1, and here it should be x. This is okay. So it is equal to like this and this. Okay, so let's print it. Print and specify here x, and print this x1. Also here specify the value of x1 equal to 20, and execute the cell. We get the error because this one is not valid here. So here specify hatch output like this, and execute this. We get 30. So as you can see, this term x1 plus equal 10 is equivalent to this operation, as you can see here. So whether you are writing like this or writing like this, both is similar. So this one is called shorthand. So in Python, this is how you can perform arithmetic operation, and we have learned about different operator, like this is a division operator, multiplication operator, subtraction and division operator. And additionally we learn about like a float division, which round down the value. Then we learn about modulus operator, which is percentage, and it is used for getting the remainder while dividing the value. And then we learn about this double asterisk symbol, which represent a exponential operator. So this is all about arithmetic operator and how to perform arithmetic operation in Python. After learning the arithmetic operator, let's learn about a comparison operator. So what is comparison operator? These comparison operators compare two or more values and return a result as a true or false value based on the comparison. Suppose you have variable a which contains value 10 and you have variable b which contains value 20. And now if you want to compare these two variables, suppose you want to see if a is greater than b or not. So what you can do here, you can use the symbol greater than and then specify the second operand. So what happening here is a will be compared with b, and here Python will check if the a is greater than b. So this symbol is a greater than, and if we output we get false, because as we can see here the value of a is 10 and the value of b is 20. So here we are checking that if the a is greater than b. So as we can see 10 is not greater than 20, so this returns a false. Now let's change this, and here specify a, here specify b and check with a. So this line will compare if b is greater than a, and let's execute this, and as you can see this is true because the value of b is 20 and the value of a is 10. So b is greater than 10, which means 20 is greater than 10, and that is true. Now we have the next operator, which is less than. So if we here want to check a is less than b, we can specify symbol less than symbol. This is the less than symbol and it also returns true or false. Let's execute this, and we can see we get the output as a true, which means a is less than b, 10 is less than 20, you can see here. Now next we have another operator or comparison operator, that is a equal to, and which checks if two value is equal or not. So if I specify here a equal to b, and if I execute this code, we can see it returns false because 10 is not equal to 20. And instead of b, if I specify here 10, and if I again execute this, you can see we get the output as a true, which means a is equal to this 10 value because this variable contains value as 10. So this is the greater than operator, this is the less than, and this is the equal to. And there are some variant of this operator. Let me show you. So variants are greater than equal to, less than equal to, and is not equal to. So we have three variants, and let's see how to use this. So we have variable x which contains value like a 4 and have another variable y which contains the value 5. Now specify here x is greater than equal to 4. So here we are checking if the value x is greater than equal to 4. If we print this, we get the true. Here we are performing two types of comparison. First, we are checking that if the value of x is greater than 4. If that is not true, then it also checks if the value of x is equal to 4. So in second time, the value become true, so it returns the output as a 2. Now let's check this one, less than equal to, x is less than equal to y, and let's execute this, and in this case it is 2. First it is checking x is less than 4, and which is in this case is 2 because x is 4 and y is 5, so the answer will be 2. But in second case you can see x is not equal to true. That means it returns false. So in this case it returns 2. And lastly we have is not equal to. So x, then specifier is equal to y. And then print this, and you can see in this case we also get true. Because here we can see x is also not equal to y, because as you can see the x contain 4 and y contain 5. So 4 is not equal to 5. That means it is true. Now here instead of 4, if I specify 10, and let's see what happens in this case. Execute this and we get false, because as you can see x is neither greater than 10 or nor equal to 10. So in this case it is going to return false. Similarly, if you will specify here 20, not a 20, specify here 2 and execute this, we get a false result. Why we get false result? Because as you can see here x contains a 4 and we are comparing with the value 2. So in this case, as you can see, x is neither less than 2 or nor equal to 2. So this is the variance of comparison operator. Now next, let's learn about a logical operators in Python. Logical operators are used to combine two or more conditional statement or expressions. And there are three types of logical operators. First is an AND operator that returns true if both the statements are true. Second is the OR operator. OR operator returns true if any one of the statement is true. So you have a statement, if any of the statement returns true, then your whole expression will yield a result or will produce a result true. And lastly, we have the NOT logical operator, and this operator reverses the result, which means if any of the expression yield a result or produce a result as a false, then it reverses the result to true, and if the result is a true, then it reverses the result to false. So let's see in action how to use this logical operator. Now let's create a new variable named x and assign value 5. Here we will provide a two conditional statement. First, we'll check if x is greater than 3, and second, we'll check x is less than 10. And now if you print this, you get value as a true. So you can see here we have used the AND operator, AND logical operator, and you can see this is the first conditional statement and this is the second conditional statement. As you know, it returns true if both the statements are true, which means this is the first statement and this is the second statement, and in this case both statements are true, so this whole expression returns output as a true. If you are not sure, let's see it separately. So let's print here, print, I'm going to copy this, copy from here and then paste, and let's print one more time and copy this expression and paste here, and let's execute this, and as you can see we get true. So in this case here you can see x is greater than 3, which means 5 is greater than 3, and here you can see x is less than 10, which means 5 is less than 10, so both are true. And if you are confused how this AND is working, so from its definition it must return true if the both statements are true. So what I will do here, I'm going to remove this, and here I will write directly a boolean value true, and also right here boolean value true. So as you can see, this is the AND operator, and this is the first statement, it is true, and this is the second statement, it is also true. So the result should be also true. Remove these lines and again execute this, and you can see we get the result as true. Now what happens if any of the statement is false? So let's specify here false and execute this, we get false. So using AND, both of the statements should be true, otherwise you will get a false result. Now let's move and see how to use the OR operator. So in definition, you can see here it returns true, any of the statement is true. So for example, if I specify here print, and if I say x is less than 10 or x is greater than 10, and if I print this, as you can see, we get the result true, because you can see we have two statements. First statement is this, second is this. So what happening here you can see this first statement is true, but as you can see second statement is not true. But from the definition, you know, if any of the statement is true, then result will be true. So we get the result true. Now let's see how to use this NOT. And as you can see, it reverses the result, which means if we check here, if we compare this value, x is greater than 2, and if we execute this cell, we get here as output true. But what happens here, we want to reverse this result. So let's store this result into a variable. So what I will do here, I am going to remove this print. I am going to store the result of this expression into a y variable like this. And here I'm going to print y, and let's see, we get the true, that is okay. Now let's reverse the result. So here I will specify NOT, and to NOT I will provide this y. Now if I execute this, we get false. If you have any confusion, let me remove all these things. Okay, now here this statement returns true, because as you can see x is 5 here, and which is greater than 2. So this expression or conditional statement become true, and it is stored a boolean value true in the y variable. Now we pass this y variable to this NOT logical operator, and what it does, it converts these two values into false, and that you can see here in the output. If you are not sure how NOT logical operator is working, let me show you. So here I'm going to print, and I will specify NOT and directly pass the boolean value. So if I pass here true, then it will convert the true to false. So let's print it, and you can see it convert true to false. And instead of true, if I specify here false and execute this, as you can see, when we pass the false boolean value to this NOT, it convert that false boolean value to true. So now you understand NOT logical operator reverses the result. So we learn about integers data type and float data type, and also learn about operator. So let's learn about a string. So what is a string? A string is a collection of characters, or in Python it is a array of bytes, which is a Unicode character. So a string is a collection of characters, and it can be created using the single quotation, double quotation. That means you can use this single and a double quotation to create a string in Python. And you can display a string literal with a print function. For example, specify print function, and here within a single quotation specify your name. For example, I'm going to specify name James, and if I print this, as you can see, we get the string James. So you can see this James name is a collection of character, and as you can see, this string is surrounded by single quotation. Also you can create a string surrounded by double quotation like this. So this is double quotation, and specify the name James and execute this. This is the complete string, and you can also call it a element of a string. So J is the element of a string, A is the element of a string, M is the element of a string, and so on. And here you have used the single quotation to create a string, also you can see here double quotation is used. Both is same. There is no difference between whether you create a string with single quotation or double quotation. So here let me point out one thing. When a Python interpreter interprets this line, when it encounters first single quotation, then it thinks that it is starting of the string, and then it goes through all the character, and again if it encounters a single quotation, then it thinks that this is the end of the string, and this case also applies to a double quotation. Now here let's say you want to insert a quotes within a string. For example, you want to print a word or a string like this. You can see here it's, so here you can see this word contain a single quote. So how you are going to print this? Let's check with single quotation. Print and specify single quotation and specify its and then end of the string, and execute this, and as you can see we get the syntax error unterminated string literal. So as you can see that this quote is not working here, because when a Python interpreter interprets this line, it encounters first single quotation and it thinks that this is the starting of the string, and when it encounters this single quote, it thinks that this is the end of the string. But after this we can see we have this character as, and then we have again a single quotation, and which creates a syntax error. So how you are going to print this kind of word or process this kind of word in Python? So what you can do here, you can tell Python explicitly that hey, this is the quote within a string. Do not consider this single quote as the end of the string, and for that you need to specify a slash. Now execute this and you get the string it's containing is quotes. So this is how you can escape the single quote within a string by specifying a slash before that quote. Now if you don't want to include this escape, or you want result like this, what you can do, instead of the single quotation you can wrap your string in a double quotation. So here if you type like this, it's, and here you can see I have not used the slash and it will work. So let's print this line and look in the output, you can see it is working. So if you need to include a quotes within a string, use the double quotation. Now what happens if you want to include the double quotation within a string? So if you want to print like this, let's say here this is the word quote, and if you want to print like this, hello there, and let's see if it works or not. Let's execute this and we get the error. You can see invalid syntax, perhaps you forgot the comma. So you can see here when interpreter encounter this, it thinks it is the starting of the string, and when it again encounter this, then it thinks it is the end of the string. So as you can see, this double quote is not working within the string. So what you can do here, you can also escape this here and here, and now let's print this, and as you can see it is working. So as you can see, we can create a string using a single quotation and double quotation. You can also assign a string to a variable. Let's say here we are going to create a variable job, and then you can assign a string like a software engineer, and this string is assigned to this variable job, and you can access this string by referencing that variable. So within print function, if you specify job and execute the cell, you get the string software engineer. Now here, as you know, each string consists of a array of bytes or collection of characters. So here string contains element, and you can access each element, and remember the length of each character in this string is a 1. So here I'm going to show you how you can access each character or element of the string. So this is the job variable. So print like this, job, then square bracket, And if you specify 1 within a square bracket, then it is going to return the character at the index 1 within this string. So if you execute this, as you can see, you get the character O, which is at the second place. So you can see here, this whole string has an index, and the index of the first character within the string is 0, second character has index of 1, and third character has an index of 2, and so on. So if you specify here 0, you will be able to access the first character of the string, first element of the string, which is S. And if you specify here 7, you will be able to access the 7th element within the string. If you execute this, you get E, which is, you can see, the 7th character in the string. Now you can access the string. You can also create a multi-line string. As you can see, this is the single line string. You can create a multi-line string using 3 quotes. For example, you can write here a variable A, and you can assign a double quote 3 times, and then you can specify multi-line here. So you can say here, we are learning Python. Then in the next line, you can specify Python is most popular programming language. And then in this string with a 3 double quotation, 1, 1, 2, 3. And let's print this, print A, and execute the cell. And you can see we are able to print multi-line string or store the multi-line string within a variable. And to create a multi-line string, we used 3 double quotation mark at the beginning and at the end. Instead of this double quotation mark, you can also use the single quotation mark. Let me show you. Here, let's create another variable P, and instead of these double quotations, specify 3 single quotation like this, and print this P, execute the cell, and we can see we achieve the same result. So this is all about string data type in Python. You learn how to create a string, what are the quotation marks that you can use to create a string, how to insert quotes, how to access each element of the string using the bracket. Let's move and learn about Python collection. So in Python, there are 4 collection data types, and these 4 collection data types are: first is the list, second is the tuple or tuple, third is the dictionary, and lastly and last data type is a set. And you already know about these data types in Python, but we will learn about these data types in much more detail. So let's start with a list. So as I already told you, list is a collection of items, and it can contain different kind of items. For example, you can create a list and assign a multiple value or include a multiple value, like you can include integer, you can include a boolean, you can also include a string like a name of the person James, or you can include a float like a 2.5. And if you print this list like this, and as you can see, it contains all these different kind of items. So when you are going to create a list, remember you need to use the square bracket. You can see here a square bracket, and within a square bracket we have specified different types of elements separated by comma. So this is the structure of list, and this is how you create the list. You can not only access all the list element, but you can also access the each separate element that you see in the list. So list items are indexed. The first item has index 0. So here you can see the first item of the list is 1, and it has an index of 0. Second item has an index of 1, and third item has an index of 2, and similarly fourth item has index of 3. So for access each element, you can use the square bracket. For example, right here print specify list, then specify bracket, and within bracket specify the index 0, then close the bracket and execute this. As you can see, we have accessed the first element of the list, which located at the index 0. So this is how you can access each element of the list. Here one thing I want to mention, the item that you see in the list, these items are changeable, ordered, and can be duplicate items. Here changeable means you can add or remove the elements. So let's see how to do that. List has a method called append. So let's create a new list called users and store two users like a Tom and Bob, and print this user, comment out these lines. Now execute this again, and you can see the list user contain a two element of type string Tom and Bob. So list has a method. You can access it by specifying dot after the list and then specify the method append, and this method adds a new element at the end of the list. So this is the beginning of the list and this is the end of the list. So when you specify new element within this append function and execute this line, it adds the new element at the end of the list. Let's see, execute this, and now you can see it added a new user James at the end of the list. So you can append or add a new element in the list using the append method. Now you can also remove the element from the list. So for that, list has another method called remove, and just specify here the element that you want to remove. So here we want to remove James, and next print it users and execute it. You can see that James is removed from the list. So use the remove function when you want to delete any items from the list. So list is changeable. Now here list is ordered. This means that list has a defined order. So as you can see, the first element is Tom and the second element is Bob. When you add a new element, you can see this element James is added at the end of the list. It is not added between Tom and Bob, or it is not added at the beginning. It is always added at the end. So it has a defined order. Now lastly, let's see, list items are duplicate or they can be duplicate. So let's add one more item. So we have a Bob. Let's add another user named Bob. So specify here append and specify user Bob like this and print it users. Execute this, and now as you can see, this list contain a duplicate values, and duplicate value is Bob. You can also know the length of the list. For knowing length, you can use the len function. Suppose you want to know the length of the list user, you can here print like this, print, then specify len function, and within len function pass the collection whose length you want to know. So here length is the list users, and execute this. You can see we have 3 items in the list, or the length of the list is 3. You can see here. List has another method called pop method. This pop method removes the element from the end of the list. So using this remove method, you can remove a specific element or items from the list, but using pop, you can only remove the end of the element. For example, as you can see, currently our list contains 3 elements and the last element is a Bob. Let's remove it. So here we will need to only call the pop method on the list and then print the list users, execute the cell. You can see now we have only 2 elements. The duplicate Bob has been removed. So using the pop, you can remove the element from the end of the list. Now next, we have a method called a insert method. And insert method allows you to insert the items at a specified position in the list. For example, suppose you want to insert the new users between the Tom and Bob. So here you can see the index of Tom is 0 and the index of Bob is 1. Let's say you want to insert a new user at the index 1. So what you can do here, you will specify here users, which is a list, then dot, then specify insert method. And this method takes a two argument, takes two value. First value is the index where you want to insert a new item. So we want to insert at the index 1, and second is the element that you want to insert. So in this case, we want to insert username. So let's specify username John, and this John will be inserted at the index first. Let's print the users, execute it, and now you can see Bob is removed or Bob is replaced, and the item John is inserted at the index first. So here there is a mistake because this pop runs again and remove the Bob. So comment it out and execute this line, and now run this again. As you can see, we have the John at the index first. Let's learn next collection data type. Next collection data type is a tuple or tuple, and it is similar to list, but it cannot be modified once created. To create a tuple, you are going to use parentheses. For example, let's create a variable name person, and to create a tuple, you will use parentheses, and within parentheses you can specify different kind of data similar to a list. For example, you can specify your integer like 2, specify boolean, specify float value 5.6, specify string value like a James. Let's check the data type of this person variable. Print type, then specify variable person and execute this code. You can see the type is tuple. Here you can create tuple with one element. For example, let's say this is variable A, and if you want to create tuple with one variable, you will create like this, like a 2.5 value, and then specify comma, and this is the tuple with a one value. You can also include a duplicate value in tuple. For example, create a variable B and specify name James, and again specify name James, and print this B variable, and you can see now the tuple contains two duplicate values. You can also find the length of the tuple like a list. For example, print specify length function, and to this length function pass the tuple whose length you want to know, and execute this cell. You can see this tuple contains two elements, and the length of this tuple is 2. Lastly, if you want to create an empty tuple, then you will create like this, specify variable name, then equal, then use the parentheses, and this is the empty tuple. And if you specify type and specify variable name and execute the cell, you can see this is the tuple. And if you print the tuple C, and you can see tuple is empty. You can also access the value of the tuple. For example, at the above we have created person, and if we want to access any of the element, we can access through index like a list. For example, if we will specify here print person and then use square bracket, specify 2 and execute the cell, you can see we found the second element that exists in the tuple. So this is a very similar to the list, and tuple has a two method. First method is the count method. Now this method returns the number of times a specified value occurs in tuple. So for example, if you want to check the number of times James occur in this tuple B, you can specify here b dot count and execute the cell. We get error, so we need to specify here value James and execute the cell. You can see the James occur 2 times in the tuple B. So specify count function and then specify the value that you want to count in the tuple. And the second method is the index method, and this method searches the tuple for a specified value and returns position of that value. So for example, you can specify here b dot index and then specify the value whose position you want to find. Like I want to find the position of James and execute this. we got position of James is 0. And if we specify here a person, we have created this here, and if we execute this, we can see the position of James in a person tuple is 3. Similarly, you can find the position of any of the element, like I want to know the position of 1 in the tuple person, and if I execute this, we can see position is 1. So these are the two methods, count and index in tuple, and we can access the any element of tuple using a square bracket, and also you can create a empty tuple by using a 2 parentheses, and then you can also include a duplicate value in tuple. You can create a tuple containing a single value like this. Let's understand next collection called set. And set is used to store multiple items in a single variable. Let me show you how to create set. Suppose this is the variable my set, and to create a set you are going to use the curly bracket, and within curly bracket you can specify multiple data. For example, you can specify a string like apple. You can also specify here boolean value like a true or false. You can also specify here integer value like a 20, and lastly you can use the float or decimal value like a 4.5. So it can store multiple data. Now let's print this set, my set, and you can see this is the set. But here I want to show one thing. Set is a unordered. Why it is unordered? Because the item we have added in this set don't have any order. So here you can see when we print my set, you can see the first element is the true value. But when we created this set, you can see first element is the apple, second element is the true value, and third is the integer, and fourth is a float. But here you can see order is changed. So it is unordered. Set is unchangeable, which means you can't change the value of the set. It should be can't, but you can add or remove the items. So for example, this is the my set, and if you want to add a new element to this set, you're going to call the add function, and within add function specify the new element that you want to add. Suppose I want to add a new element here which is a string named John, and print this, print my set. Execute this. You can see we have added a new element. You can also remove the element. So to remove element, you will call the remove method, and within remove method you need to provide a value, and this value will be the set item that you want to remove. For example, I want to remove 20. Let's print this, print my set, and you can see the value 20 does not exist in this set. So this is how you can use the remove method. Again, remember, you can't change the value of set, which means you can't change any of the value in the set, but you can add or remove the new value. Now next, let's understand set does not allow duplicate value. Not allow duplicate value. In set we can't add a duplicate value. For example, you can see here we have a string apple. Let's try to add a apple again. So call my set dot add, and then specify string apple, then print this my set. Execute this, and you can see there is only one element named apple. Here when we try to add one more apple which is similar to existing one, but you can see there is only one, which means set does not allow duplicate element. You can find the length of the set. To find, you can use the method len here, and to this len function provide the set whose length you want to find, like this, and print it. You can see the length of the set is 4 because set contains 4 different types of element. Next method is the pop method. Pop method allows us to remove a random item from the set. For example, if you want to remove any of the random item from the set, just call the pop method like this and print the my set, execute the cell, and you can see it randomly removes item. So here it removes the item true from the set, you can see. So remember, use the pop method when you want to remove any of the item or any of the random item. Now the next method we have is a discard method. So discard method is similar to the remove method. There is one difference between a discard and remove. Let me show you. So difference is when you remove the item and the item does not exist in the set, then the remove method will raise error, but discard won't raise the error. For example, if I specify here my set dot remove, and if I specify here the element which does not exist in the set, for example, here I am going to specify rock, and as you know, rock does not exist in the set. And if I try to remove this element from this set, it shows error. Let's execute the cell and you can see key error rock because this element does not exist in the set. But instead of remove, if you use here discard, then this key error will not appear. For example, let's copy this one, paste here, remove this function, specify here discard and execute the cell. You can see it does not show any key error. It skips the error, only shows the element. So this is the difference between remove discard. Remove shows the error when element does not exist, where discard does not show the error. And there is one more method called clear, and this method empty the set. For example, if you print the set my set and execute this, you can see this set contains 3 elements. If you want to empty the set or remove all the elements, just call the clear method, clear function like this, and print the set my set like this, execute it, and you can see set is empty. So this is all the essential method of the set that you can use. Now let's understand about next data type, dictionary. So dictionary are used to store data as key value pairs. The structure of a dictionary is similar to set. For example, here let's create a dictionary mydict and specify the curly bracket. And now here instead of a single item, you are going to specify key value pair. For example, suppose a user have ID 1 and name is James. So you can specify ID as a key, then specify colon, and after this colon specify the name of the user, which is James. So you can see here before the colon we have key, and after the colon we have the value for that key. You can specify different types of key value pair or a different data type of key value pair. For example, you can specify age, which is a key in this case, and then specify value for this age, which is a integer, and this integer is the value 20. So see again, here you can see the key is a string, but here in this case you can see key is the integer. It's depend upon you how you want to create dictionary, but remember the syntax is you need to specify key value pair within the curly braces to create a dictionary. Let's print this dictionary, print my dict, execute the cell, and we have the dictionary. Now if you want to access any of the value like a James or the integer 20, you can access the value by specifying key in the square bracket. So this is the key age and this is the key 1. And let's access the value of these keys. Here to access specify dictionary, then specify square bracket, and within square bracket specify the key whose value you want to access. For example, here I want to access the value of key 1. I will specify key as 1 and execute the cell. And you can see we have the value James for the key 1. Let's again access the value of the key age, specify my date and specify age like this, and then execute the cell. And now we got the value 20 for the key age. In dictionary, there is a method called get method. So you can not only use this square bracket to access the value of the dictionary, you can also use this get method. Let me show you. So if you specify here like my date, then dot get and specify the key whose value you want to access. Suppose I want to access the value of key age. Specify like this and execute the cell. You get the value 20. So here I want to mention one thing. If you will not use a print function within the cell within this Jupyter notebook, then your code will also run. But if you run the same code on the terminal, like in a Python shell, it may not work. You can write this like print myDict.get and then execute this. Your code will run and you will get the same result. Now next, I want to discuss one more method called keys. And this method gives all the keys of the dictionary. For example, if you want to retrieve all the keys in this dictionary, you can specify here print then myDict.keys and execute this. You can see it return all the keys of the dictionary. Similarly, you can get all the values of the dictionary by specifying the values method. For example, specify print myDict.values and execute this. You can see we have all the values. Next, let's understand how to change the value of the dict. So to change the value of the dicts, you can specify here myDict. You can specify the dictionary, then a square bracket. Within a bracket, specify the key whose value you want to change. Suppose I want to change the age value to 25. I will specify here equal then 25. Remember, specify the key within a bracket whose value you want to change, then use the equal, then use the new value that you want to update. And let's print here print myDict and execute the cell. You can see now the age value updated to 25. So this is how you can change the value of the any key in a dictionary. Remember the syntax. In dictionary, you can also use the update method to update the value of dictionary. For example, if you print the dictionary, print myDict, and you can see the key one have the value James. And if you want to change the name, you can specify here print myDict.update, and to update you need to provide a key value pair as a dictionary. Remember this, within the update I am specifying curly braces, then I am going to specify key whose value I want to change and the new value that I want to update or that I want to assign to that key. So here new value is John, and now execute the cell and you can see we get the non because we print the dictionary while updating. But if you print this dictionary again, print myDict and execute this, you can see the value for the key 1 is updated to John. Now let's understand how to add the value to the dict. So to add the value to the dict, you are going to use the square bracket. For example, in this dictionary, you want to add the gender of the person. So here you can specify dictionary myDict, then a square bracket, and within a square bracket specify new key you want to add. So here new key we want to add as a gender, and then equal to and the new value for that key. So gender is a male here. And now let's print myDict. Execute the cell and you can see we have added new key value pair to the dictionary. The key is a gender and the value is the male. So you can use this syntax to add a new value to the dictionary. Similarly, you can also use the update method to add a new value. For example, specify here myDict.update, and within update specify curly braces, and within curly braces specify the new key value pair that you want to add. So new key is the country and the value for this is USA, like this. Let's print myDict and execute the cell, and you can see we have added new key value pair, key is country and value is USA, using the update method. Now let's understand how to remove the item from the dictionary. So to remove item from dictionary, we have the method called pop method. Suppose you want to remove the item country from the dictionary, you can specify here myDict.pop, and within this parenthesis provide the key that you want to remove with a value. So specify here country as the key, and next to it print the dictionary myDict and execute the cell, and you can see the key value pair country removed from the dictionary. Remember, use the pop method. Within pop method provide the key, the item that you want to remove. Similarly, in dictionary you can use the del keyword to remove the item from the dictionary. For example, if you want to remove the gender key value pair, you can specify here del, then specify here my date, then here specify the key gender and specify print my date and execute the cell. And look, the gender key value pair removed from the dictionary. So remember, to remove the key value pair, use the del keyword, and then you need to specify dictionary, then within a square bracket specify the key that you want to remove from the dictionary. Now lastly, I want to share one more method, which is a clear method, and this clear method empty the dictionary. If you specify here myDict.clear and next to it print the myDict, print myDict and execute the cell, and you can see the myDict dictionary is empty now. This is all the essential methods of dictionary. Let's understand Python control and flow. So in Python, control and flow refers to the order in which an individual statement or instructions or functions calls are executed or evaluated. Python provides several control flow statements that help developer define the execution logic of program. So these are conditional statements which contains if else, and if else. And the next is the looping statement which contains for loop, while loop. And lastly, we have the control flow keywords, and these keywords are break, continue, and pass. Let's start with the conditional statement. Conditional statement allow the execution of different blocks of code based on whether a condition evaluates to true or false. So the first conditional statement is the if statement. So for example, here create variable x and assign value 10. And now based on condition, you can execute a different code. For that, use the keyword if, and after the keyword if, specify the condition. So here condition is if x is less than 10, then we want to print x is smaller than 10, like this. So here understand this, we have used the if keyword, and after the keyword we have an expression or condition which evaluate to true or false. Remember, which evaluate to true or false. And when it becomes true, it execute this block of code, this line of code. And remember, before this line, there is a white space, and this is called indentation in Python. This is how we separate the blocks in Python. In other programming language, we use the curly braces to specify that these blocks belong to if statement. So in this case, this line print belongs to this if statement, and this block will be executed when this condition becomes true. For example, if you execute this code, you can see it is showing nothing because here this condition become false. So this condition will be executed when this condition gets true. So change this number and make it a 20, and now execute this, and you can see in the terminal x is smaller than, here specify 20, and again execute this. You can see x is smaller than 20. Why this printed out terminal? Because this condition become true. So if you print this condition, print x is less than 20 and execute this, you can see output is true. So when this expression become here true, this statement is get executed, and when this statement become false, this statement is not executed, that you saw. So now you can see when if become true, then it prints the block of code, but when if become false, it does not print anything on the terminal. So we want to show something user when if become false, and for that there is a keyword else that you can use with if. Let me show you. So write like if x is less than 10, then we are going to print this block of code, copy it from here. So this block of code is executed when if becomes true. What happens if become false? For that, use the else keyword. Else block code is going to executed when if become false. Specify here print, and then specify x is not smaller than 20. And when you execute this, you can see here this line of code is coming from the else block that we have specified here. So when you want to print something, when the expression become true, use that code in the if statement. Otherwise, for the false condition, use that code or block of code in the else statement. So this is how you can use the if else statement. But here you can see our condition is limited, and you can also see we can only execute two blocks of code, one from the if and other from the else. What happens if we have multiple condition, and based on multiple condition we want to execute different block of code? And for that there is one more keyword called elif that you can use with if else. Now for example, create a new variable x and assign value 15. Then specify if, and then condition if x is greater than 20, then we want to print a block of code like print, then specify x is greater than 20. Otherwise, if the condition become false, we want to specify another condition, and that you can do by using the elif keyword. Specify elif, then condition if x is equal to 15, then execute this block of code, and where x is equal to 15. Otherwise, if none of the condition is true, specify else. Then specify the else code, print, specify x is less than 15, like this. And let's execute this block of code, and you can see here it is showing x is equal to 15, and this line of code is coming from this elif statement, from this block of code, because this condition becomes true. Let's perform analysis. Here you can see variable x is initialized with value 15, and when it compares x is greater than 20, you can see here, and as you can see this statement become false. So when if statement become false, this block of code is not executed, and then it transfer the flow to this line of code here, and here it checks elif x is equal to 15, and that you can see here the value of x is 15. So this statement become true, so this block of code is executed, and so that it prints x is equal to 15. And otherwise, if any of the condition become false or become false, then else is executed. So here let's specify 5, and now execute this block of code, and you can see x is less than 15, because here you can see x value is 5. Now this condition become false, so this block of code is not executed. Then again this condition become false, so this block is not also executed. But here both the statement become false, so else block is executed. If you are still confused, you can specify multiple elif here. Elif if x is equal to 5, then here we want to print x is equal to 5, like this. And we have included one more elif with condition and statement. So let's execute this, and you can see here x is equal to 5, because this time this condition it satisfies. So similarly, you can use any number of elif statement within the if or else to specify multiple condition, to make a decision based on multiple conditions. And one thing here I want to mention, that behind the scene this expression is evaluated to true or false, which means here it checks if x is greater than 20, and this condition becomes false like this behind the scene. So behind the scene, if statement or Python sees it like this, okay, and when it sees false, then it skips this block of code and move to the next condition, and then again behind the scene it looks for the true false value. So this statement become true, then this block of code is executed. Otherwise, in case of false, next statement is evaluated. And I hope that you understand if else or elif, and you also understand how to build a conditional statement. Now let's understand looping statement. And as you know, there are two looping statements, for loop and while loop. But What looping means? Looping is a mechanism which enable iteration. So let's understand for loop. For loop allows us to iterate over sequence, and this sequence you already learned, and these sequence are list, tuple, set, dictionary, or it can be range, which we will learn. And here the term iterate means visiting each element of the list or any of the sequence or any of the collection, performing operation on each element of the collection or sequence. So first let me show you the syntax for the for loop. Specify for keyword, then specify the variable, after this specify in keyword, then specify the sequence, and then colon, and hit enter. And you can see there is a white space, and this represents the block of code from here. So here you will write block of code that will be executed for each element in the sequence. Let's understand this with an example. Here I'm going to create a list name users, and as you know, to create a list, specify square bracket, and within bracket specify users name James, Bob, Rock. And you can see this list or this sequence contains 3 elements, and you want to print the name of each of the users one by one. So here specify the for keyword and then variable, and this variable name can be any name you want to keep. For example, here I am going to assign a variable name as a username like this. Then in keyword, then your sequence, and here sequence is user. And after this colon and hit enter. And then you can perform operation for each of the element in the list or sequence. Here I'm going to print the name of each of the element. So I will specify here user name like this. And remember, this username or this variable name represent each of the element in the list that you see here. Let's execute this, and we get the error, expected indented block after for statement. So here comment it. Now execute this line of code, and we can see here the for loop iterated over the sequence or the list and printed the name of the users you can see. So here the term iteration means visiting each of the element in the sequence. So here sequence is the list. So this for loop iterated over the users list and printed the name you can see here. Let me explain flow of execution for you. So this loops picks one element from the sequence. So it picks first element, which is a James, from this user sequence, and this username variable holds the value of this sequence, and the value will be James. And then this code block inside the for loop executed using that value. And after that, this loop moves to the next element Bob, and then this username holds the value of the next element, which is Bob, and then it prints the Bob on the terminal or on the console. And similarly, it does the same task for the Rock. So this for loop process repeats until all the elements in the sequence are processed. Remember, here I have used the list users, but here you can use the dictionary, set, tuple, or any of the iterable object or any of the sequence. Now let's move and understand how we can use this with a different data type. So here I'm going to create a string hello. So I will create a variable word, and I will specify here hello, and then I'm going to run for loop for, I will say here character, this is the variable name, you can specify any variable name, in word. And if you remember, I told you in a string section that this string consists of characters. You can see here this H is a first element, this E is the second element, and this L is the third element, and so on. So you can access each element one by one of this string. So here print character like this, and when you execute this cell, you can see it prints each of the character from this string. So here this character represent each of the element in this string. Now let's understand about range function. So this function generates sequence of numbers. Suppose you want to generate a sequence of numbers from 0 to 4. So what you will do here, you will specify here range and then specify 5 within this. And this function will generate a number from 0, 1, 2, 3 and 4. If you count, these are the 5 numbers from 0 to 4. Remember here you have specified 5. 5 is exclusive or 5 is not included because it starts generating number from 0. So if you count 1, 2, 3, 4, 5. Now using the for loop you can execute a block of code repeatedly or many times. For example, let's create a variable x and assign value 20 and then start for, then give any variable name I, in range, and I wanna specify here 5. And remember this range function generate a sequence of number. And now here what I can do, I will print here x plus I, and this range function generate a sequence of integer. So this I represent each integer and then this I is added to this x which is 20. And if you execute this code, you can see the first value is 20, second is 21 and third is 22. So this is how you can use the range function to generate a range of number and then use the for loop to iterate over those range of number to perform some operations. And here one thing I want to mention, you can not only use here a print function, you can use any of the functions or you can use any of the statement that you want to execute within a for loop for the each of the element. Let's take one more example with dictionary. So here I'm going to create dictionary person and this dictionary is going to contain person detail. First is the name and name is James, and second is the age is 30, and third is the city which is New York. And now let's iterate over this person dictionary. So specify here for, then you can use any variable name as you know which represent each element of the sequence. So here sequence is dictionary. I'm going to specify user, then in, then sequence is here person, then colon and hit enter. And after this I'm going to print here person, then square bracket, and then within a square bracket specify user. So here user represent key of this dictionary. So here this user represent name key, age key and the city key. And as you know, in dictionary you can access element through the key that we learned in the previous section of the dictionary. Now execute the cell and you can see we can access the value of the each of the key in the dictionary. So once again this user represent the key of the only dictionary, and using key we can access the value of the dictionary. So here we have specified the key in the square bracket within the for loop. So I hope that you understand how to use the for loop, how to iterate over a sequence, and how it is helpful where you want to execute a block of code repeatedly. Let's understand about the while loop. While loop in Python repeatedly executes a block of code as long as given condition is true. Unlike the for loop which iterates over a sequence, the while loop continues until the condition becomes false. While loop is similar to the for loop, but difference is it iterates over a sequence until the condition becomes false, which means if the condition is true, then it is going to run or execute a block of code infinitely. So here I am going to write the syntax. First specify the while keyword like this, and after this you will specify the condition, and this condition will be evaluated to true or false. And remember, this loop will execute the block of code. So here you will write a code block that you want to execute. So this code block will be executed until the condition is true. As soon as condition becomes false, then this loop does not execute this block of code. Let's take an example. Here I'm going to create a variable I and assign value 1 or initialize with value 1, and then specify the keyword while to start the while loop. And after this, specify the condition I is less than equal to 5, which means you want to run this loop as long as I is less than or equal to 5. And in each iteration, you want to print the I, and also you want to increase the value of I by 1 in each iteration. So let me specify here, increment I by 1 in each iteration. And remember, this while loop will run as long as the I is equal to or less than 5. Now let's execute the cell, and as you can see, it prints I value 5 times. So this is the basic while loop. So what's happening here, we initialize I with 1, and then within while we specify condition. We are saying run this block of code like this to line until I is less than or equal to 5. So in first iteration, it prints the I, which is 1, and then it increments the I by 2. So here I become 2, and then it again compares with 5, and which is less than, so it executes this blocks of code. And this block of code is executed until the I is less than or equal to 5. As soon as I become less or equal to 5, then it executes this block of code, and after that, when I becomes 6, the condition I is the less than equal to 5 become false, so the loop stops. And this is how while loop work. Let's take one more example of counter. Initialize variable counter with value 10. Then specify while keyword to start the while loop, and specify the condition counter is greater than 0. And then print the counter value in each iteration counter, and also decrease the counter value by 1 in each iteration. Now here, let's execute this code, and you can see it prints the counter from 10 to 1. Now let's analyze this code. So this loop runs as long as the counter is greater than 0. Then it prints the counter value, the current counter value, and decrease by 1 after each iteration. And this while loop stops when the counter becomes 0. So you can see here, it prints the value 1, and after this, the 1 is decreased to 0 and the counter value becomes 0. And when it compares, counter is greater than 0, and you can see here, when counter becomes 0, 0 is not greater than 0, so this condition becomes false, so the loop stops. So this is how you can use the while loop in Python to execute a block of code repeatedly until the condition becomes false. Let's understand control flow statement. And as you know, these are break, continue, and pass. Let's start with break. Now break allows us to break the execution of the program or break the execution of the flow. So for example, I'm going to create a list number and assign a several number like 1, 3, 5, and 6. And here I'm going to run the for loop for I in number, and then I'm going to print each of the element from the list like this. When this loop runs, it prints all the elements. But at a certain point, you may want to break this loop. You may want to stop at this 5 element or exit the loop. Or maybe you want to stop at this element 3 and stop the loop or break the loop. That means you don't want to proceed after this element 3. For example, you can specify here condition if I equal to 5, then I want to break the loop. When you execute this code, you can see it only prints 1, 3, 5. It does not print the 6 because the loop stops at when I equal to 5. So this break keyword or break statement break the loops. If you specify here instead of 5 like a 3 and execute this, you can see it breaks the loop after the element 3. And instead of writing print function here, if you write here, it breaks the loop at 1. So execute this. Now you can see it only prints 1, and after that it breaks the loop and does not print all these element 3, 5, 6. So this is how you can use the break statement. Now we have the next control statement is the continue. So what it does, it skips the iteration. Remember, the break breaks the execution or flow, but it skips the iteration. So for example, I'm going to take this number list. Here I will specify for I in number, and then I'm going to print I, and which means it is going to print each value, and then I'm going to specify here if I is equal to 5, then continue. And let's execute this, and you can see here it prints all the number, but when you take this print and keep this print here, now again execute this, you can see it skips the element 5 from the list number. So you can see it skips the whole iteration. It does not execute this print I. So which means if you specify continue, then the block after this continue will not be executed or will be skipped, and it moves to the next iteration. You can see here. For example, if you will specify here like a 3 and execute this, you can see it skips the 3, because here you are checking if I is equal to 3, then continue, which means skip this iteration, which means don't execute this print I. And instead of this print, if you specify here, then this statement or this continue will not be effective, will not work here. Let's understand the next control flow statement, pass. And this pass statement is a null operation and it does nothing. So it acts like placeholder that allows you to write a syntactically correct code where a statement required but no action needs to be taken. It is commonly used during development as a placeholder when the actual code is yet to be written. So for example, you can specify here for I in range 5, and then you can specify here if I equal to 3, then pass, which means do nothing when I equals to 3. Simply I want to print here I and execute this. You can see it does nothing when I equal to 3. So this is just placeholder, and we use this in development environment as a placeholder. So this is all about break, continue and pass. So let me again explain. Break the execution or flow of the program. So when you execute this code, when it encounters I equal to 3, it breaks the loop or exit the loop. And in continue, if you want to skip the current iteration, then use the continue. The continue skips the current iteration and move to the next iteration. So here when I equal to 3, then it does not print the 3, but it prints the next element in the list. And lastly, you already know about pass, which is a null operation and it does nothing, it acts as a placeholder. Okay, now it's time to learn about a Python function, because till now we have run 1 line, 2 line or 3 lines of code, but sometimes we need to run some of the codes again and again to perform a specific task, or we want to run block of code to perform a specific action. So in Python, functions are reusable block of code that perform a specific task. You can think of them as a mini program inside your main program. So how we are going to create a function in Python? And there is very simple syntax that you need to follow. You can define a function using the def keyword followed by the function name and parentheses and specify the colon and then hit enter. And here we write the function body, which contains a block of code or the lines of code that perform a specific task. So for example, create a function to print hello. Specify def keyword to create a function, then specify function name. So here I am going to keep the function name greet and then specify parentheses, colon, hit enter. And you see here there is a space before this, and this space is called indentation. So to make the lines of code or block of code to the part of this function, we always use the indentation. So here you can write print hello like this. Now we define a function named greet, which contains a one line of code which prints hello string. So here the function name is a greet, and now defining function will not work. To execute the line of code that we have defined here, we need to call this function. So to call this function, we will simply write here greet, which is the function name, and then parentheses, comment it out this line. Now if we execute this cell, we get the output as a hello. So here remember, we are calling the function, and here we have defined the function. So defining function name greet. Now here you can use this function anywhere in your program as many times you want. You can call it again like this, you can call it one more time like this and execute this, and it is going to do the same thing, printing a hello string. If you will change something here, like if you say hello there, so whatever the changes that you made with the function will be applied wherever you call the functions. So if you execute this, you can see it print hello there. If you also print this, you can see it also shows hello there. You can see here this is the very simple function named greet which print hello there on the console. Sometimes we want to customize the function, or we want to provide own value and perform some action. So how we can do that? We can do that by understanding two things: parameters and arguments. So first let's understand what is parameters. So let's create a function def and name the function add, and this function will add two values. So here specify parentheses and then colon. Now this function can accept inputs called parameters, which are variables that hold values you want to pass into the function. For example, we want to add two values, so this function will accept two parameters x and y. So here x is the first parameter and the y is the second parameter, and as you can see, the second parameter is separated by comma, and you can provide as many as parameter you want, but here we want to work with two parameters. Then hit enter, and here we want to print x plus y. So this function accepts two parameters x and y. Then within function body we are printing the sum of these two parameters. So let's call this function here, call the function add and specify parentheses. But when you execute this code, it is not going to work because here x and y value is not initialized. So we need to provide value within this function. So when we call this function, we can provide those values, and those value is called argument. So here we can specify 4 and 5. So here x contains 4 and y contains 5, and then x and y is added and result is printed. Let's execute this, and you can see we get the sum 9. So here you need to understand two things: parameters and argument. Parameter is what you defined within the function's definition, and arguments is the value that you provide while calling the function. So you can also create another function called def, and you can name it subtraction and specify two parameters like a z and k, then colon and hit enter, and here it is going to print z minus k like this, and then call the function sub and provide the arguments or the value like 5 and 4. Execute this and we get the result as 1. Now next, let's understand about return values. So function can also return values. You can see here when we call the add function, this function takes two values and add those values and print the result on the console or in the terminal. But what happens, we want to return the result from this function. We want to perform addition, but we want to return this function result and store that result into another variable. And for that, function has a keyword called return. So we can modify the above function. We can call it add and then specify here x, y, then colon, and specify the return keyword and then x plus y like this. So when you call this function, it add the x and y and then return the result from this function. For example, here create a variable result which is equal to add and then call the function 4, 5 like this. And now let's print here result like this and execute the cell. You can see you get the result 9 because the result 9 is stored in the result variable, and this result is coming from when we call this add function by providing argument 4 and 5, and this argument is passed to the function add, and then this function add the value 4 and 5 and return the 9 result from this function. So this is how you can return the values from the function. Let's take one more example. Specify def keyword and create a multiplication function, and this time this function will accept a 3 parameter x, y, z, and then it is going to return x into y into z. Then store the value in the variable res mul equal to multiplication. Call the function, then provide a 3 argument or 3 values like 3, 4, 5. Next to it, print res multiplication like this and execute this. You can see we get the result. So this is how you can create a function that return values. So here when you call the multiplication function, you provide the argument, but here you can provide keyword argument, or you can pass argument by specifying the parameter name explicitly. This is useful when you have a many parameter. For example, you can call the function mul like this. Instead of writing 3 only, you can specify here x equal to, then y equal to, and then z equal to, and it is going to return the same result. Only here you have explicitly specified the parameter name while passing the argument. So this whole term is called keyword argument. Remember this. Now next, let's understand about default parameters. So what is default parameter? You can provide default values for a parameter. If no argument is passed, the default value will be used. For example, here I'm going to again define the function greet, and within this function I'm going to specify a default parameter, and here default parameter is name and the value will be friend, F-R-I-N-T, friend. Here let's print, and then I'm going to tell you here a new thing, string formatting. You can format the string with the print function. To format string, specify F, then specify quotation, and within quotation you can specify regular string like hello. And then if you want to insert the value of the variable like here name, specify here comma, then use the curly braces, and within curly braces specify the variable name or the parameter name whose value you want to insert within a string, and then close this quotation mark and print function. Now call the function here greet and execute this. You can see it prints hello friend, and as you can see this friend is coming from this default parameter value that we have specified here. We are not providing any value here, but what happens if we provide the value? Let's call the greet function again, but with the argument value. So here we are going to specify Bobby like this, and now let's execute this, and we can see here now this time it inserts or takes the provided argument or the value Bobby. But in the first case we have not provided any argument or value, so it uses the default parameter value. But in second case we provided the value, so this greet function use the provided value. So this is all about default parameters, and you can specify any number of default parameter within the function definition. Next, let's understand about arbitrary arguments. So what is the arbitrary arguments? If you don't know how many arguments will be passed, use the arbitrary argument to accept the variable number of arguments. And there is a syntax to accept arbitrary arguments. So here I'm going to create a function name print numbers, and within parentheses to accept any number of arguments specify here asterisk and RGS, and this RGS can be any variable name, but for simplicity I am specifying a parameter name or argument name as the ARGS. And then here I'm going to print the number for number in ARGS, and then I'm going to print each number, print number, then call the function print numbers and provide any number of arguments, as many arguments you want. So here I'm going to provide 1, 2, 3, and let's execute the cell, and you can see it prints provided argument value. So here you can provide any number of means. If I specify here 4, 5 and 6, then it will work fine. Execute this and you can see function is working, accepting and as many as argument you are passing. So this is the concept of arbitrary arguments in Python when using function. Next, let's understand about arbitrary keyword arguments, and this arbitrary keyword argument is similar to the arbitrary argument ARGS, but here we use the double asterisk and we call it arbitrary keyword arguments like this. So here I'm going to define a function describe person, and this function will accept arbitrary keyword argument. So I will specify here double asterisk keyword arguments and then specify colon. And here one thing I want to tell that when you provide arbitrary keyword argument, then this number of keyword arguments are passed as a dictionary. So here I'm going to use the for loop for key and value in arbitrary keywords argument dot items, then print key and value. So format the string, specify here key, then specify the value like this and end the quotation mark. And now here call the function describe person, and you can specify any number of arbitrary keyword arguments. For example, I will specify here name equal to Bobby, age equal to 25 and country equal to USA like this. Now execute the cell and you can see we get the dictionary. When you provide arbitrary keywords argument, then use the double asterisk like this within the function definition as a parameters. And when you call the function and provide any number of arguments, then these arguments are passed as a dictionary. So here we are calling the for loop and we are grabbing the key and value from the dictionary. So here we are calling the items method on the dictionary to get the key value of the dictionary and then grabbing those key value, and after this we are printing those key value in the next line, and you can see the result as a dictionary. So this is the arbitrary keyword arguments. If you have any doubt about the argument you provide to this function and how this argument value are received, then remove all these and directly print here print arbitrary keyword arguments ARGS like this and execute this. You can see provided argument value are accepted as a dictionary. Let's understand about one more function in Python called lambda function, and this lambda function is a small function. So let me explain how you can use this. For example, here I am going to create a function add, specify equal, then specify the keyword lambda, and this means you are going to create lambda function, and this function accept one expression. So here specify argument a or b, then colon, and then the action that you want to perform with the argument or the variables. So here we want to add the elements a plus b, And then you can simply call this function like a regular function. So here specify add and then within parentheses provide the argument. So here I'm going to provide argument 3 and 4. And when you execute this, you get the value 7. Remember, this lambda function is a small function and it is also called an anonymous function that can take any number of arguments but can only have one expression. So you can see it is having only one expression and it can take any number of arguments. So here we have provided two arguments a and b, and then after the colon we have performed the addition operation. And this is how you define the lambda function. And you can see this is the regular function and this is the lambda function, and there is a difference in the syntax. Remember the syntax and use the function wherever you need it. If you are not sure, let me create one more function, subtraction equal to lambda keyword. Then I'm going to perform subtraction between three variables a, b, c, then colon a minus b minus c, like this, and call here sub and provide the three value 3, 4, 5, like this. And now execute this and you get the value minus 6. So this is how you can use the lambda function in Python. Now you understand how to create function and call a function in Python. So I think it is time to understand a recursion function or the concept recursion. So what is a recursion? Recursion is a concept when a function calls itself to solve a smaller part of a bigger problem. So here function call itself again and again to solve a bigger problem. To understand the recursion, you need to understand two things. And the first is the base case. And this base case is the condition that stops the recursion, thus preventing the infinite calls. And the second case is the recursive case. This is where the function call itself with a smaller or a simpler inputs. So what happens when a function call itself? There should be a way to stop the function, and the way is to use the base case. When a function finds base case, then it stops. Otherwise, functions runs for infinite time, and that can bring stack overflow. To understand this in a more detailed way, let me show you with an example. In your childhood classes, you may learn about a term factorial, and you know factorial is represented by n, then this exclamation mark, and this means if I say factorial of 2, now this means 2 into 1, which gives result as 2. If I say factorial of 3, then this means 3 into 2 into 1, which gives answer as a 6. And similarly, we can find the factorial of n numbers, and we can build the formula n into n minus 1. And this is the formula of the factorial. So we can solve this factorial problem using the recursion function in Python. Now here, this function acts as a recursive case. And what is the base case? Base case is when we find the factorial of 1, then it gives a 1. So this is the base case. Now let's create a recursive function, def, and name it factorial, like this, and then specify colon. And this factorial function will accept input or the numbers whose factorial we want to find. So it is n. And here, first we need to specify the base case for stopping the recursion function. So here base case is if n is equal to 1, then return 1. Now let's specify the recursive call. So here in else part we will specify the recursive call, and it will return n into n minus 1, which is a factorial function again. Here we can see function is calling itself. This is the function factorial we created here, and here we are calling this function again. So this is the recursive function, and this factorial problem is solved using the concept of recursion. Now let's come here and specify here print factorial and specify the number whose factorial you want to find. Before this, comment out these lines, and now execute this you can see the factorial of 4 is 24. Let's understand this step by step. So here I am going to draw the line, and here I will show the steps. Now, when you call the factorial function and provide the input 4, then this 4 number is passed from here. And then first is the base case, so it check for base case. And as you can see, the value of n is here 4, so 4 is not equal to 1, so this condition become false. And then it jumps to the else part, and else part, here we have a function. So by looking at function, you can see the current value of n is 4, so it is 4. Then into, and then function is calling itself, and while calling a function, we are providing the value n minus 1, which is a 4 minus 1 equal to 3. So this function become 4 into 3 like this. And now when we input the 3 into this function, what happens? It again execute these functions with value 3. And now this time it again check for the base case, and you can see it is false. So again it jumps to the return part, and here it computes 3 into then factorial function, and within function n minus 1. So 3 minus 1 equal to 2. So this time 2 goes to the factorial function. So here it will be 3 into 2. And now when 2 goes to the function, what happens? It again check for the base condition, which is again false. So it jumped to the else part, and here in the else part 2 into, which is a factorial number, n minus 1, so 2 minus 1 equal to 1. And now it becomes 2 into 1. And as you can see, in a function 1 is passed. So in a next call 1 goes to the function, and then it again check for the base condition. And as you can see, this time in this next call n is equal to 1, so this returns 1 because base condition becomes true here. Now if you compute all these, like a 4 into 3, 3 into 2 and 2 into 1, let's see what we get. We can compute it like 4 into 3 into 2 into 1, and what we get, 4 3s are 12 and 12 2s are 24. So the result is 24, and you can see we get the 24 as the result. So here you need to understand about the function. So this factorial function is calling itself again and again to solve the smaller part of the problem. And remember the function that we have created here named factorial, and you can find the factorial of any number. Like you can find the factorial of 20, 30, 500 or any of the number. So this is all about recursion. I hope that you understand how to build recursion function and how it works, and what are the two cases that you need to know that should exist in recursion function. Now one thing I want to tell you about a function's parameter and argument. There is a two-term positional and keyword argument in a function. Let's understand this. For this, let's define a function greet again. And this function takes a two value name, the name of the person and the age, like this. And then we will print on the terminal or console, like here, hello. Then we will insert the name of the person, and after this, age of the person. You are, then age, years old, like this. And now let's call this function. So here you can see this function accepts two parameters, name and age. And now here first we will specify the name as Bobby and the age is 25. And if you execute this, you get the correct result or correct output, hello Bobby, you are 25 years old. And here when you provide this kind of argument, then this is called positional argument, because here position matters. So here the first argument is mapped to the first parameter name, and the second argument 25 is mapped to the second parameter age. And if you swap this argument, then there will be incorrect output. For example, if you swap this, remove Bobby from here and pass the first argument as the age and the second argument as the name, And if you execute this, you can see we get the incorrect output. Hello 25, you were Bobby years old, and this is completely incorrect. So in positional argument, you need to care about the position of the argument when you pass to the function. So let's make it correct. And now in case of a keyword argument, you need to provide the keyword. For example, you can call this function again greet and specify the name keyword like this, name, and then age equal to 25 like this. Comment out this line, and now if you execute this, you get the correct result. But what happens if you swap the argument? So I am going to remove the name and I'm going to specify the name after the age like this, and now execute this, and still we get the correct output, because in keyword argument order doesn't matter. So here you can see we specify the name of the person at the second argument, but it maps to the first parameter. And the reason is, here while providing the argument, we have specified the keyword or the parameter name to which this value or keyword should be mapped. So this is the difference between positional and keyword argument. But here I want to show one thing more. In some function you will notice there is a slash or asterisk. So what this mean? So here this slash represent a positional argument args, and this asterisk represent a keyword args. This means when you specify slash or asterisk within the function parameter, then that parameter is forced to be either a positional or a keyword argument. For example, let's modify this greet function. So I am going to copy this function from here, and here if I specify comma slash, so this means this name parameter will always be positional argument. You cannot specify keyword argument. So whatever the parameter that you see before this slash, which is name in this case, this parameter is forced to be except a positional argument. For example, here if I call the greet function and specify name Bobby and age equal to 23, you can see it is working. But what happens if I specify here keyword argument? If I specify here name equal to and execute this, and you can see there is a type error, and the error is greet got some positional only argument passed as a keyword argument name. So you can see this parameter is forced to be except a positional argument, but here we specified the keyword argument, which is not correct. So remove this one. And if you use the asterisk here like this, this means after the asterisk, whatever the parameter that you specify will accept keyword arguments. For example, if you execute this code, you can see here while calling the function we have specified the keyword argument and it is correct, and it is going to work fine, and you can see it is working. But what happens if I remove this keyword from the function and then execute this, and you can see we get the type error, greet takes one positional argument but two were given. So here you can see we need to provide the keyword argument, then it is correct. Execute this and now it is working. So I hope that you understand what is a positional argument and keyword argument and how to force the positional or keyword argument in a function. So you know how to create a function and what are the different kind of argument in functions, and these are the user defined function because these functions are created by user. There are some built-in function and let's explore those functions. So first function is the input function, and this function takes the input or the data from the user, because if you notice in the previous videos we have initialized a variable with a value like specifying here a equal to 10. But what happens in real application, we take input from the user. So for that we use the input function. For example, here we have initialized the a with value 10, we can take this 10 value from the user like this. So here I'm going to specify variable b equal to, then I will specify input function and comment out this line, and here I will print the b and execute this, and you can see it asks for input here. If I specify here 10 and hit enter, you can see it prints 10, and this is the entered value. If you are not sure, this input function takes a parameter prompt where you can specify the integer which shows the information about the input. For example, here you can specify enter the integer value like this, and this information will be displayed to user to indicate that, hey, enter only the integer value. And here if you execute this, you can see we get the error, and error is because we have here single quote, we need to use here double quotation. Now execute this, and you can see this is the message on the screen, enter the integer value. Now here user will enter the integer value like 20 and hit enter, and this is the print function which print the value of the variable b. So in the result we get this 20 value. So this input function is very useful and you will often use this. Now here if you check the type of this variable b which contains the input value and execute this and specify the value 10, and you can see the type is str, but here we are entering integer value. So by default, when you provide a value through input function, it converts the given value into a string. How we are going to convert this given value into integer or float or any other data type? And there is a concept in Python called type conversion or typecast. So what happens here, we can convert the data type of one value to the another value, or we can convert one data type to another data type. For example, here if I specify a string like 100, and if you check the type b, you can see its type is str, but you can convert this string into a integer. For that you will use the int function, and within int function specify the data that you want to convert into integer. So here we want to convert this b into integer, so I will specify here b. Now I will print the c and execute this. This is the 100 integer value. If you are not sure, specify here type and then specify the parentheses and execute this. You can see the value is converted to integer. Similarly, we have a function called float which can convert the integer to float. For example, here if you specify float and then this float function pass the value that you want to convert into a float. So here I'm going to pass the b, and then here I will print, and I'm going to specify here f, then here convert it to float and specify here the converted value which is t, and then close this and execute this, and you can see the 100 is converted to float. Now if you want to check the type, specify here type then d like this, execute this, and you can see the type is float. Similarly, we have a function called str which converts value into string. For example, if I will create a variable y equal to, and if I specify 100 as a string, if I specify 100 as a integer value and pass this y to str and then print f converted to string, and here specify the quotation mark and close this print and execute, you can see the 100 integer is converted to string. If you are not sure, specify here type e and execute this again, you can see the type is str. So these are three functions, str, float and integer, that you can use to convert integer to float, float to integer, string to integer, and integer to string. So here you learn about input function, how you can use this input function to take input from the user, and then you learn about type conversion. You can combine both the function input and these type conversion or typecast method. For example, Here you can see user is entering integer value, but we received the string value. What we can do here, let's copy this, paste here, and wrap this input function with int. And now when the user will enter the value like a 10, and you can see here we get the integer instead of string. So remember, by default input function accept the value as a string, but we can typecast those value or convert those values into required data type using the three functions int, str and float. Whatever the data type in which you want to convert, you can use those methods. In this section we are going to learn how to handle error. So what do we mean by handling them? In normal circumstances, these errors will stop the code execution and display the error message. To create a stable system or application, we need to anticipate these errors and come up with alternative solution or warning message. And you can handle this error using some statement. First statement is a try except block, then else, and then finally statement. Now what happens, we write a bunch of code line by line. If error occurs, then the error stops the flow of the program or stop the execution, and the next line will not execute. For example, if I will here print divide 1 by 0, and next to this I am going to perform one more arithmetic operation where I will add 2 plus 2. So what happens here, when Python interpreter comes here, interpret this line, it try to divide 1 by 0, and then it must move to the next line to execute it. So let's execute both the line and see. And when I execute this, you can see we get the error 0 division error. So here it is saying we cannot divide 1 by 0. In programming, you cannot divide any number by 0, and when you divide you get this kind of error, especially in Python. But after this line, after this arithmetic operation, we have another operation like addition, and we want to execute this. So here I want to say whenever an error occurs, then the program should not stop at that point. It should move to the next line of code, or it should execute the next code. But here error stop at this point. So there is a way to handle this error, and that way is the try except, else and finally statement. Let me show you how we can do that. So here you need to wrap your code within a try block. So I will copy this here from and paste in the try block, and then if any of the error will occur, will be catched by this except block. So here we will specify exception like this as E, and then within an except block, remember within except block we can specify the warning message or the error that we want to show the user. So here I am going to specify you cannot divide by 0, and then I can simply specify the error here, specify parentheses, then within parentheses specify E, then double quotation and parentheses. Now execute this line of code, and you can see we get this here. So here you can see the next line of the code, you can see 2 plus 2 get executed because we have handled the error properly here. So here you can see within the try block we write the code that we want to be executed correctly, and then if any of the error occurs, that error is catched by this except block, and then within except block we can specify the code that we want to show that hey, this kind of error occurs, you can't do this, you must do this. Like this information we can specify in the except block. And remember, this exception is the keyword, which is a general exception which contains all kind of error that may occur. So instead of here, you can directly specify the error, or you can be much more specific to the exception or the error. For example, when we execute this, we get the error 0 division. So what we can do here, instead of this exception as E, we can directly specify here 0 division error, because we know that here when we divide any number by 0, then this is going to raise an exceptions 0 division error. So here we are more specific to the error, and then we can remove it from here and we can directly execute the whole code and we get this. So here whole point is your program execution is not stopping and it execute the next line of code, or it moves to the next line of code that you can see here. So this is how you can handle the error in Python using the try and except block. Remember, in a try block, you write the code that you want to run correctly, and if any of the error will occur, then that error is cached by this exit block, and here you can write your own customization warning or some information that you want to show related to the error. And this is not only the error in Python, there are more errors. For example, if I here say x equal to 2 into like a spam, so you can see this is not correct. If I will try to print here, print x and execute this, you can see we get the name error. So we can also handle this error. To handle it, specify here try, then within try specify the statement x equal to 2 into spam like this, and then here specify except block to handle the error, or you cannot specify any of the error here if you don't want. But here, as we know, this is the name error, so we will specify here this error type is name error, and then here we can print our custom message for the user, and here we will say the name error has occurred like this. And now if we write any line of the code after this, that code will be executed. For example, if I will say here y equal to 4 minus 3 and print here y and execute this, you can see this shows the specified error information, the name error has occurred, and you can see the next line of code is executed. Our flow of program does not stop, or code of execution does not stop. Let's take one more example where I will show you can use a multiple except for catching the error. So for example, here I'm going to specify try, and then within try I will say x equal to 2 divided by 1, and then y equal to 2 multiplied by k. And now here I will specify except, then if this error occur, 0 division error, I'm going to copy all this from here, paste here, and also I'm going to specify this except here. And as you can see, we can specify multiple except to catch the different type of error. Now let's execute this code. You can see the name error has occurred, which means when we try to multiply the 2 with a string, we get this error. But our first line of code got success, which means when we divide 2 by 1, it is correct. So this error is not raised. But as soon as this line is interpreted or computed, then the error is raised and you can see error in the terminal like this. What happens, we will make this correct, and here instead of 1 specify 0, and as you know, this line of code is going to raise the 0 division error. Let's execute this, and this time you can see you cannot divide by 0. So here you can specify multiple except block to catch different types of error. Okay, now it's time to learn about else block. So why we use this else block with try? We use this else block whenever there is no exception, then we want to execute a certain codes or some specific lines of code. That code can be written within else block. For example, if I will copy this code and then here I'm going to make a change, I will specify here 1 again, and as you know, both this line is correct and both this line is not going to raise any error. So what happens after this? We want to execute a line of code which will show the result. So here we will specify print, then f, and here we want to print the result. like this, division result like this x, and multiplication result like this in y, and then close the parenthesis, and if you execute this, you can see the result. Division result is 2.0 and multiplication result is 4. So remember, whenever there is no exception and if error is not occurring, you want to execute a certain block of code or you want to perform some action. That action can be written within the else block that you can see here. So this is the purpose of the else block. So finally is here keyword is used in try except block. It defines a block of code to run when try except else block is final or finished. And remember, this finally block is executed no matter if the try block raises an error or not. For example, let's copy this code and paste here, and then next to it I'm going to specify finally, and here I want to print message try and except block executed successfully like this. And now if I will execute this, you can see this is the message from the else block code with the result, and you can also see the message from the finally block. And in this case, you can see this block is executed, but finally block is also executed. If any of the error occurs, that error will be raised and this finally block will execute. For example, if I will specify here 0 like this and execute this, you can see it raises error you cannot divide by 0, but also finally block is executed. I told you finally block will execute no matter if try block raises an error or not. So why to use the finally block? Finally block is used to close the opened objects or created objects and clean some resources when we don't need it. Now I hope that you understand how to use try except, why to use else, and why to use finally. And also if you want to know more about exception handling and errors, you can visit the official documentation of Python. So let's visit this, and when you visit this, you can see here it explains different error and exception and how to handle them. Now you know how to use try except, else, or finally to handle the error. But what you can do, you can raise a manual error using the raise keyword in Python. For example, here I'm going to create a function def check age, and this function will check the age of the person, and it is going to accept a parameter called age of the person. And then here I will check if age is less than 0, then I'm going to raise the exception here, raise. I will specify the keyword raise to raise the exception, and then the what kind of the exceptions or error we want to raise for this kind of error. So here I'm going to raise the value error, and then within parentheses you can specify the message like a not a valid age. After this I'm going to specify one more condition by specifying elif, and I will check if age is greater than equal to 21, then it is going to print you are old enough like this, and then it is going to return true. And finally specify else block, and then here it will print you are not old enough, and then it will return false. And now let's call the function check age, and here specify the age of the person like a 15 and execute this. You can see you get you are not old enough. Let's specify minus 12 and execute this, and we get the error value error not a valid age, and this error is raised by this block of code where we use the raise keyword to raise this value error whenever age of the person is less than 0. So this is how you can use the raise to raise a custom error, to raise your own custom error. In this section, we are going to understand what is module, package, and libraries in Python. So let us start with a Python module. So what is module? Module is a single file with a extension .py, and this file contains all the code like functions, classes, and variables. So this module is nothing, it is a single file where you can write your own codes, you can write your own functions, classes, variables that you want to use in another Python script or in another Python file. So whatever you learn till now, like you have learned how to create variables, how to perform arithmetic operation, how to create functions. So all these things you can specify in a module for a specific task, and then that you can use that module in another Python file wherever you need those tasks. So first I'm going to introduce you some of the built-in module, and then we will create our own module, or we will learn how to create our own module. So in Python there is a module called math module, and this math module contains a function related to math, like it has a pi, it has a sqrt function, it has an exponential function. There's lots of function exist in this math module. And to import any module in Python, you need to specify keyword import, and after this import specify the name of the module that you want to import. So here I'm importing the module math in this current Python script or Python file. Now execute the shell, and this Python module will be included in the current script or in the current file. Now this module contains several functions, and that you can access by specifying dot after the module name, like this, specify module name math, then dot. And if you are using a Jupyter notebook, then simply press tab from your keyboard and you can see all the functions that exist in this module. So here you can see we have function sign, sqrt, 10 function, and there are a bunch of functions that you can use like exponential. So here I'm going to specify the function sqrt, which will find the square root of any given number. And now within this function, if you specify 16 and execute this code, you can see the square root of 16 is 4, and this function is defined within this module math. And it has also a function that you can access, or it can also contain constants or variables. So it has a variable like pi, and if you execute this, you can see it gives the value of the pi 3.1415. Now we have a next module in Python that is called OS module, and this module allows interaction with the operating system, including file manipulation, environment variables, and directory changes. For example, if you want to get the current working directory, you can specify here OS, which is the module name, then dot. And if you want to see all the functions that exist within this module, press tab from your keyboard and you can see all the function. And here there is one function called get current working directory or get CWD, and when you execute this, you can see this is the current working directory of this Python file. And as you know, there are a bunch of functions in this module. So let me show you one more function, which is the os.mkdir, which creates a new folder in your current directory. And if I will specify here data, and then this code will create a new data file, and execute this, you can see we get the error because here this should be mk, not mak. Execute this again and it creates a new folder in your current directory. Not sure, go back to home and refresh this. You can see here what is happening. Let's again reload this page. You can see the new folder data is created. Now there is another library, that is sys library, import sys, and this library provides a function variables that interact with the Python runtime environment. For example, you can get the current version of Python. So specify here module name sys dot, then specify version, and this line will print the current version of the Python. And you can see the current version of Python that we are using 3.12.6. Also there is one more module which is very important that you should know, which is a date time module. And this module provides a classes for working with date and times. For example, if you want current time, you can specify now equal to date time dot now function, and here print now like this and execute this. You can see this is showing the current date and time. And as I told you, Python has a bunch of modules that you can use for your work. Now it's time to understand how to create our module. So to create a module, you need to go to the folder wherever you want to create a new module. So here I'm going to create module in this directory. So click on here, file, go here, click on new, and then Python file. And I'm going to change the name of this Python file and specify the name my module like this and rename this. Now in this file, let's define a function def show, and this function will simply print the given text. So here it will print hello and then given name. Specify curly braces, then close this, and here specify the parameter name like this. Now save this file, save all, and come back to your Python tutorial script, and here let's import the module. So here specify import and specify the name of the module that you want to import. Remember, we have given the name to the file my module. You can see here, if you refresh this or reload this page, you can see the module name is a my module, and this module contains a one function show. So let's import this module, and now you can access the functions that you have defined in this module. Here specify module name, my module, and then dot, then tab. When you specify tab or press tab from your keyboard, you can see this is the show function we have defined. And now let's pass the text to this, like a name John, and execute this. You can see, okay, let's define one more function within this module. Remember, you can not only define function, you can specify classes or variables within this module, and you can use those functions and variable classes in other scripts. So here I'm going to add one more method called add, which will take a two number, and the number is x, y, and then it will return x plus y. Now save this module and then come back here, re-import this module, and as you can see this function is working. Now access the add function my module dot add and give a two argument 3, 4, and execute this, and we can see we get the error. We get the error because the changes that we made to this file is not reflected here in this Python script. Here I'm going to restart the kernel, and now after restarting kernel, let's again import this my module and execute this function, and now you can see it is working. So we have created this add function in the my module, and we can access here in other script. Similarly, we can go back here and define variable of type dictionary person equal to and curly braces. Then here first key is the age is 20, second key is the name, and name is James. And now save this file, and then here again import the module to include the latest changes, and here call the variable my module dot person like this, and execute this. We get the error. Let's reload the kernel, restart this kernel, again import this, execute this function, execute the add function, and execute the person, and you can see we can access the variables that we have defined or specified within this module. And here you can see when we import module, we specify import keyword then module name. There is an alternative way you can use to import specific functions, specific classes or variables. For example, specify keyword from, then specify module name from which you want to import classes, functions, variables. So which is a my module in our case, and then specify import keyword. Now you can import only one function called show like this and use this function directly like this. Here give a name rock like this and execute this, it will work. Remember, when you import any functions, classes like this, you don't need to specify module name dot like this. You can use those function classes directly with the name. Now it's time to understand what is a package. So what is package? Package is a collection of modules. So you learned about module, and package is collection of modules. Also, this package can contain sub package. So within this package you can create sub package. Now let's understand how to create the package. Let's go back to the home folder or in home directory, and here you see this is the module. To create a package, you need to create a new folder, and here I'm going to give a folder name as a mathy file like this, because I'm going to include some mathematical related modules within this package. And now currently this is the empty mathy5 folder or a normal regular folder. To make this folder as a package, you will need to include a new file within this package with a specific name and extension. So here within this package, create a new file and name this file as a _init _ like this. Remember, to make the any folder as a package, or if you want to add the folder as a Python package, you need to create a special file named init like this. And when you create this file, then this folder is considered as a package. And now here you can include your own module. For example, let's create a new Python file here or new module, and I will call this module cal module. And here in this module, define a function add, which will add a number, return x plus y, specify parameter xy. Then create another function def subtract x y, and then it will return x minus y. Create another function div division xy and return x divided by y. And lastly, let's create another function called mul, which is multiplication, then return x into y. Save this file. Now come back to our scripts wherever we want to import the package. Okay, now to import the module from the package, specify here from, then the package name, which is a mathy, then import, and then module name that you want to import. So module name is cal, and execute this. You can see it is working. And if you are not sure whether module is imported or not, you can simply specify here print cal and execute this cell. You will see a information like here mathy.call, and if you do not see, which means you have not successfully imported the module or the package. Now this cal contains a method like add, which adds two number like 3 and 5, and execute this. You can see it returns results. It has another method cal.sub, which subtracts two number 5 and 6. Execute this. You can see it returns result -1. You can see it returns result -1. Similarly, you can call the div method to divide two values 4 and 2. Execute this, and you can see it is working fine. So here we are importing the cal module from the mathy package, and to create a package you need to define a file called init.py. This is the special file which indicate that this folder is a Python package. So I hope that you understand how to create a module, how to create package. Now let's move and create a library. So what is a library? And library is a collection of packages and modules. Library contains both thing, packages and module. And library is created for a specific task or specific actions. It contains all the package or sub-package or modules related to the specific actions, specific task or specific operation. Okay, now here is a step that you can follow to create a library. Create a new folder and give a meaningful name, and then within this folder you need to include your packages, modules or sub packages. That's it, and your library will be ready. For example, let's go in the home and create a new folder, and for example I'm going to create a library for calculator. I will keep the name calculator like this, and then within this we can create our packages. For example, create a new folder within this and name it cal, and within cal create a special file, and this file name will be init be pi like this, and then here we can create our module Python, and we can give module name, like we can create here a different module, add module, which will contain add functions like def, add like this, and you can specify your block of code here. So here this calculator folder will be our library, and this library contains a package, and this package contains a modules or sub package. So I hope that you understand about what is a module, library and packages and what are the difference. In these sections, we are going to continue basics of Pythons. And if you remember, we learned about arithmetic operator or the expression which evaluate to true or false. For example, if I will say here a equal to 5 is greater than 2, and if I will use here if condition and specify a here, then we can print something on the screen or perform some operation based on the condition when the condition becomes true. So I can print here 5 is greater than 2 like this. Else we can print if this condition become false. So specify here 5 is not greater than 2 like this. And if we will, and when we execute this, we get 5 is greater than 2 from the if block. So here this part is executed because here a is evaluated to true. But you can see here this is the expression, and this expression contains a operands like a 5 and 2 and operator. But in Python there is a term called truthy and falsy. So that means you can evaluate any value or any object in Python as a true or false value. If the value is a true, we call it truthy, and if the value is a false, we call it falsy. For example, if I will take here variable x and assign a value 5, and if I will specify here if x and then print, here I'm going to print the value of x like this, and then if I will execute this, you can see this block is get executed because here the x value evaluated to true. But as I told you that this expression, when we use a operand or operator, these kind of expression are evaluated to true or false. So what is happening here? So I already told you that in Python you can determine whether a value is a truthy or falsy. So in this case, here the x variable contains a value 5, and value 5 is a truthy value. When the x is truthy, it means it is evaluated to true, so the if block is get executed. But how you are going to know that any of the value is a truthy or falsy? So in Python there is a function called bool, and to this bool function you will pass the value that you want to determine whether it is a truthy or falsy. For example, if you will specify here bool, and within bool function let's specify this x and see whether it is a truthy or falsy, and as you can see this bool function returns true. which means this x value is truthy. Remember, truthy means true, falsy means false. Now let's take another number. Here I am going to use the integer 4 and let's see, and we can see it is also true or truthy value. And one thing you must remember, 1 is equal to true and 0 is equal to false. So if you want to verify it, let's use the bool function, and to bool function specify 1 and next to it specify 0. Comment it out this line and execute this. You can see here, let me remove this. Now execute this. You can see the value of 1 is true, and if we specify here 0 like a bool 0, you can see here the value of 0 is false. So if you use 1 or 0 with if and while, then it will work fine. For example, if you specify here 1, which means true, and you can execute the if block code like this is the truthy value like this. Or also you can specify here if 0, and here 0 is falsy, and when you execute this, this is the falsy value and it will not work. Here specify else block and print this is the falsy value like this, and remove this one, make it truthy. And first let's execute this line and see if it is working or not. So comment out this line, execute this, and you can see this is working because here 1 represented true. Now let's comment out this line and uncomment these lines, execute this, and here you can see this is the falsy value and this part is coming from the else block, because here if is 0, which means it is false, so the else part is get executed in case of false condition. Now let's check sequences and collection for truthy and falsy value. First, here I'm going to create set A, and to this set I will assign some value like a 1, 3 and 5. And now let's check if this A is a truthy or falsy. So specify bool function, and to this bool function pass the list A and execute this. You can see here it returns true, which means this A is a truthy value. Now what happens if we remove all the value of the set and we make this set empty? And now let's check this, and this time we get false, which means when set is empty then it is a falsy. When set has an element or set is not empty, then it is a truthy. Now let's check the tuple. So here I'm going to create variable t and assign some value, and the values are integer value 2, 3 and 5. And now specify bool function and specify t, execute this, and we can see when set is not empty then it is a truthy or true value. Now remove all the element of set, then execute it. We can see it is a falsy, which means if you create a empty collections or sequence, then that empty collection and sequence will be a falsy or false. And if the collections or sequence are not empty, if they contain elements, that means they are truthy, they are true. That you can know by looking at these examples. So we can say here empty list, then tuples, then dictionaries, then set, then empty string, and then range with 0 value. These are falsy, which means these are false value. Now next let's understand what are the numbers which are truthy or falsy. So here let's check the 0 value, execute this, and we can see it is a false or falsy. Let's check float value 0.0, execute this, and we can see it is still false or falsy. Also let's check complex number 0j, execute this, and we can see it is still false, which means 0 of any numeric type is falsy. So we can specify here 0 of any numeric type is falsy or false value. There are some constants. Let's check those constants. So here, specify bool, specify the constant non, execute this, and we can see it is a false. Also, let's check one more constant, and that is a false value. So here specify bool, then this is the false value. It is a constant. Remember, when we write true or false, those are constant. Execute this and you can see it is false. So we can say here constants like a non and false is falsy or false value. Let's write all the truthy value. So from the web example, you know that when the sequence and collections are empty, then those are the falsy. If they are not empty, then they are truthy. So we can say here, if collections sequences are not empty, then these are truthy value or true value. Also, if we check here bool and specify any integer number greater than 0 and execute this, we can see we get it true. Just change this to different number like a 500, execute this and we get the true. So we can say here numeric value that are not 0 is truthy value or true value. And lastly, we have the constant true, and as you can see, it is also a truthy value. I'm telling you about truthy and falsy value because you can use this value within if and while condition wherever you need to evaluate a condition for true or false. For example, let's create a list user and specify some username within this like a James, Rock and John. And now you can use this in if condition. You can specify here users and you can read it if users. That means if user is not empty, then we are going to execute this line print list contains users like this. Otherwise, if the condition false, then execute the else part. So here print list is empty like this and execute this. You can see list contains users. This means if part is get executed, which means this user is evaluated to true, because when the list or collection is not empty, then they are evaluated to truthy or evaluated to true. So if part is executed, and if we make it empty, let's make it empty and execute this, we can see else part is executed because this time list is empty. So this list is evaluated to false or falsy. So if block is not executed, else part is get executed. I hope that you understand about truthy and falsy and why they are used. Now let's move and understand scopes in Python. There are two kinds of scopes, global scope and local scopes in Python. For example, create a variable, name number and assign value 10. And now print the value number. And then again specify the variable number and assign value 20 and again print here number. Now execute this code, specify parentheses, execute this and you can see for these lines of code we get the output 10 and for these lines we get 20. Here in this case we have defined the variable globally number which has a value 10. Then we print the value and after that we again specified or referred that variable and assign value 20 or change the value from 10 to 20. So it printed 20. Now what happens if I define here function def and I will give a name to function change number, and then within this I'm going to create another variable number which is equal to 100 and then I will print here number. Now I'm going to remove these ones or comment it out and execute this. First call the function, then execute it. So here call the function change number and execute the cell, and you can see this time we get a 10 and 100. But here we are printing the number before the function, so remove this or print here. Print after this calling change number and execute this, and you can see this time we get 110. But what we saw here, we saw the number change to 20. And why number don't change to 20 and here it is still 10? Because the variable that we have defined here is a global, and the variable that we have specified here, number equal to 100, is a local, which means this line creates a completely new variable locally, and this number is not related to this number because the scope of this number is outside of this function, above this function and below this function, not within this function. So here when we assign a number equal to 100, it completely creates a new variable. So in the result set we see here 100, and when we print here a number, this number refer to this number that we have defined at the above because it is a global. So remember, the variable that you define within any function will not be used outside the function. You can use within the function, but you cannot use outside the function. For example, instead of number, specify here var and change this to var. And if you try to access this var outside of the function like this, execute this, and you can see we get the error, and name var is not defined, which means when you create a new variable within a function, that variable is only defined or used within the function, not outside the function. So for this line we get this name error. But you can use the global variable, this global variable, directly within this function. For example, remove this line, and here you can specify number and then execute this code, and you can see it is working fine because within this function we can use the outer variables or global variables, but the variable that we define within this function we cannot use outside of this function. And here we saw how we change the number to 20. So how we can achieve this, or how we can update the outer variable or global variable within the function or locally. So for that there is a keyword called global. Let's take another example. Here I'm going to copy this and paste here, and I will call it only number function. And then here if I will specify keyword global, and then if I specify here number, then this line refer to this global variable that we have created here. And after this we can specify or update the value of this variable equal to 20, and when we execute this we get the value. So here I messed up. Let's change this to number and execute it, and we can see we get the value 20. So remember, when you want to update the global variable in a local or in any function, you need to use this global keyword to refer that variable, and then you can perform any updation or change the value of that variable. Otherwise, if you will not use this line like a global, then this will completely create a new variable for this local function. So I hope that you understand about local and global scopes. But what happens if you create another function within this function? Let's call it inner func, and specify here number equal to 40, and then print number like this. And now here let's call this inner func like this. Let's execute this, and we can see it print 40. So here let's comment it out and again execute this cell, and we can see the value is 20 and 40. But what happens if I change this to 10 and execute this, and we can see the value changed to 10. So here you need to understand this number variable is a global for this whole function. So you can use this number variable within this inner function, but here we have assigned 40 to the number. This means it completely create a new local number variable for this inner function, and we cannot use this defined number within the outer function. For example, if I will comment it out, and here I think that this number refer to this one, this number. And if I execute this, let's see, and we can see this number is not working within the above function. So which means whatever the variable that you create within function, that variable is local to that variable. But if in that function you create another variable, then that variable will also be local to that variable. So here you can understand this number is local to only this inner function, not to this number. But the number you have created here, we can use it here within this inner function, because this number will be global to this inner function. So if I comment it out and execute this, and we can see the value of both the number is 20, because this number refers to this variable. So here you can see that we can use this number, but as soon as we here assign a new value to that number, then it creates a completely new local variable to this inner function. So how we are going to update this number within this function? And for that, you can use the keyword non-local and then specify the variable of the outer function. And now if you will execute this, you can see the value is updated to 40. So here this line non-local number refers to this number that we have created here. So here it is not creating a completely new variable. It is using the existing one from the outer function. And also remember, the variable that you define within this function cannot use outside the function. For example, I cannot specify here print number like this. So if here I'm writing, I'm thinking that this number is coming from this function. But as I told you, it will not work. Let's execute it and you can see we get this. So this is coming from the other variable that we defined globally. Let's change this to number 1 and also change this to number 1. Also change this and execute this. We can see we get the name error, number 1 is not defined, because number 1 is defined within the function, within this function, not outside the function anywhere. So I hope that you understand what is a scope and what is a global and non-local keyword and how to use them. Now, next basic thing in Python is a list comprehension. What is a list comprehension? List comprehension offers a shorter syntax when you want to create a new list based on the values of the existing list. So here you will have a list, and if you want to create a new list from that list, you can use the list comprehension. So here, for example, suppose here I have the list fruits, which contains a number of fruits like a apple, banana, cherry, kiwi, and then mango. And suppose here I want to create a new list from this fruit list. For example, I want to create a new list, and this list will contain all the fruits whose name contains letter A. So what I can do here I can start the for loop for x in, then I will specify here fruits, and after this I will check if letter A in x, then add this to new list using the append function like this, and then we can print new list like this. Let me explain for loop. So here you can see we start the for loop which takes each element from the fruits list. Then it checks if the letter A exists in the X, which is the current fruit of the list. So then if this line becomes true, then it calls the append method on the empty list, and to this append method we pass the element or the value that we want to add into the new list. And finally we are printing the new list. Let's execute this, and you can see here there are 3 fruits: apple, banana, mango with the letter A. So here you can see for performing these operations, for finding an element within the list with letter A, we are using 3 or 4 lines of code. But using the list comprehension concept, we can do this only with one line. So let's comment it out this line, and here specify new list variable like this. Then specify square bracket. And in case of list comprehension, you can run the for loop within this for bracket. For example, you can specify here for x in fruits like this. And then before this loop, you can specify the expression that you write within the for loop. So here we will specify x. And after this for loop, specify the condition. So here specify if a in x like this. So as you can see here, if a in x is a condition, and before this is the for loop which will iterate over the list, and then this x is the expression, or you can specify any operation that you want to include in the list. And now if I will print here new list like this, execute this, you can see we get the same result. So this is the list comprehension where we run for loop, condition and expression in one line. As you can see, this is the very shortest way to create a new list from the existing values. Now, if you are not sure, let's take one more example. Suppose you want to create a new list, but this list will contain all the fruits. For example, create a new fruit list, and this list will contain all the element or the values of the fruits list. So using the traditional method for loop, you can write like for x in fruits, and then here you can specify new fruit list dot append then x like this. And then if you print new fruit list and execute this, you can see this new fruit list contains all the fruits or all the elements from this existing fruits list. But you can modify this, you can use the list comprehension, and for that you will specify your new fruit list 2 like this. This is just for example. Then square bracket, then within a square bracket run the for loop for x in fruits. Then here we do not have any condition, so before this we will only specify x, and remember this x is the current element within the list, and this element or this expression is evaluated, saved into or added to the new list that here we have created. So here we do not have any condition, so we will not specify any condition after this. Now let's print this, print new fruit list 2 and execute this, and we can see we get the same result. So you can see this is the very shortest syntax that you can use to iterate over a list and perform some operation and then create a new list from the existing one. You can also use the range function within this. For example, you can create here numbers equal to then square bracket and specify here for k in range of 5 and then specify here k. So what happens here when you execute this, it's create a series of number 0 to 4 which is equal to 5 number, and then it adds each number to this new list numbers, and this is the current number. So let's print this, print numbers, execute this, and you can see new list created numbers with the series of number from 0 to 4. So remember, whatever the operation that you can perform with a traditional for loop, you can also do that with the list comprehension concept. Now next concept is a slicing. A slicing gives a section of a iterable object that you can refer with index. For example, here I'm going to create a list sequences, and this list will contain list of integer from 1 to 6, 1, 2, 3, 4, 5 and then 6. And here you can slice a part of this list. For example, suppose you want only element from 1 to 3. So you need to know here one thing, and that is the index. So in reality, behind the scene, the index of first element in the list is 0, the index of second element in the list is 1, and third element is 2, and fourth element is 3, and so on for the other element. So in slicing, you will specify the list, then square bracket, and you want element from index first. So here the index of the first element is 0, so specify here 0, then specify colon, and then you want all the element from index 1 to index 2. So behind the scene 3 has index 2. So here you will specify index 2. But remember, when you specify index 2, this is exclusive, which means this index is not included in the slicing or in the range, which means when you execute this line, you will get only element from 0 to 1, and this 3 will be excluded. So what we can do here, always remember, specify ending index plus 1. So instead of 2, specify here 3, then this code will give all the element from 1 to up to 3. Now execute this, and you can see we get part of the list or the section of the list from 1 to 3. Suppose you want element from 2 to 4. So when you are going to extract element from 2 to 4, just remember the index of the element 2, and as you can see, the index of this element is a 1. So specify here sequence says square bracket, then the starting index colon, and we want element up to 4. So the index of the 4 here in this case will be 3. So we know ending index plus 1. So 3 plus 1, 4. Execute this and we get element from 2, 3, 4. So you can create your syntax here, iterable object, and remember this object must be, or you can refer using index. You can build a syntax, so specify iterable object, then square bracket, and within square bracket starting index of the element, then colon, then ending index plus 1, like this. Now following this concept, let's take one more example. Suppose you want element from 3 to 6. So the index of 3 will be here 2, and the element of 6 will be 5, because the element of 1 is a 0, then 2 is a 1, 3 is a 2, 4 is a 3, 5 is a 4, and 6 is a 5. So here specify sequences square bracket. The index of 3 is a 2, and then index of 6 is a 5. So you know ending index plus 1. So 5 plus 1 is a 6. Execute this, we get the element 3, 4, 5, 6. Now here I want to show what will happen if we don't specify this ending index. So for example, if I will specify here sequences square bracket, and then I'm going to pass the index 2 and colon. I will not specify the ending index and directly execute this, and we can see we get all the element up to 6. So which means if you specify starting index and don't specify ending index, then it will retrieve all the element from the starting index up to the last index. So we get 3, 4, 5, 6. Similarly, if you specify here starting index as a 3, it will retrieve all the element from starting index 3 up to last. Similarly, you can reverse this operation. You can specify here sequences, then square bracket, and then don't specify starting index, then colon, and specify the ending index like a 3. So in this case, it is going to retrieve all the element from starting index up to the ending index. For example, execute this and you can see we get the element 1, 2, 3. Let's take one more example. Specify here sequences, then colon, and then specify here index 6 like this, and execute this and we get all the element from starting up to the end. Okay, now here I want to show, as I told you, that when we specify ending index, then this ending index is exclusive, which means it is not included in the list. Why it is? Because of the operations that we can perform. So here you can specify sequences, and then if you specify like this 3 and then specify add operator, then again specify the sequences, and here this time specify 3 dot, then close this square bracket, and as you know, this line will retrieve all the element from the starting index up to 3. And as you know, this line is going to retrieve all the element from 4 to 6. And if you execute this line, you get all the list elements. Both are combined. So this is why the ending element is excluded, or it is exclusive. Remember. Now you can also specify negative indexes, because you can see here we have specified positive integer value. So you can see here this is the list. What happens in a negative indexing, it goes from 6 to first, which means the index of the last element is -1, and then second last is a -2, and third is a -3, then -4, then this one -5, and this one -6. If you specify here negative indexing like this, sequences, then square bracket, within a square bracket, specify negative index -1 and execute this, and you can see it returns the last element. If you copy this one and change this 1 to 2 and execute this, you can see it returns second last. So we can apply the slicing concept here, and if you will specify here -3 then colon and execute this, you can see it returns 3 last element from 6 to 4. As you can see, -3 is included, and if you go up here and you will see here, this is the -1, -2, and this is the -3. So it returned or a slice element in this direction 6, 5, 4. Now let's change this to colon -3 like this and execute this, and we can see it returns all the element before the -3 indexing 1, 2, 3. So let's go up. So here this one is the -1, -2, -3, -4, -5, -6. So which means this is the -3. So in that case it returned all the element from -3 to the first, which means to the end in negative direction. So you can see here it returned 3 to 1. And if you specify here sequences, square bracket, and specify here -3, then colon, then -2, and execute this, you can see it returns element 4. And remember, this is the starting index, so this index is included in the list, but this one is not included. So here ending is the -2 and starting is the -3. So let's go up here, and here let's find the element at -2. So here this is the 5 which is as -2, and this is the 4 which is at -3. So as you know, ending is not included, so this element is not included, but only -3 is included in this case. So remember, when we perform negative indexing, then it starts from backward direction, then it goes from end to start in this direction. Now you know about how to specify start or end index to get a slice of the list, but there is one thing that you need to know here, and that is the one more concept called step in slicing. So here if we specify here sequences, then leave it blank, then colon, and if I specify here 2 and close the square bracket and execute this, and you can see we get the element 1, 3, 5. So this one, after this colon, we specify the step value. So here step means extracting element at regular interval. So as you can see, it extract element at a regular interval here 1, 3, 5. If you are not sure, let's understand this with a simple concept. Remember, it is going to print every second element, or it is going to extract every second element. For example, you can see here we have the list sequences here. Let's copy this one from here and paste here. And as you can see, this list contains 6 elements total. So here you can see in starting, we are saying start from the beginning. And then we are also saying ending that include everything. And after that, we have specified step 2, which means start from the beginning and take every second element. So that means you can see here in this output, it starts from the index 0, which is the element 1, and that element is included in the list. Then from here, count the second element. So this one is already included. Count from here 1, and then this is the second element. So it included the second one. And after including that value, then again count from here 1, and this is the second. So it included the 5 value. And after this, we get only 1 value. So slice extraction stops here because there is no enough element in the list to slice. So remember, this steps means extract every second element. So if you specify here 3 like this, then it is going to extract or include every third element in the list like this, you can see. So it starts from first element. Then after this first, count 1, 2 and 3. This is the third element, so this third one is included. And after this, count 1 and 2, and there is no third element, so a slicing will stop here. So this is the concept of a step. And now let me show you general index, how you can perform a slicing. So here specify the iterable, and this iterable will accept a 2 colon within a square bracket like this, and then here you specify start, then end, and then specify step like this. This is the complete syntax for performing a slicing. Now you know about slicing, and remember you can also perform a slicing on a string. For example, here if I specify name equal to James like this, then you can perform a slicing on this string because we can refer the character of the string using index. For example, if I will specify here name, then if I specify here 2 and close the square bracket, execute this, you can see it returns the element at the second position within the string. So we can apply slicing here. We can specify here name, then a square bracket, and we can say start from 2 and end at 4 like this, and execute this. You can see it returns 2 element ME. And this is the same concept that we learned above, which means we can also apply it on a string. Also, you can perform negative indexing like name, then here specify -3 and then colon, close this, execute this. You can see it return character in backward direction SEM. And remember one thing, by default the step value is equal to 1 when we do not specify this step. So in the above examples, you can see here we have not specified step in any of this. So by default step is 1, remember. Now this is all about a slicing in Python, and remember you can do a slicing with the collection or sequence that you can refer with an index. In this section we are going to learn about OOPS concept in Python. So what is a OOPS? OOPS stands for Object Oriented Programming. And what is Object Oriented Programming? It is a way to structure code by bundling related data and the methods, and remember methods are function. And these methods operate on the data into objects. Maybe at this point you don't get what is Object Oriented Programming, but you will understand it soon. And OOP concept help us organize a large and complex code in a more intuitive, maintainable and reusable way. There are some OOPS key concepts that you need to know, and the key concepts are these 8 concepts. So first is the class, second is attribute, third is the method, fourth is the object, and fifth one is encapsulation, then inheritance, after polymorphism and abstraction. So first we will understand about class, attributes, methods and object, and after this we will understand encapsulation, inheritance, polymorphism and abstraction. Now let's start with the term class. So what is a class? Class is a blueprint. Suppose you want to build a house, then you will go to the architect or civil engineer and you will say, hey, I need a house and you need to build the blueprint. So the class is like that blueprint. And when the house is built from that blueprint, that house is called object. So what is object? So we can simply say object is a instance of the blueprint. So remember, class is blueprint. It means it is a house blueprint, and when your house is ready, where you can live, that ready house is a object. So that is called instance of a blueprint. Now the next term is the attributes. What is a attributes? Attribute is nothing, it is your variable that you already learned, where you can store your values like integer, string or list. So these are the variables that belong to the class or objects. And then we have the term called methods. What is method? Method is nothing, it is the function, and this function can manipulate on the data of the class or object. So what happens when we build a class? We include attributes plus methods in the class, and then we instantiate or create a object from this class, and then using this object we can work on the attribute. Whatever the value that you stored in the attribute, we can manipulate using these methods. And remember, methods is also called behavior of the class. So method is behavior. Now let's take a real world example. So to create a class in Python, you need to specify keyword class. And after this, you need to specify the name of the class. So in this case, we are going to name it house. And then colon, then hit enter. And now you are in the body of the class. Remember, this is the indentation before this. So this is the body of the class. Whatever you will define here like attributes and methods, that method will belong to this blueprint or this class house. Now here there is an important function that you will define in every class, and that is a init function. So specify here def, then double underscore, then init, then double underscore, and then parenthesis and colon. So this is the special method, and this method will be defined in every class, remember. And here to this method you will specify first parameter as a self. And at this point, I know that you do not understand what is this init and self, but for now just understand this. This is the initializer function of the class. So when you initialize or when you create an object from the class, then the object contain attributes. To initialize those attributes, this initializer function is used or called. And here self is a tag that is attached to each class to identify the objects. So here after the self, you can specify any number of parameter like a regular function. So here we are going to build the class of house or a blueprint of house. So house can have attributes, and remember, attribute is a details of the class. So here the house can have details like a color of the house, size of the house, and number of rooms in the house like this, and then hit enter. Now let's define the attributes or the variables of the class on which a methods will operate. So here specify self dot color equal to color, then self dot size equal to size, and then self dot number of rooms equal to number of rooms. So here at this point you may not understand what all these, but you will understand it soon. For here just understand we have created or defined the variable color, size and number of rooms, and then this variable value will be initialized when this init method will be called with the argument color, size and number of rooms. And here let's define the methods, behavior, or you can say function of the class. So here the first function is a open door, because in house you can perform a function, you can perform an action, and that action can be opening door. So here specify open door, and then remember to each function specify self parameter. And then here we are going to print, and here we will print the door of the self dot color. Then house is now open. And as you know, when you have a blueprint of any house, you can build any number of house in real world. Similarly, the class is like a blueprint, so we can create any number of objects. So when we create a number of objects, we can open any of the house. So color is necessary to know which house is open. Now next, let's create another function, call it turn on lights, because this is also a function that you can perform in the house. You can turn on the lights of the house. So here specify print, then within this specify the lights in the self dot size house are now on, like this. And let's add one more methods, and the methods is a lock. We can lock any of the room in the house, and remember specify self to the methods, also to this one self, like this. And then simply print here the self dot size house with self dot number of rooms is now locked. So here we have created a class named house, and then we have created some attributes like a color, size, and number of rooms, and these are the behavior of the house, or functions or method of the house that can operate on these attributes or variables. Now our blueprint is ready, our class is ready. Now it's time to create a real house or objects from this class or from this blueprint. So how we are going to do that? And that is very easy. All you need to do here is simply specify name of the class, then parenthesis, and this whole thing is called constructor. And before this specify equal, and now specify your house. And then while creating object, you need to provide the argument to this constructor, and the arguments are color, size, and number of rooms. So for example, here we can specify the color of house is blue, and the house is large, and the number of room in the house is 5. And as soon as you execute this line, this creates a object named house, and that object is initialized with the value that we provide within the argument. And when we create these objects, behind the scene this init method is called, and what it does, it initializes the attributes of the class that we have defined here with the value that we pass as argument. Okay, now we have the object house. Using this house object, we can access all the attributes or the data or the function or the behavior of this class. For example, just simply specify here house, then specify dot, and after that you can specify here color attributes. What it does, it keeps the color of the current house or the color of the house object. So execute this line and you can see the color is blue, which is correct. We have specified while creating the object. Now here specify house dot size. It will give the size of the house, which is large, and then you can specify here house dot number of rooms and execute this. We get the error because there is a error in the attribute name. Let's go up here and see, and we can see here we have messed up. So fix the name of the rooms and specify like this. rooms. Now again execute this whole code, then this one too, and also this one, and now execute this. You can see the number of the room is 5. So using this dot operator, you can access the properties or the methods of the objects. And here the object is a house. So if you specify here house dot, and then to access any of these methods or behavior, specify open door like this, and then execute cell, and you can see it shows the door of the blue house is now open. Similarly, specify object, then dot, then here we have the method turn on the lights. So copy this one and here paste, specify parentheses, and we get the error. So it is a light. Execute this and you can see the lights in the large house are on. Similarly, you can call the house dot lock to lock the rooms, and you can see the large house with 5 rooms is now locked. So this is how you can call the function of the class, and this is how you can call the attributes of the class. But as I told you, this class is a blueprint and we can create any number of objects. So here we have created a first object named house. Let's create one more object, house1, and equal to house, and then this time we are going to build different house, or we are going to build different object with different properties or attributes. So here I am going to give a house color as a green, and the house size is a small, and the number of room in the house is a 2. And execute this. We have created another object house1. So always remember, when you execute this line of code, behind the scene this init method is called automatically, and this init method takes this argument values that we have provided here and initialize these variables or attribute with those values, and then this method can operate on those attribute. So if you go up here, and here we learn bundling related data and the method that operate on that data into objects. So we created objects, and then those methods that we have defined like a lock, open door, and turn on light operate on the data. That means that can access data, that can manipulate the data in the class. So here we've created another object from the same class blueprint, and then here we can specify house.1.color and execute this. We get the color green. Then again house1.size, it gives the size of that house, and then here house1.number of rooms like this, and when we execute this it gives number of the room. So here I told you this self tag that you see here, this allows each object to identify the data, the method. So here behind the scene you can see we are using the same class to create a different object, and that difference is identify the self tag, otherwise you will get the same result. Similarly, you can call the function house1.open door like this and execute this. You get the message the door of the greenhouse is now open. So you can build any number of objects. So here I want to introduce two terms, instance and instantiation. So what is instance? So when you create this object like a house3 equal to house, and the house color is a orange, and the size is medium, and the number of room is a 3. So what happens here, we are creating instance of the class like this. So sometimes instance and objects are same thing. In programming, developer consider instance and object same. So this house3 is called instance or object, and the process of creating the object is called instantiation. Remember, when we execute this line and our house3 is ready, then the process of creating object is called instantiation, and the created object is called instance or the realization of the object. I hope that you understand what is an instance and instantiation. Okay, let's take one more example. So here we are going to create the blueprint for the dog. So here first you need to specify the keyword class, then the name of the class, which is a dog in this case, and colon, hit enter. And as you know, you need to create a first method, which is a init or initializer, and this method takes the first parameter, and this first parameter is self. And as you know, self is a tag that is used to represent the current object or current instance. And then you can specify different parameter within this function. So first is the name of the dog, second is the breed of the dog, and then third is the age of the dog. And we will initialize the variables like self dot name equal to name, self dot breed equal to breed, self dot age equal to age. So we defined our initializer function, and as you know, this function becomes active when we create an instance, and this function is called when we create an instance of the class. And then you know, dog can bark, sit, and fetch. So here fetch means dog can bring item. If we say, hey, bring the ball or bring something else. So bark, sit, and fetch is the behavior of the dog. So let's define this as a function. So first function is the bark, and as you know, each function accepts a parameter self, and then within function we are going to print here self dot name, and then is barking. So which dog is barking, and that can be known by calling this bark function. Similarly, let's create a function def sit dog can sit, specify the self parameter, and then specify here print, and within this specify self dot name of the dog, and then it's sit, or we can call it here sitting. Similarly, let's create a last method fetch. A dog can bring any item, specify the first parameter self, and then here specify print, and within this specify self dot name, and then fetch the specific item. So we have not specified here item. Let's define the self dot item equal to item and add one more parameter item like this. So we have defined our class dog, which has a initializer function, and this function initializes the following attributes: name, breed, age, item, and also dog has a behavior like bark, sit, and fetch. Let's execute this code and now create the object or instance of the dog. So here I will call dog equal to then dog and parentheses, and within parentheses we will provide the values. So here first value is the body, and this is the name of the dog, and second is the breed of the dog. So breed is the golden retriever, and then pass the dog age is 3. Dog is 3 years old. Now execute this, and at this point you can see here this item is showing error because here we have not specified the item. So what we will do here, instead of here we are going to remove it. We will not accept this. We are going to accept this in the method. So specify here item like this, and sorry, I apologize for that. Now again execute or create the class dog and execute this line, and now we get the dog object or instance. So now here if we specify dog.name, we get the name of the dog, which is the buddy. Dog.breed, we get the breed golden retriever, and lastly dog.age, we get the age of dog. Now we can call the method dog.bark like this and execute this, and you can see here buddy is barking. You can also specify here dog.sit. Now dog will sit, so buddy is sitting. And also you can tell dog to fetch some item. So specify dog dot fetch like this, and the item that dog will fetch. So in this case it is going to fetch ball. And now here execute this line and it is showing buddy fetch the ball. So this is how you can build the class in Python and how you can define attributes or the function methods. And if you remember, as I told you, whenever we create a class, we define this init method, otherwise we will get error. And that is correct in some cases. So which means you can define the class without defining this init function, because this function only initializes the attributes with a value that we provide while creating the object. So for example, we can create another class called dogs, and then we can directly define a regular function like a bark, and this function will print a simple message on the screen: the dog is barking, like this. And execute this and your class is created. Now you can create a object like this, dogs, and this time we don't need to provide any argument because we have not defined any kind of initializer in this class, so that may raise error. So providing argument this time will raise error. For example, if I will say here dog name is a Tommy like this, then execute this, you can see we get the error, type error, dogs takes no argument, because we have not defined any initializer here, so remove it. And now if you execute this line, the dogs object is created. Now you can use this to access the function bark, and execute this, you can see the dog is barking. So initializer ensured that the object always created with the right attributes. So as you can see in this class, we have not defined any attributes like name, breed, but we can define the attribute using the object. So specify here dogs dot and then specify the name, and this is the attribute, and name is equal to like Tommy this time. So this line will define a new attribute name with value Tommy manually. So execute this, and now next time when you refer dogs.name, you can see you get the Tommy as the name of the dog. And similarly, you can also define one more variable, dogs.breed, and here you can specify golden retriever like this, and then execute this, and next time you can access this attribute dogs.breed like this. So now I hope that you understand what is the use of initializer, and let's understand why to use this self. So as you can see here, we are using self. So as I told you already that self is a use to represent the current instance or current object of the class. So suppose you create this dogs1 equal to dogs, and then you create another object dogs2 equal to dogs. So how the Python is going to know both the object is different, and that can be known by specifying the self. So this self allows Python to identify different objects with different or related data. So here if you execute both this, and this time if you specify here dogs1 dot name equal to Jimmy, and then next to it specify dogs2 dot name equal to Ronnie. So execute this, and next time when we specify dogs2 dot name, then it is going to return the name of the dogs2, which is Ronnie, and this identification is done with the help of self tag or self keyword that we use in the class. Now I hope that you understand why to use init function and why to use self in Python. Now let's understand the key concept, encapsulation, inheritance, polymorphism, and abstraction in Python with a simple example. So first, start with the encapsulation. What is encapsulation? Encapsulation is the concept of hiding data and methods inside a class to protect the object internal state from being modified directly. And it can be achieved by making attributes protected and private using the underscore and double underscore. So what this mean, attributes protected and private? To understand this, let's go up and look for the example, the dog. You can see here we have defined the three different attributes: name, breed, age, and these attributes are called public attribute, which means you can access this attribute directly by specifying its name, like name and breed here. But in case of private, you can't do this. You can't access the value of the attribute by specifying its name, like here dog.name. So when you define the attributes like this within a class, then this is called public attributes. Now let's come back, and here we're going to take an example, and in this example we're going to create a new class called customer, and this class will have a initializer method in it, and then first parameter is self, second is the name of the customer, and third is the age of the customer. So customer will have two parameters, name and age. Now let's create a attribute self.name equal to name, self.age equal to age. Now at this point we are not going to define any of the methods, we will define later, but for now let's create a customer object and specify the name of the class, then parentheses, and within parentheses we need to provide two parameters. First is the name of the person, which is a row, and second is the age of the person, which is a 23. So as I told you that this time you can see here these attributes are public attributes. Now if you execute this code, you can access the public attribute by specifying its name, like customer.name, and execute this. You can see we get the value. So if you specify here a single underscore like this, then these attributes are protected. And in this case, you can also access this attribute outside of the class like this. By specifying name of the attributes correctly, and you can access the value of the class. So why it is protected? Protected means you can't use this variable in the derived class, and that you will understand in the concept of inheritance. So for now we will understand only about a private attributes. So to make this public attribute or convert this public attribute into private attribute, you need to specify double underscore before the name of the attribute like this. And now when you execute the cell, this time this class contains two private attributes. And now if you try to access these attributes like this, you can see you get the attribute error, because when the attributes are private, you can't access those attributes outside of the class like this. So this is the private variables. Now if you want to modify this variable or assign or update the value of this variable, you can do that by using the function that is defined within the customer class. For example, let's create a function def.getCustomer, and this function will return the name of the customer and pass the first parameter as self, and here this function return self.name. And now let's create one more function, def get customer age like this, and then self and return self.age. Execute the cell, and now you can't access the value of the attributes directly like this. We will always get error. To get the value of the attributes, we can call this method customer name. So specify here get customer name like this, and when you execute this, you can access the value of the attribute name. So which means you can only modify or update the value or access the value of attribute using the function defined within the class like this. So this is how you define private attributes in a class, and this is the concept of encapsulation, where the data and methods are hide within the class to protect object internal state from being modified directly. So you can build one more method, and this method will allow you to modify or update the value of the attributes. For example, create method def and specify method name, set customer, and then specify yourself, and it is going to accept two parameter, name of the customer and age of the customer, because using this method we will update the value of the name and age. And then here, if name exists, if customer provide the name, then it is going to update the self dot double underscore name equal to name, otherwise elif. And if the customer provide the age, then in this case it is going to update the age of the customer. Then you can update like this. And lastly, else part, print invalid input. And this is just a simple example. And now let's execute this and also execute this one. Let's try to get the age of the customer. So specify here object customer dot get customer age, like this. We get the age. Now we can update the name and the age by using this set customer method. So we can specify here customer dot set customer, like this. And suppose we want to update the age, so specify the age as a 24, like this. Let's also provide the name here, so I'm going to change the name to James and age is 24, like this, and execute this. And now let's access the name of the customer, get customer name, like this, and execute this. And we can see we have updated the customer name from Rock to James. Similarly, customer age is updated. So here you need to understand two things. First, you define the attributes as the private, and this attribute can't access directly outside of the class by specifying its name. And the second is you can define the method. That method can access the value of the attributes or modify the value of the attributes. So now I hope that you understand what is a encapsulation. Okay, now let's understand the next key concept, inheritance. So what is inheritance? Inheritance allows a new class to inherit or get the properties and the methods of existing class. It enables code reuse and helps in creating hierarchical structure. So here we have defined the attributes and the function. So we can retrieve or get or take these attributes and methods to another class without defining again and again. That means inheritance. And if you are confused about what is inheritance, let me explain with a simple example. For example, suppose when you born or when a new baby or child is born, then the family of the people say that the child got the eyes of the father, or maybe got the face like the mother. And as you can see here, these features like eyes and the face is coming from the mother and father. So in this case, we can say the child inherit some properties from the mother and father. So in this case, child inherit eyes or the face from the parents. Similarly, here consider parent as the base class and the child is the derived class. So let's take a simple example. For example, here let's create a class animal, and this animal class will have a method initializer init, and then specify first parameter self. And as you know, animal will have a name and create the name variable or attribute self.name equal to name, like this. And now, as you know, each animal can drink, so create a variable drink and then specify the first parameter as a self, and then here we are going to print F, then here specify animal name, then is drinking, like this. And you also know that each animal can eat. So this both function can be done by any of the animal. So define this function eat, and I'm going to copy this from here, paste it here, self.animal name, and specify here eating. So this is the animal class, and as you know, each animal can do two things. First, it can drink and it can eat, and it applies to all kind of animal. Now let's create a class and name the class dog. And as you know, dog can also drink and eat. So what we will do here, we are going to define all these properties in the dog class also. And here you can see when we define these two properties again, like if I go here, copy from here and paste it here, you can see this is the same properties. So here we are duplicating the functionality like a drink and eat, but we don't want this. So what we can do here, we can use the concept of inheritance. So what we will do here, we will simply specify animal like this. And this lines means this dog inherits properties from the animals to this dog class. And remember, this animal class is called the parent class, or it is called base class. And this class is called the child class or derived class, because this dog is deriving all the properties or all the methods from the animal class by specifying the animal class within the parenthesis of the dog class, like this. So remember the syntax. Whenever you want to get all the properties or method from the another class into the new class, just specify that class within the new class, like this. Now this is the new class. We can also define the init method for this class also, like this, and then self, and then name of the dog, like this. And after this, within this div function, we will need to call the initializer of this base class to initialize the attribute value. And to call the initializer, we are going to use the super method, and then dot, and then init method from the animal class, like this. And to this initializer, we need to pass the parameter name. So whenever you are going to create a derived class from the base class, always specify super.init within the derived class, like this, to initialize the properties of the animal class or the base class. And after this, you can access all the methods and properties of the animal class by specifying the class properties or methods. For example, let's create a new method for this dog class, and then specify the name of the method as a routines, and then pass the self parameter like this and hit enter. And now as you can see, we have now defined this drink and eat function for this dog class, but we can access these functions or the method within the dog class because we are inheriting all the properties or method from the animal class by specifying animal within the parenthesis, like this. So a dog can eat, dog can drink, and finally what we can do here, we can define own methods or function for this dog class. So let's create one more method called diff bark, and then specify self, and after this here we're going to print the simple message. So copy it from here and paste it here and change it to bark. Here let's create one more class called cat. So cat is going to have the same properties. Copy this one, paste here, change the class name to cat, and cat is also inheriting all the methods or properties from the animal base class. Then here instead of bark, specify meow, and then cat will do meow meow like this. So here we have defined two classes, dog and cat, and these two classes inherits all the properties or methods from the animal class. So remember, the cat and dog is a child class and animal is a parent class. Now let's execute the shell to create these classes, and now let's create the object. So here I'm going to create the dog object and call the dog like this and specify the dog name. So here I'm going to give a dog name as a boomerang, and then also create a cat object called the cat constructor and specify the name of the cat as a snowball like this. And now execute this. We have created two objects, dog and cat. So here again I'm reminding you, we have not defined the function drink and eat within the dog and cat, but we can access those methods using the dog and cat objects. For example, here if you specify dog dot routines, call the method routines like this and execute this, you can see we can access all the method from the animal class that we have defined here. So we are accessing this method within this routine method of the dog class. So here I'm going to add this self dot bark like this and execute it, and now we can access dog methods also. Similarly, if you specify here cat dot meow and execute this, you can see snowball meow meow. As you know, this method is defined within the cat, and now we have not defined drink and eat. We can also access the drink and eat like cat dot eat, execute this, snowball is eating, cat dot drink, snowball is drinking. So here this is the power of inheritance. We just need to write like this, then initialize the animal class, and now we can access all the methods or the attributes of the animal class within this new derived class. Now if you remember from a previous video, I told you about the protected and private member or attributes of the class. So at the time I told you I'm going to explain protected member in inheritance concept. So here in inheritance, if we specify here underscore before the attributes, so what happens, this attributes become protected member. Protected members means use this attribute or the member within the base class or the derived class if you want. Otherwise do not use it outside the class, like you can not call it like a cat dot name like this. So this is the just indication to show that do not use the protected member outside of the class, only use within the base class or the derived class. This is just concept of the protected member. Let's understand the key concept in OOPS polymorphism. So what is polymorphism? Polymorphism allows you to use a single interface like a method operator to represent different types of object, and the same method can behave differently depending on the object calling it. Here let's break the word polymorphism. Here the term poly means many and the term morphism means forms. So polymorphism means many forms. If you remember, we can create a variable a and assign value 10, and then we can create a variable p, assign value 20, and now we can use the operator to add these two values. So for example, here we are going to use the operator plus to add the two value, and you can see result is 30. But also we can combine the string using this operator. For example, here I can specify C equal to James and D equal to rock, and as you can see this is the different name, but if we perform here addition like a C plus D and execute this, as you can see both string is combined. So here you can see this operator is acting or working like a polymorphism, which means this operator as many forms. When you use this operator with the integer, it adds the two integer value or find the sum. When you use the same operator with the string, it combines both the string into a single string that you can see here. So it has the same name and the same signature but behaving differently. Similarly, we learn about the length function. So length function return the length of the given objects. For example, if you specify here list and create a list of values 2, 3, 4, and then within the print function specify len and specify here the list whose length you want to find, you can see it return the length as a 3 because this list contains 3 elements. And similarly, if you find the length of this C string, so let's see len and execute this, you can see it returns 5. As you can see, this len function behaving in a different way with different objects like a string and list. So we can build operators or method like this using the concept of polymorphism. So let's go up here and you can see here we have created here the class animal, which is the base class, and then we created two derived class dog and cat. So here let's add another method to the base class called sound. And as you know, animal can make a sound. So here specify self as the first parameter, and then simply we will print here a simple message is making sound like this. Here we can also define this same method with the same signature within the dog class like this. So I will simply copy this from here and paste here, and I will just change the implementation. So here I will say barking. So instead of this bark function, I will use this sound function. So I'm going to comment it out from here and from also here. And similarly, we can use the same function within the cat class, and instead of making, we can say meowing, something like that. Here let's execute to implement these changes, and then also create the object dog and cat from scratch. And then here if you specify here cat.sound and then execute this, we get the error. So error is cat object has no attribute name, because in a previous video we have specified single underscore here. Remove this one and again execute the whole code and then create a object dog cat, and then from here let's call the sound, and we can see here snowball is meowing. Similarly, you can specify here dog dot sound and execute this, boomerang is barking. As you can see here, the method sound is coming from the cat and dog, and the signature of or the name of the function or the method is same like in the animal class here. But here we have defined a different implementation like barking and meowing, so it is accessing this sound function. And this is the concept of polymorphism, because here we have the same function but behaving different in a different class. So for dog it is barking and for cat it is meowing. So this is the concept of polymorphism, which means you can have one function with a different actions. Last concept is abstraction, and in Python, abstraction is a key concept of object-oriented programming that focuses on hiding the internal implementation detail of an object and exposing only the necessary parts to the user. Python provides a ABC, which stands for Abstract Base Classes module, to implement abstraction. So using this module, you can create a abstraction classes. So what is abstract class? An abstract class is a class that cannot be instantiated on its own and serve as a blueprint for the other classes. So which means you cannot create the object from this abstract class. You can only use this abstract as a base class for the other subclasses. And this class contains one more abstract method. The method that you define within abstract class is called abstract method, and this abstract method must be implemented by subclass that inherits from the abstract class. So whatever the subclass inherit the abstract class, these subclass will implement the detail of the abstract method. And these methods are declared using abstract method decorator, and they do not have any code in them. Let's create a abstract class with abstract method. So first we need to import the module from ABC, then specify import the ABC module, and then abstract method, and create a class. And here I'm going to create a shape class, and this shape class will act as a base class for all the shape like rectangle, square, and any kind of shape. And in Python, to make any class as an abstract class, just pass this ABC, and this ABC stands for abstract base classes. Now here this shape class will have two functions. First function is the area that can calculate the area of shape, and second is the perimeter that can compute the perimeter of the shape. So in abstract class, to create an abstract method, we need to specify decorator at abstract method like this, and then after this define the method, and that method will be a abstract method. So here first method is the area, and specify the self, and within method we are not going to specify anything. You can see here methods are declared using abstract method decorator, and they do not have any code in them, because the code that we want to specify, we will not specify in this abstract class. We specify all the code in the subclasses which inherit this shape class. You will understand that soon. Let's create one more method and name it perimeter like this, then self, and here also specify pass. And if you remember, pass does nothing. It means you are going to write the code in future, you will not write now. So if you remove this pass and execute this code, then it is going to show the error. So we use here pass so that whenever we create this class, the error will not generate. Now we have created abstract class, and now let's create another class and name it rectangle. And this class will inherit shape class, which means this class is going to have all the abstract method defined within this shape class. Now first function is the initializer function or init function, and this function accepts self. Then a rectangle will have a width. Also rectangle is going to have the height. And now, as you know, you need to here call the super method, then call the init, and this init will initialize the base class, and here specify self, then specify width and height like this. Now after this, here create one more method, name it area. Actually we are not creating here method. This method is coming from the shape class, only we are implementing its detail. So here we are going to implement self.width, because the area of rectangle is a width into height. So self.width into self.height like this. And also let's specify the method perimeter like this, and then here it will return 2 into, and within parentheses specify self.width plus self.height like this. So here you can see in the abstract class, for the abstract method, we have not specified any detail. We are saying here we will specify these detail in the subclass which inherit this abstract class. So you can see here rectangle inherit this shape class. So here we have implemented the code of the method that we defined in the shape class. So here I made a mistake. We don't need to include this super method with init, because in the shape class we have not created any def init initializer like this, so we don't need it here. If we specify def init in this class, then we will need to use here a super dot something like that. So simply what we will do here, we will call it here self dot width and specify the width and self dot height and specify the height like this. And now again execute this, and here let's create an object rectangle, call the rectangle class like this, and then provide a two values 10, 20 like this, and execute this. We have the rect object of a type rectangle. And now let's check it. So here let's find the area of the rectangle. So simply specify the object dot and then call the method area like this. Execute this. Now you can see it returns area of rectangle is a 200 with width 10 and 20. Let's also find the perimeter. So call the perimeter function like this and execute this. You can see it returns perimeter of rectangle is 60. So here again I'm going to explain abstract classes. So to create any class as an abstract class, pass this ABC to this abstract class, and this ABC is imported from this ABC module. Then within the abstract class we create an abstract method, and these abstract method don't have code in them. So we simply specify pass because the code will be implemented or will be included in the subclasses which inherit this abstract class. And remember, before defining any abstract method, you need to specify this add abstract method decorator like this. Whatever the class that inherit this abstract class will have all the abstract method defined in the abstract class. And now you can specify the implementation of that abstract method within the subclasses like this. So I hope that you understand how to create an abstract class, how to create abstract method, and how to implement the detail of these abstract method in the subclasses. Up to now, you learned much about functions, variable, classes, and some of the OOPS concept. Now there are some built-in function that comes with Python when you install the Python on your computer. And we will explore each of the important method, not all the method, but we will explore some essential method that you will always need. So I'm going to start with the method called a print method or print function. So here, as you know, this print method takes argument and print those argument on the console. For example, you can specify here a string hello, and then if you execute this, you can see it prints that string on the console. So similarly, you can give any kind of argument to this print function. For example, you can specify integer. You can give a list of values like a 1, 2, and 3. And also you can give a string. You can specify float 4.0. And you can specify any objects that you want to print on the console. And if you execute this, it will work fine. And it's going to print all the objects on the console. But here I want to show some of the parameter or the key argument that accept print function. For example, if you print this name of the person like a Bobby and Rock and execute this, you can see here it prints name of the person in the same line. If you want to insert a new line, I mean if you want to print this Rock in the second line and Bobby at the first line, you have to specify /n, and this /n means insert a new line. So after the string Bobby, it inserts a new line and the Rock will be printed to the next line. So when you execute this, now you can see Rock is printed or displayed at the second line. So in Python, by default, when you print any of the string in the Python, and each string is printed on the next line. So here, if you print this separately like a Rock and execute this, you can see each of the string printed on the different line. So by default, this print function accepts a /n that we have specified here, and you can change that by using the key argument called int. And when we specify int equal to /n, then this part is equal to this one. So by default, what happens, this print function accepts this key argument. So you can change this, you can specify here like a dot and execute this, and you can see after the James we have dot, and now the rock is in the same line. And if you specify here /n and execute this, now you get the same result as before, because /n means insert a new line. You can specify any of the strings here, like you can specify 3 exclamation and execute this. You can see after the end of the James you get the 3 exclamation. So this is how you can use the end to specify the end values for the string or any of the object. Now there is one more parameter that is accepted by the print function is called separator. For example, here if you specify a string like a James and as a second argument specify a rock like this, and when you print this, it prints both James and rock, but you can see there is a space between this James and rock. Suppose instead of this space you want to use any other string or a symbol. For example, if you specify here separator equal to, and if you specify within a single quote like a hyphen or a dash and execute this, now you can see there is a dash between the James and rock. Even you can specify here asterisk symbol and execute this. Now you can see this is the asterisk symbol. Here I want to mention you can also format the string within the print function. For example, let's define variable a and assign value 10. Now specify print function, and within parentheses you can specify here f, then use the single quote or use the double quote like this. Then here you can write a string that you want to print like a this is the integer, and then within this string you can insert the value of the a by specifying the curly braces, and within curly braces specify the variable or object whose value you want to insert. So if you execute this, you get the value, this is the integer 10. So remember, specify f, then use either single quote or double quote, and within this you can specify regular string, and you want to insert the value of the object or variable, just use the curly braces, and within curly braces specify the object or the variable whose value you want to insert with the string like this. So this is all about the print function in Python, and there are some of the arguments that accept print function and that you will never use, so it is not necessary to know that. Now the next function is the enumerate function, and this function gives the item and its index. As you know, tuples and list contains a multiple elements, and these elements have a specific index that we can use to access those elements in the list. So for example, if I will create here a list fruits, and in this list I'm going to specify some of the fruits like a apple, then banana, and then cherry like this. And as you can see, this list contains 3 elements, and each element has an index. Apple has index 0, banana has index 1, and cherry has index 2. So if you want to access the index, you can use the enumerate. For example, create a variable fruits index equal to enumerate, and then pass the sequence or the list or tuple whose index you want to track, and next to it print fruits index like this, and execute the whole code. And as you can see, this enumerate returns a iterable, but you can print that iterable using the print function. Here you can see it says enumerate object at this memory location. So for that we will need to use the for loop. So here you can specify for, then we need 2 things, index and the item. So specify here index and item in fruits index, and then print both the thing. So here specify f, then insert the index, and then colon, and then insert the value or the item of the list like this, and execute this. We can access the index 0, 1, 2 for the item apple, banana, cherry. Or what you can do, you can directly use this enumerate function within the for loop like this here and execute this. You will get the same result. So here now you can see the index of apple is 0, banana is 1 and the cherry is 2. But if you want to start the index from the 1, then this enumerate function accepts one more argument called start. So for example, let's copy this and paste here. And here specify the second argument called start equal to 1. And this time the index will start from 1. Let's see, and as you can see now, the starting index of the apple is 1, banana is 2 and cherry is 3. If you specify here 3, then index will start from 3, 3, 4 and 5. So this is how you can use the enumerate function to get both index and item from the iterable like a list and tuple. Now you can also use the enumerate with the string. For example, here I am going to create a string Python, and here let's call the for loop for index, and then it can grab all the character from the index, then specify here enumerate and then specify the string like this and print here f index then colon and then character like this. And now execute this and we can see here it prints index for all the character in the string Python. Similarly, you can also specify the start parameter here and you can say start the indexing from 1 and execute this. Now you can see indexing start from the integer value 1 to 6. And here always remember why to use enumerate. So when you need both index and the value of item in a loop, use the enumerate. It can help make your code cleaner and easier to read by avoiding the use of a manual counter. Next built function is a round function in Python, and this round function is used to round a floating point number to a specified number of decimal places. By default, it rounds to the nearest integer, and this round function takes a two parameter, and first parameter is the number that you want to round and second is the AND digits. This is the decimal places. So the second parameter is the number of decimal places to round to. If omitted, the function rounds to the nearest integer. So let's understand with an example. For example, here let's create variable result, and in this variable I'm going to store the value 4.6. Now let's use the round function to round this number. Here specify print. Within a print function, use the round function, and within round function provide the result variable which contains the value 4.6. Now execute this and you can see it rounds the number to the nearest integer, which is a 5. Now one thing you need to remember here, whenever you are using this Jupyter notebook, you don't need to always use this print function to print something on the console. You can directly specify the variable whose value you want to print, or the function that you want to execute with the value, you can directly use it in this cell. So here, now we are going to round down the number to the nearest integer. For example, specify the round function, and within round function, if you specify value 4.4 and execute this, now you can see it round down number to the value 4. So here, one thing you must understand, while rounding the value, if the value is greater than 4.5, then it rounds value to the bigger number, to the nearest integer. In this case, it is a 5. But if the value is less than 4.5, then it's round down number to the nearest integer, which is a 4 in this case. Now, next, let's understand how to round a number to the specified decimal places. So, for example, specify round function, and within round function, provide the value like a 4.6, 7, 8, and 9. And then, suppose we want to round value to the 2 decimal places. So here, we will specify second parameter, which is a AND digits, and we want to round to the 2 decimal places, specify 2 here and execute this. Now instead of 4, we can see here number is rounded to the 2 decimal places, 4.68. Similarly, you can round number to the 0 decimal places with a no fraction part. So here, specify round function, and within round function, specify the value 1, 2, 3, then decimal places 4, 5, 6, and round to the 0 decimal places, specify 0 and execute this. Now you can see it round number to the 0 decimal places. You can also round a negative numbers. For example, specify here round, then within round number provide a negative number 4.678, and suppose we want to round it to the 2 decimal places, so specify 2 here and execute this. Now you can see this negative number is rounded to the 2 decimal places. So this is the use of the round function. But what happens if you have the value like round 4.5, and how it is going to round this number? Is it going to round this number up or down? So let's see this. So let's execute this, and you can see it round down the number to the 4. So let's take one more example, and here specify round and then specify 2.5 and execute this again, and you can see it round down number to the 2. So whenever this round function encounter the half number like 4.5, 2.5, 3.5, 10.5, then it's round the number to the nearest even number. So you can see here 4 is the nearest even number, so it round to the 4, and in this case also 2 is the even number, so it round to the nearest even number, which is 2. What happens if you specify 3.5? Round and specify here 3.5 and execute this. Now it round to the nearest even number, which is 4. So in this case, you know this 3 is an odd number, but this round function rounds the value to the nearest even number. So the nearest even number in this case is 4. So this is all about a round function in Python, and you will use it a lot. Next function is the range function, and this range function generate a sequence of number and commonly used in loops for iterating over a block of code a specific number of time. So this range function accepts a 3 parameter start, stop, and step. And if you remember, this 3 parameter is familiar, and it is familiar because you learned about slicing. So here the first parameter is start. This represents the starting number of a sequence, and the default is 0. Then we have the parameter stop, and it represents the number at which the sequence stop, but not included this number. So as you know, when you specify here any of the number, that number is not included in the sequence that is generated. And lastly, we have the step, and this is the difference between each number in a sequence, and the default is 1. So let's take an example and understand how to use this function. So here, if you specify sequence and sequence equal to range and specify here 5, then print sequence and execute this, you can see it outputs the representation of the same sequence. But as you can see, this is not more detailed. We need much information about the range. So here when you see output like this means it is iterable, or the object you can use here for loop to get all the values. So here specify for in, then specify the sequence like this, or here I forgot to specify the variable x in sequence, and then I'm going to print x and execute this. Now you can see it prints all the value which is generated by the range function here. Similarly, you can use the range function in a for loop directly for x in range and specify 10. And remember, when you specify 10 here, it is going to generate a number from 0 to 9. And this specified number is exclusive or not included in the list. And now print x, execute this. You can see it generates number from 0 to 9. Let's use the second parameter. So for here, specify for I in range, and first parameter is the starting. So I want to start the number from 1, and then I want to generate 15 numbers. So in this case, it is going to generate a 1 to 14. So here print I and execute this. You can see it generates number from 1 to 14, but this time default value is changed to 1. So it start the number from 1, not from 0. Now let's take one more example, and here we will specify all three arguments. For example, if you specify here for I in range, and we want to start the integer from 0, and then we want to generate a 10 number, and we want difference of 2 between numbers, and then let's print the I value like this, execute it, and you can see it prints all even number. First it starts with 0, then after 2 steps it prints 2, then 4, then 6, and then 8, and as you can see there is a difference of 2 between each number. So this is the work of the third parameter, which is the step. Now you can also generate this number in a negative direction. For example, here we have generated number from 1 to 14, but we can reverse this. We can generate from 14 to 1. For example, let's copy this one and here paste, then specify third parameter as a -1, and then change this to 15 and make this 15 as a 1 like this. And now execute this. You can see it generated number in reverse direction from 15 to 2. As you can see here, it ends at the 2. So here if you specify 0, then it ends at the 1, and execute this. Now it is perfect from 15 to 1. This is how you can use the range function to generate a sequence of numbers in a positive or negative direction. Next function is a slice function, and a slice function is like a slicing concept that you learned in the previous videos or sections. So a slice function in Python is used to create a slice object that specifies how to slice a sequence such as a list, tuple, or string. It defines a start, stop, and step values for a slicing and allows you to extract a portion of the sequence. So if you remember, you learned about a slice and where you specified the list, and within a square bracket you specify start, stop, and then step. So remember, this slice function performs the same task. So let's see how to use this slice function. For example, here we have my list, and this list contains several integer values like a 0, 1, 2, 3, 4, 5, 6, 7. And now first you will need to create a slice object, and let's specify variable s equal to and use the slice function to create a slice object. And to this slice function provide the start, stop, and step values. So here I'm going to only provide two values, start value which is 2 and stop value which is 6. And as you know, it starts from index 2nd and goes to index 5, but it does not include the 6th index because it is a exclusive, or if you remember, stop is exclusive. Now here let's specify print function and specify the list and then a square bracket, and here within a square bracket you need to pass the slice object s like this. And now execute this. We get the error. Let's fix it. So here we need to specify equal. Now execute this again. You can see here it extracts the elements from index 2 to 5 since 6 is a exclusive in this case. So remember, when you are going to use the slice, first you will need to create a slice object with a start, stop, and step indexes. Now let's see how to use the third parameter step to skip the elements. So list is same. Here I'm going to create one more variable called k. K is equal to a slice, and then I want to start the slicing from index 1, and then it stops at 7 and with step 2. And here specify print my list like this, then square bracket, and within a square bracket pass the object and execute this. You can see this create a slice index from 1 to 6, but with step up 2, so it selects every second element from the list you can see here. Now let's see how to use this slice function with a string. So here create a myString variable and assign some string like a hello world like this, and then create a object O equal to a slice, then here specify 7 and 12. So here 7 is the starting and 12 is ending index. Now specify print, then within print function use the myString variable, then square bracket, and then pass the object O. Execute this. You can see it extract the string from index 7 to 12, and here 12 is exclusive. So as you can see in the output, it extract the character from index 7 to 11. Since 12 is exclusive, so it does not include the 12. Now you can also use the negative indexes in a slice function. So for example, I'm going to use the same myList that we have defined here, and here I'm going to create an object called q equal to, and remember here I'm taking different variable name, and specify the slice function, and then specify the starting index -4, then ending -1 like this, then specify print myList, then square bracket, pass the object, then close the parentheses, execute this. Now you can see it counts the element from the int of the list. So this is how you can specify the negative indexing. One thing I want to here tell you that you can specify default values with a slice function that you learned in a previous video while using the square bracket with colon notation. If you remember, we sliced the sequence using this list, then square bracket, and then colon, and then here any of the ending index like a 5. So how we can achieve this using the slice function? Let me show you. So here let's create an object t which is equal to a slice function, and then within this function to get this kind of what we can do here, first provide the non, then comma, then 5. And remember this thing is equal to this one, and here let's print my list square bracket t and execute this, and as you can see we get the result from index 0 to 4. Similarly you can swap this, you can write a non at the place of 5 and write a 5 at place of non to change the position. So this is all about slicing, and I hope that you understand how to use the slice function, and this function is very powerful for creating a slice object that you can use to extract portion of sequences like a list, tuple, string. Next we have the function called globals, and this function return a Python dictionary representing the current global symbol table. So what is this symbol table? This symbol table is a data structure maintained by the interpreter, and this symbol table stores information about variable, functions, and objects in your current code context. So here we have created this object, we are using this slice function, then calling print function, then here we have defined string. All these are stored in the symbol table, and this symbol table maintained by the interpreter, remember. So here I'm going to first clear the kernel or restart the kernels, and after restarting I will here create a variables like x equal to 10 and y equal to 20. And now if we execute this x and y variable are stored within a global space, or we can say it is stored in the symbol table. And to access this, we need to use the globals function here. For example, here I am going to create a variable global vars and then equal to globals function like this. So this function gives all the variable functions and objects that we use in our current code context. So let's execute this, and here let's print global vars and execute this, and you can see it returned all the variable function that we execute in the global context. And here you can see this is the variable x and y that just we have created here, and this is the global function we call here, so it is also recorded here, you can see. And then we use the global vars, and then we use the print function. So you can see everything that we write within the script, within the correct context, all the thing is recorded within the symbol table or within the global space. You can access the value of the global space. For example, type here print, then global vars, then a square bracket, and suppose I want to access the value of this x. So what I will do here, I'm going to specify x like this and then execute this, and you can see it returned the value 10. So here remember, all the information about variable function and objects are stored as a dictionary in a symbol table or in a global space. You can see here, this is the dictionary where you can see key is the name of the global variable as a string and the values are corresponding objects. So here you can see these keys are the variables and corresponding objects is the value you can see here. So this is how you can use the globals, and even using the global you can modify the value of any of the variables. For example, you can call here globals function like this and then square bracket, I want to change the x value to 50 like this, and now then I'm going to print here the value of x. Let's execute this, and you can see the value of x changed to 50. So we made that change using this global function. Okay, next function we have the locals, and local is similar to the global, but it returns all the variables, function and objects of the local space. For example, create a function, my function, and this function contains a two variable like e which is equal to 10 and y which is equal to 20. And now if we print here locals or call the local function, and then let's call the my function, my func like this, and execute this, you can see this local returns a dictionary containing the variables defined within the function. So whenever you want to know all the variables, function and objects within a function, then use the locals. Or here I want to tell one thing, that these locals we have similar to globals when we use outside of the function. For example, if I will specify here print and call the local function, then outside of this function this local will behave like a globals. So let's execute this, and you can see it returns dictionary containing all the variable functions and objects that we used in the current code context. So this is all about locals and globals. Remember, locals return a dictionary of variables within the current local scope, whereas a global returns a dictionary of a global variable. Now next function is all function, and this all function return true if all element of an iterable are true or if the iterable is empty. If any of an element in iterable is false, then all return false. And this is the syntax. Here we specify all function, and within all function pass the iterable. Now here let's understand with example how all works. So here I'm going to create a list, my list, and then I'm going to include some boolean value. So here I'm going to specify true, 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 and here you can see this list contains 3 elements, and these 3 elements are boolean value. And now here if you print all and then to all provide the iterable. So iterable is a my list in this case, and when you execute this you can see it returns true. So from the definition, the function all returns true if all the elements of an iterable are true. So here you can see all the elements of iterable is true, so this all function returns true. And now next it is saying if any element in the iterable is false, then it returns false. So let's make one of the element false and see what happens. Execute this and now you can see it returns false because one of the element of this list is a false, you can see here. And now here what I will do, I'm going to create a new list. I will call it a empty list and I'm going to make it empty. And now here I will check print all, then pass the iterable empty list and then execute this and see, you can see here for empty list it returns true. So this means whenever you pass an empty iterable within the all, then it is going to return true. If you remember, we learned about a truthy and falsy value, and while learning we understand that like a zero, non, false and empty list, empty string are falsy, and if the values are non-zero, non-empty object and true, those values are truthy value. Now instead of specifying here true false value, you can specify any value. For example, you can say here integer list and then if you specify here integer value 1, 2, 3, 4 and try to check if it returns true or false using all or not, you can specify here print all, then pass the iterable integer list and execute this, you can see it returns true. So in the section of truthy falsy, you learn numbers or non-zero numbers are a truthy value, which means they return true. So in this case you can see these are the non-zero number which exist within the list, so it returns true. What happens if we specify 0 within the list? So let's check it. Suppose here I add one more element but the value is 0, and if you remember I told you that 1 is equal to true and 0 is equal to false. So here let's execute and you can see it is returning false. Why it is false? Because as from the definition, if any element in the iterable is false, then all return false. So here these are the true value but 0 is the false value. So one of the element of this list is a false, so here all return false. Now let's use all with the string. So here let's create a variable string equal to, then specify list, and here specify list of string like hello, then world, then Python like this. And as you can see, this list contains 3 strings. And if you remember, strings are non-empty, which means they are considered as a truthy. So all function here must return true. For example, print all, then specify the iterable and execute this. You can see it returns true. And now here I want to check with a mixed data type. For example, let's create a variable mixed equal to, then specify different types of data like a boolean, then integer, then string, and then specify empty list. And now specify here print all mixed, then execute this. You can see it returns false. Why it returns false? Because here there is an empty list. Remember, in the above when we specified here an empty list, you can see this is the iterable. So in case of empty iterable, remember in case of empty iterable it returns true. But here within this iterable we have another empty list. So according to truthy and falsy rules, if we specify a empty set tuple list, then those are the falsy value or those are the false. In this case, these three elements are true, but this empty list is false. So according to definition of the all function, it returns false. Now next built-in function is any function, and this function is similar to the all function. So this any function returns true if any element of the given iterable, like a list tuple set, is a true, and if all the elements in the iterable are false, or if the iterable is empty, then any return false. This is the syntax of the any. Use the any function, then specify the iterable. Let's understand with an example. So here I'm going to create a list of numbers, create a numbers variable, and within this I'm going to specify false values. So 0, 0, then 0. And after this I'm going to specify any numbers like a 3. So this list contains 4 integer value. First 3 are 0 and this last one is a 3. Let's print and then specify any function, and to this any function pass this iterable numbers, and now execute this. You can see it returns true. So from the definition you can see here any function in Python returns true if any elements of an iterable are true. So here you can see here these three elements are false. As you know, 0 is equal to false in Python, and any of the number that is not 0 is true. So this 3 is a true and these 3 are false. So according to definition, one of the value is a true. So this any returns true as the output you can see here. What happens if I'm going to copy here and paste here, then change this to 0, and you can see all elements are false. So execute this and you can see it returns false. So from the definition, if all element in the iterable is false, or if the iterable is empty, then any return false. So here you can see it return false. Let's create a empty list or iterable and pass this iterable to the any and see what it returns. Execute this, you can see it returns false because here the number iterable is empty. So I hope that I don't need to give more example about any. As you know, any is similar to the all. Only difference is it returns true when one of the element is true. It returns false when all the elements are false. Next built-in function is a is instance, and this function is used to check if an object is an instance or a subclass of a specified type. It returns true if the object is an instance of given type and return false otherwise. And the syntax is you need to pass a two value. First is the object and second is the type. This object can be any object that you want to check, and then this type represent class, type or tuple of classes, and it types you want to check against. So let's take an example. Here I'm going to create a variable called x and assign value 10, and you can see this variable contain integer 10. Here I can print and specify age instance, and then within this instance we need to provide two value. First is the object. So here object is x, and here I want to check if the x is an integer value or not. So here type is integer, and remember in place of type you can specify any built-in data type, subclasses or class. And now execute this, and this function checks that the x is an integer or not. So from the result you can see the x is integer type. Now what happens if I specify here float and execute this? You can see here it returns false, which means x is not float. Let's change back to the int and take one more example, and here I'm going to specify a string which is hello, and then I will check here print is instance, and then to this provide the object or the value that you want to check. So in this case is y, and specify the type. So here type is a str, which means a string. We want to check this value against string type. Now execute this. It returns true because y contains string and we have specified type as str. Now change this string to int and let's see. Execute this. Now it returns false because this y is not an integer. So let's change back to str. You can also use this each instance with the other inbuilt data type. For example, let's create a variable u and include the list of integer value 1, 2, 3. And now here print age instance, then within this provide the object u and the type. So type is here list and execute this. You can see it returns true, which means u is of type list. And now let's change this to dict and execute this. You can see this time it returns false, which means u is not type of dictionary. So let's change back to the list, and similarly you can specify an inbuilt like a dict, tuple and set. Now here I'm going to show you how you can use this each instance with the custom classes. So here I'm going to create a class animal and then simply I will use the pass here, and now create another class dog, and this class will inherit from animal. And now also specify pass here, and then here I'm going to create a dog object called the dog constructor. Execute this. Now I want to check this dog object against the dog class and the animal class. So here specify print, then within print function age instance, then within each instance specify the object whose type you want to check. So it is dog, and then specify the type. So here type is a dog. So we want to check if this dog belong to the dog class or not. So let's execute this. You can see it returns true. Now let's check this dog object against the animal class. So copy it and paste here. Change this dog to animal and now execute this. You can see it is still showing true. And why it is showing true? Because this dog class inherit all the properties from the animal that you can see. So this dog is of type animal also. So this object belong to animal also. That is why we get the value as a true. Now here you need to know the difference between type and the age instance. So this type function returns the exact type of an object, while each instance checks for the type and also supports checking for subclasses that you just saw. Next built-in function is a callable function, and callable function is used to check if an object appears to be callable, meaning if it can be called like a function. It returns true if the object can be called, otherwise return false. So this is the syntax of the callable function, where you will specify the function, then parentheses, and within parentheses specify the objects that you want to know whether it is callable or not. Now let's take an example and understand how this works. So here I am going to create a function def my function like this, and then here I will simply specify pass, and now I am going to print here callable. Then to this callable function I am going to pass this my function. Remember, while passing the function name, do not specify parentheses, just specify the name of the function. And now execute this. You can see we get the error. So here specify parentheses and again execute. You can see it returns true. So here my function is a function, so this callable function returns true. Now let's check with a built-in type. For example, if I will specify here x equal to 10 and here specify print, then within print specify callable function, then parentheses, and then specify x object. And now when you execute this, you can see it return false. So in this case x is an integer and integer are not callable. So this callable function returns false for this x value. Next, let's check if any class is callable or not. So let's create a class and I'm going to say my class like this. and then simply specify pass, and here I'm going to specify print, then callable function parentheses, and within callable function specify the name of the class to see whether it is a callable or not. And now let's execute this, and you can see the class is callable, so we get the result true. And remember, classes in Python are callable because you can create an instance of class by calling the class itself, like using this syntax. So it is callable. Now let's check if an instance of class is callable or not. So let's create an instance of this class, my class, like this, and specify the constructor like this. And now here print callable like this and specify my class. Execute this. You can see it return false. So the instance of the class is not callable. Now here in this case you can see this my class instance is not callable, but you can make this instance callable by specifying a method call in this class. As you can see, there is no any function or attribute in this class. So here remove this pass and specify function def, and then double underscore, then call, and then double underscore, and here specify self, and after this here just print a simple message instance called like this. And now whenever this call method is implemented within any class, then the instance of that class is callable or act as a function. So if I create here new instance, my instance, which is equal to the constructor of the class like this, and now execute this and print callable, and then pass the my instance, execute this. You can see it is still written false because we need to execute this class, and now this time when you execute this you get a true. Why you get true? Because you have implemented a call method within a class, and if you remove this call method from the class, then this instance or this object will not be callable. So comment out these lines and then specify here pass, execute this, and now when you execute this you can see this time, first execute this and then execute this, you can see this time it shows false. So whenever you don't have a call method within the my class, then instance of that class will not be callable. Now let's move and understand how to use the callable method to ensure that an object can be called before actually calling it to avoid error. So for example, let's create function save call, and then this function will accept object, and here I am going to check if callable, then here specify object, and here call the object like this. Then in the else part we are going to specify print object is not callable like this and execute this. Now here this function will accept object and check if that object is callable or not. If the object is callable, then it will call that object using this line. Otherwise, if the object is not callable, then it is going to print object is not callable. For example, call the function save call, and to this function pass the object like a my class, and now execute this. You can see it shows nothing, which means object is callable. Now here again call the function save call, and here pass the value 10 like this and execute this. You can see it says object is not callable. So do not confuse here, because here we are only calling the object, so you don't see any output here, but this means it successfully executed this lines of code. Let's understand the next built-in function filter. and filter function in Python used to construct an iterator from elements of an iterable for which function returns true. It allows you to filter out element from a sequence based on a condition. This is the sequence, and here specify the filter function, and within parentheses you need to provide two values. First value is the function, and this function tests each element of the iterable. It should return true, false. If none is passed as a function, it defaults to bool function, which means it filters out false values from the iterable. And the second is the iterable, and this can be any iterable like a list, tuple or set whose element you want to filter. So how this filter works? This filter function takes this function and applies this function to the each element of the iterable. For example, if you have list and if you have any function, then this function will be applied to the each element of the list. So let's take an example, and in this example we will try to find the even number from the list. So create a function, and function name is even, and then this function will accept any number, and this function will return even number. So if the number is divided by 2, returns a reminder as a 0, which means this number is a even. So here let's create a numbers variable, or it is a list, and then specify number 1, 2, 3, 4, 5, 6, 7 and 8. Now to apply this even function on each element of this list, you need to use your filter. So here create a variable result, then call the filter function, and within filter function, first parameter is a function that you want to apply on each element of the list or the sequence. So here function is each even, and then second is iterable. So here iterable is a numbers. This is the list of the number from 1 to 8. This each even function is applied to each element of this numbers list. Now here print result and execute this. You can see we get an object at this memory location. So the filter returns a iterable, and this iterable is not viewable. That means you cannot view it directly. So you will need to convert this result into another data type. If you convert this result into a list, then you will be able to view all the data. So specify list and pass the result to this list and execute this. You can see you get the result 2, 4, 6, 8, and these are the even numbers. Once again, this filter returns an object, and you will need to convert that object into another data type to view the filtered result. So here I have used the list function, and to the list function I have passed the result, and this result is converted into list. So here we can see all the data of the result object. Now if you remember about a lambda function, and this lambda function is an anonymous function which accepts a argument and a single expression. So instead of writing this whole function, you can specify here lambda function. So what you can do, copy this from here and paste it here. Then instead of each even, you can directly specify lambda function like this, and then specify argument x, then colon, then here expression is x, then x is divided by 2. If it returns remainder equal to 0, then it is an even number. So this is the lambda function, and this lambda function is applied to each element of this number list, and you will get the same result as the previous one that you can see here. Now next, you can filter non-empty string. For example, create a strings variable, and this is going to contain some string like a Python. Then it is also going to contain empty string, and after this specify another string code, and then one more string like a filter, and one more value. So here I'm going to specify none. Now here specify str result and then equal to filter. To this filter, if you specify first function as a none and the second one is the iterable strings, then it is going to return all the non-empty string within these strings. Remember non-empty string, which means it is going to return only the list containing string and it will remove all the empty string or the false value. So here print, then call the list function, and within list function pass the str result like this. Now execute this. You can see it returns non-empty string, and also you can see it removed this empty string and this non value. And remember, this non means false or it is false value. After filter function, next built-in function is a map function, and this map function in Python applies a given function to all items in iterable like a list, tuples, and returns an iterator with the result. It is a useful tool for transforming or processing each element of an iterable in a functional programming style, where you will input several values. So this is the map function, and within parentheses, first value is the function that you want to apply to all element of iterables, and then second itself is iterables, and remember on this iterable this function is applied. So here you can specify one or more iterable to which function will be applied. If more than one iterable is passed, the function should accept that many argument. So in case of filter, we can pass only one iterable, but in case of map, you can specify as many iterable you want to. Remember, each iterable is separated by comma. Now let's see with an example how map works. And one thing remember, map returns a map object which is an iterator. So here I'm going to create a function def square, and this function will square the given number. So it will accept that number as an input, and then it is going to return x into x. Now here I'm going to take example of number, and this is the list of number, and this is the 1, 2, 3, 4. Now here create a result variable to store the result and then call the map function. Then within map function, first parameter is the function that you want to call on each element of the iterable. So the function is square here, and after this you need to specify iterable. So iterable is a num. Now let's print result like this and execute this. You can see it returns map object at this memory. So here we will need to convert this result, specify print, then list, then to this list pass the result. Execute this, and now as you can see it returns the list containing the square of the element. So here you can see the square of 1 is 1, but square of 2 is 4, square of 3 is 9, and the square of 4 is 16. Here map function applies this square function to each element of this list. So again, here we are using the regular function, but we can also use the lambda function here. So for example, copy this one and paste it here, and now specify here lambda function, lambda, and then x, this is the argument, then colon, then it should return x into x. And remember, while using the lambda function, we don't need to specify the return keyword as we have specified here, because it returns the result automatically. Now also convert this into a list to view the result returned by the map function and execute this. You can see we get the same result as the previous one. And as I told you before that you can use the multiple iterable with the map function. So for example, here I am going to create a second iterable num2, and it is going to contain a different element like a 5, 6, 7 and 8. And now here create a variable result2, then call the map function. And here this time I want to add or apply the add function to both the iterators. So here specify lambda, then x and y, and it is going to return x plus y. After this, specify both the iterator num and num2, and next to it print the result. So specify list, and then to this list pass the map object or the result from the map. Execute this, and now you can see it add both the numbers. So if you are confused, then go up here. You can see here this is the num1, and this time this 1 is added to this 5. So in the result we can see it is a 6. Then this 2 is added to the second element of num2, so we get the 8, and so on for each of the element. So this is how you can use the multiple iterator with the map function. And here if you have any confusion about the filter and map, so remember, filter only filters the element that satisfies the given condition. In case of map, the function is applied to all the element of the iterables. Next inbuilt function is a sorted function, and this function in Python used to return a new sorted list from the items of any iterable like a list, tuple, set and dictionary. And this sorted function returns a new list without modifying the original iterable. So this is the syntax of the sorted function. Specify sorted, then within parentheses you need to provide the first parameter or the value is the iterable, and this iterable is a sequence or collection like a list, tuple, dictionary, set that you want to sort. And the second is the key, and it is the optional. So this key is a function that extracts a value from each element to compare for sorting. This is typically used when you want to sort by a specific attribute or a custom criteria. Then we have another parameter or the value reverse, and this is the Boolean value, which means it evaluates to true or false. So if it is true, the sorted list is returned in descending order. The default is false, which means list is sorted in ascending order. Let's take an example and understand how this sorted function works. So here I'm going to create a variables or list numbers, and this list is going to contain a random number like a 3, 1, 8, 2, 0, 5. And as you can see, there is no order in these elements. Now if you want to sort this element in ascending order from smaller element to largest element, you need to here use the sorted function. So create a variable sorted numbers like this equal to, then call the sorted function, and to this sorted function pass the iterable numbers. Then here print sorted numbers. Execute this, and now you can see it returns new sorted list. And as you can see, this list is sorted in ascending order because first element is 0 and last element is 8. So first one is the smaller and the last is bigger. It is going from smaller to bigger. Now you can sort this in ascending order. To sort the same thing in ascending order, let's copy this one, paste here, and as I told you, you need to provide the parameter reverse, and this reverse will sort this list in descending order if we specify here true. So execute this, and now you can see this list is sorted in ascending order from bigger element to smallest element. Next, let's see how we can sort the string. So here I am going to create a word variable, and it is going to store the string Python. And now you can sort the each character of this string using the sorted function. For example, create a variable sorted word like this equal to, then call the sorted function. To this sorted function pass the string, and then print sorted word like this and execute this. Look, it sorts each character of the string. But if you notice it closely, the letter P is not sorted. But after all the letters which are in small case are sorted in alphabetical order. Let's change this P to small case and now again execute this, and now you can see all the elements are sorted in alphabetical order. Now let's take one more example, and in this example we are going to use the second parameter, key of the sorted. So here let's create one more list, words, and this list is going to contain a string like a apple, then banana, and third string is a kiwi, and the last one is a grape. So here I want to tell you can sort the element based on their length. So here create a variable sorted by length and then equal to call the sorted function, and to this sorted function specify the iterable which is word, and then you can use here key, and as you know key accept a function. So here I am going to use the len function, and you already know about this len function. This len function return the length of the specified objects or variable. So this sorted function will sort this list based on the length of the each element. So let's print, and here specify sorted by length and then execute this. You can see string is sorted based on their length. For example, if you look at the first string, you can see it consists of 4 characters, and the apple is consist of 5 character, and grape is also consist of 5 character, and you can see here banana is consist of 6 character. So it sorts the string from smaller to bigger based on the length. Let's take another example, and here let's sort the list of tuple by specific element using key argument. For example, create a tuple pair equal to 10 within the square bracket specify tuple. So first is the 1 and 2, second tuple is 3 and 1, third tuple is 5 and 7, fourth tuple is 2 and 0. Now here create a variable sorted pairs equal to call the sorted function, and to this sorted function pass the tuple that you want to sort, so pass the pairs. And now specify key, and you know key accept a function. So here let's build a function, and that function will sort the tuple based on the second element of each tuple. So look, the second element of first tuple is 2, second element is 1, and third is 7, and fourth is 0. So here you can use the lambda function and specify x then colon, and you know 0th is a first element of tuple and 1 is the second. So we want to sort the tuple based on the second element. Here print sorted pairs like this and execute this. Look, you can see tuple is sorted based on the second element of each tuple. You can see here. So if you look at the second element of each tuple, 0, 1, 2, 3, and if you specify here reverse equal to true and execute this, look, it sort the tuple based on the second element in descending order. So first element is 7, then 2, then 1, then 0. Similarly, you can use the dictionary, and based on dictionary key you can sort the dictionary. So I hope that you understand how to use the sorted function to sort the different kind of values. Next inbuilt function is a eval function, and this function takes a string as an input and evaluates it as a Python expression. It executes the expression and returns the result. This can be useful for a dynamic execution of Python code, but it also requires due to security risks if the input is not trusted. And this is the syntax: specify eval, then within parentheses specify expression, and this expression is a string and it is a valid Python expression. This expression can include variables, arithmetic operation, functions call, or any other valid Python code. So here let's see with an example. Now I am going to create a simple variable x with value 10. And now here I'm going to create a variable result to store the result, then call the eval function. So here you need to pass the expression as a string. For example, if I specify here x plus 5, then this string is evaluated as an expression x plus 5. Remember, this line is equal to print x plus 5. So here let's print result like this and execute this. Look, it adds the 5 to the x, which gives a 15. So you can see this eval function automatically know this is the variable and it has a value 10. So we need to add this 5 to 10. So it automatically deduct that this is the expression. Now let's take one more example, and here we will build a expression. So name it expression, and it is equal to 3 into, then within a parenthesis specify 2 plus 1 and close the string. Now you can see this is the string, but eval function will evaluate it as an expression. So create a new variable result xp equal to eval, and now to this eval function pass that expression like this. Now here print, within print function specify result expk like this and execute this. Look, it returns the result 9. So this is how amazing eval function is. You can convert a string into a Python valid expression and get a result. Now let's see how this eval function work with functions. So create a new function add, and this function is going to accept two parameter x and y, and then this function is going to return x plus y like this. Now here build the expression xp equal to, then here call the function add and give the argument 3 and 4, and as you can see this is the complete string. Now here create a variable res to store the result and call the eval function, and to this eval function pass the expression exp, and now print res here and execute this. Look, it calls the function and add the two value and then return the result 7. Now let's take one more example, and here we are going to take the input from the user and then evaluate that input as an expression and return the result using the eval function. So here specify while, then true, then here it is going to take user input equal to input, and then here specify enter the math expression like this, and then here we are going to print, and to this print function specify eval function, and to this eval function pass the user input. Now execute this, and here specify math expression like 2 into 3 and hit enter. Look, it returns 6. Specify 4 minus 5 and hit enter. Look, it returns -1. Specify here 4 divided by 2, and look, it divides and return the result 2. So this is how amazing eval function is, which convert a string into a Python expression and then return its result. So here eval function allows for a dynamic execution of Python code, but comes with a significant security risks if the input is not controlled, and you must use this carefully, especially when evaluating input from the user or the external sources. Next function is an inbuilt function called execute function or xkey, and this xkey function is similar to eval function, but it takes a block of code in the form of a string or compiled object, and it does not return any kind of value like a eval. So this is the syntax of xkey, and which accepts a object, and this objects contain a string, and which is a multi-line of a Python code. So let's understand how to use this execute function. So here I'm going to create a variable x equal to 20 and then y equal to 30. And now you can write here print x plus y like this, and it is going to, so here we need to stop this input. So what I will do here, I will go here and restart the kernel. Now execute this code and you can see it returns 50 and this line adds the xy value. So in case of execute, you can pass whole Python statement as a string to the execute function. So here create a code variable, and to create a multi-line string you need to use the triple double quotation. And then here I am going to copy this Python statement and paste here. And now specify here triple double quotation like this. Now you have created a string with multi-line, and this string contains a Python code. Now here you can specify result, and result is equal to x key, and then to this pass the string code. And now print here result like this and then store it here. So here you can see it returns known, because here this x key function, after performing operation or executing the statement, returns the known. So when we print result, it shows known. But if we remove this and execute again, you can see it prints the result, because it executes all the expression or the statement that we have specified within the string. So I hope that you understand why to use the x key. So there is one difference between evaluate and x key. Evaluate takes a single expression and returns the result, but in case of execute or x key, it takes a block of code as a string but does not return a value. Simply it executes a Python code as if it is a regular Python code. Moving next, we have an inbuilt function zip function, and this function takes a multiple iterable objects like a list, tuples and string, and then combine those objects into as tuples. And this zip function returns a result as an iterator of tuples. This is the syntax of zip, and which accept iterator, and it can be multiple iterators. Let's understand with example how to use this zip function. So for example, here I am going to create two iterator or two list, and this list is going to contain elements like a 1, 2 and 3. And let's create a second iterator or second list, and this list will contain a string A, string B and string C like this. Now to combine both the list into a tuples, let's use here a zip method. So create a zipped variable and then call the zip method, and to this zip method pass the list 1 and list 2. And now let's print list zipped like this, and when you execute this, you can see it returns a list containing a tuples. So here zip function pair the first element from the list 1 with the first element of list 2. Then it again pairs the second element from the list 1 with the second element of the list 2 that you can see here. So you can see this is the first tuple, and this one is coming from the list 1 and the A is coming from the list 2. Then this is the second tuple. This contains the second element of list 1, and then again B, it is a second element of list 2, and so on for other elements. Now here I want to show one thing, what happens if one of the list is shortest. So let's also check that. So here I am going to copy this whole code and paste it here, and this time I am going to remove C from here, and you can see the second list is a shortest list. Now let's execute this and see. And as you can see, it returns a list of tuples where it only contains the 2 tuples. Since list 2 has only 2 elements, the pairing stops after the 2 iteration, so that this list contains only 2 tuples. So instead of list, you can use here dictionary, sets, and tuple. That is iterable that you can iterate, and this function combine those iterator into a tuples. So this is all about a built-in function in Python, and I hope that you understand each and every function. In this section, we are going to understand docstring. So what is a docstring? Docstring, short for documentation string, and is a special type of comment used to describe the purpose, functionality, or the uses of module, class, methods, or function. It is written using a triple quotes. You can use either double triple quotes or single triple quote, and it is placed right after the definition of the object it describes. Docstring are useful for improving code readability and are often used to generate documentation automatically. Let's see with an example how to specify docstring for a function. So suppose here create function add, and this function accept a two parameter. Parameter is a and b, and now here you can specify function docstring, which defines what kind of parameter this function takes and what it will return. So here to specify the docstring, you can use either the double triple quote or single triple quote. So here we need to specify multi-line string, so we will use the triple double quotes like this. And now within this we can specify our multi-line documentation. So here I am going to write this function takes two numbers as input and returns their sum like this. And after this I will specify the parameter the function will accept. For example, specify here parameters then colon. And now first parameter is the a, and it can be type int or float like this. Then this is the first number. Then we provide the second parameter, and also it can be int or float, and this is the second number like this. And after that I will specify return type of this function or what the function will return. So here returns, then it can return data type of int or float, and this returning data is the sum of two input numbers. And then right after this function will return, then after this we need to specify return type, return a plus b. So in this example, the docstring explain what the function does and the parameters and what it returns. And let's execute this. Now here one thing I want to say, you can access the docstring or documentation string using the help and doc attribute. So for example, if you specify here help and within the parentheses pass the function add and execute this, you can see it returns all the documentation string that we have written within the function here. Let's take one more example, and here I'm going to create a class and I will show you how you can specify docstring in a class. So I'm going to create a class doc, and then in this class to specify the docstring, specify triple double quotation, then within this specify multi-line documentation string. So it is a class used to represent a doc. Now I'm going to initialize a method also here. So I will specify def, then init method, and this method will accept parameter self, name, age, and then initialize the parameter or the attributes name equal to name, self dot age equal to age like this. Then it is going to have a method dot bark and self, and then here it is going to print within this specify dog name self dot name, and then age barking. Now here we have specified a class is used to represent dog, and after this we can specify documentation about the attributes that we use in this class. So specify attributes, then specify the name of the attributes and the type. So the name type will be string, and this is the name of the dog. Second attribute is age of type int, and this is the age of the dog, like this. Then we have methods, so specify the methods, and then here the method name is the bark, and it prints the dog's name and age barking, like this. So this is how you can specify doc string for the class, and you can see doc string tells about the class and what are the attributes and what are the methods. So in other words, the class dog has a doc string explaining its attributes and methods. So doc string are good practice for documenting Python code, provide detail on how your function and classes work, and enhancing overall maintainability. Next, let's understand fstring. So fstring stands for formatted string literals, and it provides a concise and readable way to embed expression inside a string literals using a curly braces. And it was introduced in Python 3.6, and fstrings are prefixed with a small f or a capital F that you see here. So you will need to specify a small or capital F before the string. It allows you to directly include variable expressions or even a function call inside a string, making string formatting more intuitive. Let's say with an example, create a variable name and assign a string alias like this. Then age of the alias is 30. So here we have a two variable name and age. If we want to print the value without formatting, we can specify here a print function, and within print function we can use the variable like this. But we want to format it, we can use here fstring. So to use the fstring, you need to prefix f. So specify here f, and then either you can use the double quotation or single quotation for the string. So here I am going to use the double quotation. Now here I will specify string my name age, and then I want to insert the value of this name variable. So for that, specify curly braces. Remember to insert the expression, function, anything with a string, you need to use these curly braces. Then within the curly braces, specify the variable name. And after this, I want to print a regular string like and I am. Then here I want to insert the age. So again, specify curly braces, and within this specify variable age. Then string years old, like this. So when you execute this, now you can see my name is Alice and I am 30 years old. So you can see here these two values, Alice and 30, it's stored in the variable name and age, and we get this value within the string by specifying curly braces like this. And remember, if you remove this f, it will not work. Execute this, you can see it is not working. So you need to prefix the string with f like this, then it will work. Let's see how we can embed an expression. So here I am going to specify with it equal to 5 and height equal to 10. And then here I will create a new variable area equal to, then specify f, then double quotation. And within this, I'm going to write the area of the rectangle age. Then here I can perform arithmetic operation. So within curly braces, specify with it into height like this. So you can see this is the Python code that will multiply with it with height. So we can do that within the string by specifying these curly braces, and then square unit, and let's pass this to a print function like this. And when you execute this, now you can see here, make it area. Now execute this, and you can see here the area of the rectangle is a 50 square units. So this is how you can specify the expression or embed or insert the expression within a string with the help of fstring. Now next, let's see how we can format numbers in fstring. For example, if here I have a pi value like a pi 3.1415926 like this, and I don't wanna these decimal places, I want only 2 decimal places. So we can use here a round function, or we can format this using this fstring concept. So here I will create a variable formatted pi like this, and then specify f, then double quotation, and within here I will say pi to 2 decimal places. So here I'm going to round the pi to 2 decimal places, and for that you need to use the curly braces. Then within here specify the value pi, and after this, to format this pi to 2 decimal places, specify colon, then dot, then 2, then f like this. So this part will format the number to 2 decimal places, remember. And here let's print formatted pi and execute this. You can see here it formats the number to 2 decimal places. If you want format to 3 decimal places, just remove this 2 and add 3.3f like this and execute this. Look, this time it contains 3 decimal places. Want 4 decimal places, specify 4 here, execute this. Now you can see 4 decimal places. So this is how you can format the string in fstrings. You can also call a function as I told you. So create function def to uppercase, and then this will accept a text, and this function will convert the text into uppercase. So text dot upper, and now here I am going to specify the name, and I will specify the name Bobby in a small letter like this. And remember, we can call this upper function. This is the inbuilt function, and you can call it on string to convert that string into uppercase. Now here I'm going to use the print function, and within print function specify fstring, and here you can say hello, then within a curly braces specify the function that you want to call to upper case, then here pass the name variable like this, and now execute this. Look, we call the function in a fstring and it is working fine, and it outputs hello Bobby. Also you can see this converts the letter to uppercase. So fstrings offer a clean, readable and efficient way to format a string by embedding expression directly. They allow variable interpolation, expression evolution and formatting controls in simple syntax. Let's understand assertion in Python. Assertion in Python are debugging tool used to test whether a certain condition is true during the execution of program. The assert statement checks if condition is met, and if it is not, it raises an assertion error with an optional message. This is the syntax of the assertion. So here we need to specify assert keyword, and then we specify the condition. This condition is evaluated to true or false, and then we have the optional message, and it is a string that is displayed when the assertion fails, providing information about the error. So let's understand this assertion with example. And remember, this assertion is used in a development environment, and this assertion is used by developer to debug the error. So here I'm going to create a variable x and I will assign value 10, and then variable y assign value 0. And now here I will specify result, then equal to x divided by y. Here I will print result, and as you can see here, this expression will raise error because you cannot divide any number by 0. So here we can assert or test the value of y, so it should not be 0 before performing any division. Here you can specify keyword assert, and you will always specify this assert keyword, and then we need to pass the condition. So here condition is y is not equal to 0, like this, and after this specify comma, and if y is equal to 0, when this assertion condition become false, in that case it is going to raise error with message y should not be 0 for division, like this. So remember, after the assert keyword we have specified condition, and this condition is evaluated to true or false. So here it is checking y is not equal to 0. When y is not equal to 0, then condition become true, then it perform the division. If the y is 0, then condition become false, then it raises assertion error. Let's see it and execute this, and you can see here we get the error. So here we need to wrap it with a double quotation, and now execute this, and you can see we get the error, assertion error, and y should not be 0 for division. So what happens if you specify here 1 and execute this, and now you can see you get the result. So in this case y is not equal to 0, which becomes true, so it executes the expression. But in the case of 0, it raises error because here this condition become false, so we get this optional message with the error. So this is how you can use the assert function in development environment to debug the error, to find any issue with your code and fix that issue immediately. So you can use this assert function inside a function also, and syntax is same, and you can specify here function, and as I already told you about truthy and falsy value, so as a condition you can use those values here, and then assert function will work as you defined. Moving next, let's understand unpacking. What is unpacking? Unpacking in Python is a process where elements from collection such as a list, tuple or dictionary are assigned to variable in single operation. It allows you to extract values from collection and assign them to individual variables easily. This makes code more concise and readable. And remember, unpacking can be done with various types of data structure including list, tuple, dictionary, even a nested structure. Let's see how to do unpacking with tuple. For example, here I am going to create a tuple coordinates, and this tuple is going to contain 3 values, 3 coordinates, 10, 20 and 30. So in general, if you want to store this value in variables, you can create here variable x, then assign value 10, then create a variable y, assign value 20, then create a variable z and assign value 30, like this. But using the concept of unpacking, you can unpack these coordinates into 3 variables without assigning values like this. For example, specify x, then comma y, then comma z, like this, then equal to, and then specify here coordinates or the tuple that you want to unpack, or the tuple whose element you want to assign to a single variable. And remember, the number of element should match the number of variable. So here specify print x, y and z, like this, and execute this. You can see it returns value 10, 20, 30. So this coordinates or this tuple is unpacked, or the elements of the tuple is assigned to each variable separately or individually. Now if you print the value of x individually like this, print the value of y, then print the value of z and comment out this line. Execute this. You can see 3 variable x, y, z contains the coordinates from the tuples. Now similarly, you can perform the same operation or same unpacking with the list. For example, here I am going to create a list numbers, and this list will contain 1, 2, 3, and then you can specify here variable a, b, c equal to numbers or equal to the list, and let's print here, print a, print b, print c like this, and execute this. Look, list is unpacked to a variable individually. You can also use the star or asterisk for unpacking. So this operator can be used to capture excess item in a list or tuple during unpacking. For example, suppose here I am going to create a sequence, and then this sequence will contain a number from 1, 2, 3, 4, 5, 6, and 7 like this. Suppose I want to assign 2 elements to 2 variable and rest of the element to third variable. For example, here I am going to create a variable a and b. So if I will write like this, sequence, then here what I means, I want to assign a first value of sequence to the first variable and second value of the sequence to second variable, and rest of the value or rest of the portion to a third variable. So how can I do that? I can do that using the asterisk or star operator and then specify the variable name, which means first value or element will be assigned to A, second will assign to B, and rest of the from 3 to 7 will assign to C. Let's see here. So here I'm going to print A, print B, and then print C like this. And now execute this. You can see. So A contain first, B contain second, and C contain all the rest of the element in the list. So this is how you can use this asterisk. Now you can also specify the middle of the portion, like from 2 to 6, and then assign this one to first variable and this one to last. So for that, specify here first, the variable is first, and then here specify asterisk and call it middle, and after this specify comma and specify last, then equal to sequence like this, and here print first, then print middle, and then last like this, and execute this. You can see the variable first got the first element, and variable middle got all the middle element from 2 to 6, and variables last got the 7. Here first element is assigned to first variable and last element is assigned to last variable, and all the rest element are assigned to this middle because of this asterisk. Now let's understand how to unpack the dictionary. So dictionary has a special methods like items, keys, and values. You already know about these. So using this, we can unpack the keys or values. So for example, here I am going to create a dictionary student, and here I will specify 2 keys. First is the name of the student, which is the James, and second is the age. So make it a string, and then age is 25. Let's also add one more, which is a grade of the student. So here grade is A. Now here you can grab the key value as a tuple. For example, if you print here, print student dot items like this and execute this, you can see you get the dictionary as a tuple. So what you can do here, you can use the for loop to iterate over a key and value. For example, specify here for, then we want to iterate over key value. So specify key value, which means this item gives you the key and value as a tuple. So we can access the key value by specifying key value, or you can specify any variable name here, but you need to specify two variable name here. And then in student dot items like this, and after this we can print key and the value like this and execute this. You can see it prints name John's, age 25, and grade is A. So these items return all the key value pair as a tuple, and then we are grabbing the tuple first and second element using this key value variable. Now let's see how we can unpack dictionaries values into variables. So here I can unpack this student in variables. For example, here I can create a variable name, then age, and then grade like this, then equal to, here I will specify student, then dot values, and values will return all the values of the key in the dictionary. And here print name, print age, and print grade like this. Execute this, and you can see it retrieve all the values from the dictionary and assign to each variable individually, or unpack to each variable individually. Similarly, what you can do, you can also unpack nested structure such as tuples list within other tuples or list. For example, here I am going to create a person, and this person will contain name as a zone, then again it is going to contain tuple, and this tuple will contain first value as a 28 and the second is the engineer. And remember, this is the age of the John and this is the profession of the John. But here you can see, here I have used the tuple, and within tuple I have used another tuple. So this is the nested structure of the tuple, and we can unpack this also. For example, here I am going to specify name, then comma. So the first value of the tuple will be assigned to this name variable, and after this we have another tuple, and look at the structure. So similarly we will specify here age and then profession like this, and after this equal sign and specify person. So this part is assigned to these variable within parentheses, and this one is assigned to this name variable. Let's here specify print name, print age, and you can see it prints the name and age. Now if you specify here print profession like this and execute this, we get the error because we made a mistake here. Fix this profession and execute this. Look, it returned profession as the engineer. So using a tuple we can unpack the nested structure into a individual variables. Let's understand some basics logical operators, and these logical operators are and, or, not, in, and is. Let's start with the logical operator and this operator is used to combine two or more conditions and returns true or false. If either condition is false, then it returns false. If both condition is true, then it returns true. So let me show you with an example. Here I am going to create a variable x and I will assign value 5, variable y and assign value 10. And then here I am going to use the if, and here I can combine two conditions. I can say here x is greater than 0 and then specify AND keyword and say y is greater than 5 like this. So here you can see this is the first condition and this is the second condition, and then next to it I am going to print both conditions are true, and I am going to also use the else part, and here I am going to print both conditions are not true. Now execute this, and you can see in this case it execute the if block, So here the first condition before the AND becomes true and the Y condition after the AND becomes true. So both condition becomes true. So AND returns true, then this block is executed. And if any of the condition become false, then it execute the else part, because in case of AND, if any of the condition is false, then it returns result as a false. For example, if you will say here x is less than 0 and execute this, and look, it executed the else part, both conditions are not true. So in this case, this part or this condition become false, so it returns result as a false. So in case of false, will not execute this. So in case of false, this block is executed. And you can combine any number of conditions. You can specify here again and specify condition z is greater than 5, and here let's create a z is equal to 20 like this, and also change this one. And if these three becomes true, then this block is executed, otherwise else block. So let's execute this, and you can see it return both conditions are true. So it means this one becomes true, this one also becomes true, and this one true. If any of them become false, then it is not going to execute. Let's make it less than and execute this. Look, it execute this block because this condition become false. So in case of AND, every condition should be true for the true, and if any of them become false, then result will be false. Next, let's understand the OR operator. So this OR logical operator is used to combine two or more conditions. It returns true if at least one of the condition is true. It only returns false if both conditions are false. So for example, here I am going to specify x, and then here I will say x is greater than 0 or x is a less than 0. And here I can print x is greater than 0 like this. And then here I will specify else block, and it will print x is not greater than 0 like this. Now execute this, and look, it execute the block of code from the if, because here the if gets the true value. So here you can see this part, this one, x is greater than become true, and after the OR keyword, this condition become false. So according to the OR definition, if any of the condition is true, then it returns true. So this whole part returns true because first condition is true. So this block is executed. And if it is false, let's say here I will again specify x is less than 0, and then both this condition, this one and this one is false, so it will return false. And if condition will not execute in this case, let's see, and you can see the else part is get executed if is not executed. Now let's understand next logical operator called NOT operator, and it is the negation operator. And what it does, it is used to invert the truth value of condition. That means if condition is true, it can convert that condition into false, and if condition is false, it can convert that value into true. Let me show you how you can use this. For example, here I am going to define variable boolean data like this, and here I will say x is greater than 0, and which is so true because here we have defined x is 5, so x is greater than 0, it is going to return true. Specify here print, then boolean data like this, and execute this. Look, it returned true. But if you want to invert the condition or boolean value, just specify here not, and then execute this. You can see it returns false because this condition evaluate to true, but as soon as you specify not, then this true is converted to false, so we get the false. Similarly, if we will say x is less than 0, so here this condition is false. Remove this one first. Let's execute this, and you can see it returned false because here we have defined x is 5, which is greater than 0, so this condition is evaluated to false. As soon as we specify not and execute this, you can see it inverted the value from false to true. So I hope that you understand how to use this not logical operator to invert the truth values from false to true, true to false. Now the next operator is the in operator. What it does, the in operator is used to check if value exists within sequence like a string, list, tuple. It returns true if the value is found and otherwise false. So for example, here I am going to create a list fruits equal to, then include several food like a apple, then banana, then cherry, and now here you can look if banana in fruits like this, then print here banana exist like this. Here you can see we use the in keyword, and this in keyword will check if this banana string exists in this fruit or not. If exists, then it is going to return true and this block is get executed. Let's execute this, and you can see it returns banana exist. This means this string exists in fruit, so this whole line returns true. Also, you can use the not operator with in here. You can specify here if grape not in fruits, then print here grape does not exist like this, and execute this, and look, we get the error. So here we need to specify this one and execute this, and you can see here grape does not exist. So you can use this not with in, so it will check for non-existence of this string. And lastly, we have the logical operator called is operator, and this is operator check if two variables refer to the same object in memory. Remember, refer to the same object in memory. It compares the memory location of two objects, not just their values. For example, here you can create a variable x and assign value 20, and create a variable y and assign value 20. And if you specify here if x, then you can specify here equality operator and y. So what it will do, it is going to say variable value are same like this, okay? Otherwise it will say variable values are not same. Let's execute this, and in this case you can see variable values are same because you can see x and y contain same value. So we use here equal operator. What happens if we use here is and execute this, and you can see we get the same result. That's okay. But here it compares the location of the memory in this case. Let's create one more variable. Understand this. Here I'm going to create variable a and specify some value like 1, 2, 3. And then also create another variable and specify same number of value 1, 2, 3. And you can say this both variable is same. So let's check if a is b, and then I'm going to print here a and b refer to the same object like this, and also specify the else part, else, and then print a and b refer to different object. Now execute this, and look, here it returns a and b refer to different objects. But as you can see, both the variables or list contain same value, and here in this case we get the output like a variable values are same. So why we are seeing a different value? So here I told you this is compare the object memory location, not the value. When we use here double equal, it compares the value within this variable. So in this case the values are same, so it returns variable values are same. But in this case, it does not compare the value of the variable, it compares the location. So if I will print here ID of A and then print ID of B, execute this, and look, the ID of both the variables or both the list is different. So this is compare these values, not the values that is assigned to this variable, not the value which exists in the variable. It compare the memory location that you see here. So in this case, we get the A and B refer to different object. I hope that you understand when to use this equal operator and when to use this is operator. So this is all about logical operator in Python. In this section, you will understand how to handle file in Python. So handling files involve reading from and writing to file, which allows you to work with the data that persists outside of your programmer's runtime. So the file that exists outside of your script or program, you can work with that files. And these files can be a text file like a .txt, .csv, or it can be a binary files like an image or audio. So in Python, before working with files, you need to open the files. So to open the file, Python provides a function called open. And this function accepts a two parameter, the file and the mode of the file, which means how you want to open the file. So let's see how to open a file. So to open a file, you will need to provide different mode, and first mode is the R mode. And this mode means open the file for reading. If the file does not exist, then it raises an error. Second mode is a W mode and it is called write mode. This opens the file for writing and it creates a new file if it does not exist or truncates the file if it exists. Then we have the mode A mode, and this mode is called append mode. And this opens the file for appending, does not truncate the file, remember. Then we have a B mode, which stands for binary mode, and it is used in combination with other modes for handling binary files. And then we have X, and this is called exclusive creation, and it creates the file and raises an error if the file already exists. Let's take an example and understand how to work with file in Python. So currently we do not have any files in our home directory. If we go here, we can see. So let's create a new file using this Python function. So here I'm going to specify file variable equal to, then call the open function. And as you know here, we can use this X to create a new file. So here I'm going to specify the file name data.txt, and then I'm going to specify mod as X like this. And now let's execute this, and this creates a new file. If we go to home and reload this, we can see here we have a new file data.txt. And if you have any confusion about where these files are created in your directory. Let me show you this file on my computer. So here you can see I'm running this Python tutorial IPNB file, and the file that we have created, data.txt file, is in my Python directory, you can see here. Now, one thing you must always remember, whenever you open file in any mode, you need to close that file if you don't need that file anymore. So to close the file, call the method .close on that file like this and execute this, and file will be closed. And when you close the file, it releases the used resources or resources held by this file object. Now we have created a data.txt file, but this file does not contain any data. We can write a new data to this file. So again, specify your file to, and then open the file in write mode. So first specify the file that you want to open in the write mode, and then specify the mode as W, and W represent writing mode, and execute this. Now your file is opened in writing mode. We can write some data to this file. So to write some data in this file, we have two methods provided by file. First is the write method, and this method writes a string to the file, and second is the write lines method, and this method write a list of string to the file. So first, here I am going to specify file 2.write method, and let's write a string to this file. So here I am going to write a simple string, I am learning Python, and now execute this. It returns a 20 character because the length of the whole string is 20. So which means this string is written to file. Now close the file 2 like this, and now open again file in a writing mode. So here specify file 2 equal to open, then specify the file that you want to open in writing mode, and here specify mode as R and execute this. Here specify txt, and now again execute this. Now we have opened the same file in reading mode this time. So here, to read any line from the files, we have a method, and the method is the read line, and this method reads the entire file as a string. So let's specify here file 2 dot read line. This should be line, not line, and here execute this. You can see it returned the string that we return to that file, and that is I am learning Python. Now let's close this file again, file 2 dot close like this, and here I am again going to open this file 2 file in writing mode, and this time I will use the write line function. So here again open this in a writing mode, and then here call file 2 dot write lines like this, and here within this we can provide a multiple string. For example, we can provide a list of string, specify square bracket and provide James, then another string Rock, then another string Bob. Execute this and then close the file 2 dot close again, and file is closes. Let's again open the file in read mode. So here I'm going to copy this one and paste here. It is opened in a read mode. Now here specify file 2 dot read line, and as you can see it returns James Rock Bob. Also you can specify here file 2 dot, and then we have another method read lines, and this reads all the line and return list of lines. So here execute this. You can see it returns empty list. So let's go back here, and here I'm going to close the file 2 dot close and execute this. I'm going to again open the file in writing mode. So execute this line, and then to this list I'm going to add an additional string, and this will be inserted in next line, and this is the name of the users like this. And instead of this /n, as you know, this /n insert a new line. So from here I'm going to specify at this position /n like this. Now execute this and then close the file. Now again open the file in read mode using this statement and call the read line, and you can see it shows only a single line. Now again specify here read lines, and this time you can see it return the next line of code. This is the name of the user, and let's close the file. Now next let's understand how to append data to the file. So what we will do here, we will open file in append mode and add a new data at the end of the file. So you can see this is the end of the file, which means this string exists at the end of the file. So after this we can insert some of the new data, and for that let's open the file in append mode, specify open function, then the file that you want to open in append mode, and then specify mode as A, which stands for append. Now file is open in append mode, then let's write something file.write, and this function write a single line of data. So here I am simply specifying appending a new line like this, and then /n for the new line like this, and next to it I'm going to close this file like this and execute this. Now again I'm going to open the file 2 in a reading mode. So open, then data.txt, then open in read mode, and after this I'm going to specify read lines function to read all the line as a string, and then I'm going to close the file like this. Execute this, we get the error. So first remove this and execute this again. Let's fix this error. So here we are referring to file, but it is file2, and again here specify file2 dot close like this and execute this. You can see it shows nothing, so let's remove this and execute this again, and you can see it shows all the string within the file as a list of string. And remember, we have added this one, appending a new line like this. You can see here when we append, the string is added to the end of the file. Now let's close this file2 dot close like this, and file is closed. Now here I want to tell you one thing, that whenever we open the file, we are calling this close method again and again each time to close the file, and that doesn't seem good. So in Python you can automatically close files. So in Python, to ensure that files are properly closed, it is best to use the with statement, which automatically handles closing the file even an exception occur. So here specify the keyword with, and then specify the function open, and then here specify the file that you want to open like this, and then specify the mod, which is R, and here specify the file name. And what this line does, it open the file in read mode and return the file object or file reference using this file name. Whenever we perform any operation in file, like we perform write operation or read operation, after operation it automatically closes the file. We don't need to call file.close function to close the file. So here I am going to specify content, and then here I will say file.read, and then simply it will print the content values. This line will read the line of string from the file and store in content variable. And now execute this, you get all the data of the file. So here using a with statement, we can automatically close the file after performing some reading and writing operation. Now next mode is the binary mode, and you can open a non-text files in a binary mode, and this file can be like your image file and audio file. Let me show you how you can open this file. Let's specify with, then specify open, and within open specify the file that you want to open. So in this case I am going to open the file image.jpg, and I want to open this file in reading, writing or appending mode, but this file is a binary file. So here I am going to open this binary file in reading mode. I will specify here mode as rp, and then as file colon, and now here I can read the content of the binary file, specify by file.read method, and then print the content like this. And here RB represent a open file in reading mode. And if you specify here a W, which means open the file in a writing mode. So this open the binary file in writing mode. Remember here B represent binary. So here this function consider this image.jpg file as a binary. Now if you execute this, you get the error read, because we do not have any file here like image.jpg, or the file does not contain any of the binary data. So here we have specified WB, which means open file in writing mode, or in this case we do not have any file. So this mod W will create a new file in our directory. If we go back at the home, we can see it created new image.jpg file. So that this read method raise error unsupported operation. Now let's go here and change it to R, and here I'm going to delete this file, and at this moment we don't have any file name image.jpg. Let's open this file, execute this, and you can see we get the error file not found error. So here I want to show you how you can handle the file exceptions. For that you can use try except block. So here specify try, and then move this code to the try block like this, and after this specify except block, and then specify the error. So error is a file not found error, and I want to print file does not exist. And this message will be shown to the user. Now let's execute this. If we can see, we get the message file does not exist because the file that we are trying to read in binary mode does not exist. So I hope that you understand how to open the file in binary mode and how to handle any of the file exception that occurs. So at last, I want to say don't forget to subscribe my YouTube channel, and thank you.